All right, another week, another new app. So this time we're building a quiz app called Quizlet, and it's going to be a step up in terms of complexity from everything that we've done so far. And through completing the tutorial, we're going to learn about something really fundamental to creating slightly more complex apps, and that's of course the model view controller. So by the end of the tutorial, you will understand what the MVC or model view controller pattern is, and you would have used it in creating the Quizlet app. So there's a couple of other things that we're going to learn through making this app as well, and I'll talk about them as and when they come up. So firstly, let's have a look at this app. So if I tap on the app icon, you can see that it's made up of 13 questions. And you have a true or false button, and you have a progress bar at the bottom, as well as a score label. So the user will go through answering these questions, and you will see a heads-up display or a little pop-up that tells you whether if you got the question right or wrong, and the progress bar will fill itself up as you progress through the different quiz questions. And then at the end, you get to restart the app and go from the top. So if you're thinking about becoming an app entrepreneur and starting your own app-based business, one of the most popular ways for people from other disciplines to get into app development and generating revenue on the App Store is through creating quiz apps. So, you could have special expertise in the bar exam or in a medical exam or some other topic that people need to study for. And you could use your own knowledge to create a question bank and then turn that into a quiz app through the tutorial that we're about to embark on, and then put it up onto the App Store and start generating downloads and revenue. So I'm really excited about teaching you guys this app because it's going to be really, really useful for all of the future apps that you're going to build. So without further ado, let's get started. All right, so let's download and set up the Quizlet project. Well, first things first, let's head over to github.com/LondonAppBrewery/Quizlet. The URL's in the text box below if you want to go for a short link. And then when you're here, just go to clone or download over here, and then you can download the zip file. If you're a ninja with terminal, then feel free to git clone to your desktop. If that didn't make any sense, then don't worry, just follow along with what I'm doing. So once you've downloaded the zip file, just click on it to unzip it, and then you should be able to find the folder called Quizlet-master. So now in this folder, you should be able to see three things. One is the Quizlet folder, one is Quizlet.xcode project, and then there's a README. So double click on the Quizlet Xcode project to launch it in Xcode. Okay, so this is the skeleton project for Quizlet. The first thing we're going to do is we're going to have a look at the settings for this project. So if you click on Quizlet over here in the File Navigator pane, and then if we go to the targets, and it's this one, the Quizlet with the app icon under here. And then if you just click on General, you should be at the pane that we're looking at right now. So first things first, change your bundle identifier as you have done in the past to something unique, and then change your team to your personal profile if you're planning on launching this app on a physical device. And the other thing that I want to show you is that if you have a look down here where it says deployment info, device orientation, I've unchecked in the skeleton project landscape left and landscape right. And this is because for a quiz app, for the user experience to work, I don't think it makes sense for it to be in landscape. And plus, this will make our layout issues a lot easier. So I've just unchecked these orientations. So once you launch the app on the phone, no matter how you tilt the phone or turn it around or upside down, it will never go into landscape or change its own appearance. This is a simple way to lock down the orientation if you know that you don't want your app to change its orientation. Now, the other thing that I've done here is that I've changed the status bar style to light. The status bar is the top part of any app. You can see how much battery you've got left, how much signal, etc. That little bar. And because the background for our Quizlet app is blue, it doesn't really look very nice with a black status bar. So I've just changed it to style light, which means it'll be white and it'll look a lot nicer. So it's quite easy to do that. So if you need this functionality in the future, just go to Quizlet, select your app in the targets, and then under general, you've got this status bar style light. And you can also hide the status bar here using this checkbox. But if you run the app right now, you'll see that it hasn't actually carried over. And you actually have to make one more adjustment in order for this to work. And that is changing the information that's in the info.py info.plist file that's under the supporting files folder over here. So if we just click on the info.plist, remember, try to not double click on any of these things on the navigation pane, because when you double click, you open it up in a new window. And then as you're coding, you've got a million windows that are simultaneously open, and it can get really confusing. So always just single click so that it all opens up on the same page. So in here, we're going to modify a setting. You can see that already by using that drop-down list, setting our status bar to light, i.e. white. It's automatically put in this key value pair. Now, a key value pair is also known as a dictionary, because similar to a normal dictionary where you've got, say, a word and then you've got its definition, they are paired together in a similar way. So for example, here, the name of the key is status bar style, and the value for that key, the setting, is UI status bar style light content. Now, in order for this setting to get carried through to the phone, we have to add one more key value pair. So I'm going to go ahead and add a new key by clicking on this little plus button up here, just next to information property list. And that gives me a new key. Now I'm going to delete this application category because that's the default key that gets filled in. Instead, I'm going to scroll down to find view controller based status bar appearance. So if you just scroll over here, you can see that's the full name of the key. Now I could have also typed it in, but remember, key value pairs are similar to code. In fact, if you right click on info.plist, you can actually open it up as XML code. And that's why whenever you put in a new key value pair, you have to make sure that the spelling of the key and the values are precise and correct, because otherwise it won't work. So it's much easier to get Xcode to write it and you just simply select it. Now the value of this key is of type Boolean, and as we discussed in the past, Booleans are either true or false values, and here the default is no, which we're going to keep and we're not going to change. So what this does is that by default, every single app looks into the view controller code to see what it should set as the status bar style. Now you can use code in here to change what the status bar should look like, but we've kind of gone through the shortcut way and set it in the general settings. In order for that to carry through, we had to go into the info plist and specify don't use the view controller code, instead use what's specified in the plist over here, which is the UI status bar style light content. And now if you launch your app, you'll be able to see that the app doesn't currently do anything because we haven't given it any code to run. But if you look at the status bar, it is now white and it looks beautiful. Great, so now that's sorted, let's stop the simulator from running by going Command full stop or clicking the stop button up here. Now, if you have a look in this left-hand navigation pane, you can see that we've organized all the files into folders. And the three main folders that we're going to be working with are the controller, the model, and the view. And this, of course, relates to the MVC model view controller design pattern that we're going to talk about in detail in the coming lessons. But if we head inside the view folder and we click on main.storyboard, let's have a look at our design. So we've got this top area for the question to show up. And then we've got these true and false buttons, and at the bottom there's a progress bar which will increase in width as we progress through all the questions, and we've got this label that keeps track of which question we're on out of 13. And over here we've got a score label that tells you how well you're doing. Now this is common practice to put in a default value of the largest number that label will ever show up. So in a question bank with only 13 questions, allocating 1 point to each correct answer, having 9,999 is a bit overkill. But it's good practice to figure out what is that maximum so that you never get into the situation where the label gets truncated because the score has gotten too high. And this is especially important when you're programming games where the score can actually get quite big. Okay, so now I'm going to go into the assistant editor. Remember, we can go into the split screen by by clicking on this little button with the circles. And now I can see the main storyboard next to the viewcontroller.swift file. Now, if in your Xcode you don't see the viewcontroller.swift file showing up in the right side of the assistant editor, you can also go into here, and under automatic you should be able to find viewcontroller.swift. If not, you can also navigate through the manual section as well. But basically we have the design file and the code file side by side. And this will allow us to quite easily have a look at what's already been linked up. So we've done some hard work ahead of time because we're happy that you already know how to drag and drop and create IB outlets and IB actions. We've done that quite a few times. Back on how those things were created, you can always pull up the Dicey video tutorials, and there's a lesson in there that goes into this in detail. But we want to save you from doing boring, repetitive work and teach you as many new things as possible. So hence, we've already linked up 4 IB outlets, and if you roll over the margin over here, you can see that the first IB outlet is linked up to the question label, and we've given it a name of question label in camel case. And then the next one is linked up to the score label, and one to the progress bar, which is this yellow bit here. And then finally, we've got the progress label that tells you which question you're on. And make a mental note of what these names are. We've named it, I think, in a logical way, the name. But remember, if you want to change any of the names of these outlets, you can't just change it in code because the design files are still pointing towards a specific name in the code. So for example, if you right click on the question label, you can see that it's linked to something called question label, spelt like this, in the view controller. So you can't just change the code, willy-nilly. Say if I get rid of the capital L and I right click on this, you can see that it's still linked up to question label, even though I've changed the code file. And now if I run the app, it will crash because it won't be able to find this question label. So always break the connections and then remake them if you are going to change any of these label names. But I'm going to undo by going to Command Z, keep it as it is. Next, let's have a look over here. We've created a IB action that's linked to these 2 buttons, the true and the false button. And based on the tag of these buttons, we will be able to figure out if the user pressed the true or the false button. So if you have a look at these buttons in the utility pane, and you go into the attribute inspector and have a look at the tag values, true has tag of 1 and false has a tag of 2. So that way we can use the sender.tag, similar to how we did it in Xylophone, to figure out which button was pressed. And then there's a bunch of functions that we've pre-created with absolutely nothing inside other than just the names. And in the coming tutorials, we're going to fill all of those up with code, and we're going to get our quiz app up and running. So that's just an overview of how the skeleton project is set up. And have a look through your skeleton project, and if you have any questions or any issues, just write a comment in the video below. But otherwise, we're going to move on to the next lesson, and we're going to create a model. Alright guys, first things first, I'm recording these videos in our Epping recording studio, and it is absolutely freezing over here in the UK. So if you hear any rustling noises in the background, that will be one of my 3 coats that I've got on right now, to try and prevent myself from freezing to death. So just a clarification in case you're wondering. So in the last episode, we went through the setup and we looked through our code file as well as our design file in this new Quizlet skeleton project. In this lesson, we're going to learn about building a data model. And at the moment, if you have a look inside these folders over here in the navigator pane, you can see that in the controller folder, you've got 2 files, the appdelegate.swift and the viewcontroller.swift. In the view folder, you've got all your image assets which we've already incorporated, including the app icon. And you've also got the main storyboard that's already set up and ready to go. But if you have a look in the model folder, it's currently empty because we haven't created a data model yet until now. So the first thing we're going to do is create a new Swift file. Now, up till now, all the Swift files that we've been working with have been generated automatically by Xcode when we've chosen the single view application template when we started up Xcode. But now we're going to create our own. So we want to create it inside the model folder. So I'm going to select the model folder, and then I'm going to go to File, New, File. And then we're going to make sure that we're under the iOS tab, and I'm going to pick a Swift file right up here and then click Next. Now we're going to call this file question, and we're going to make sure that the target Quizlet, i.e. our app, is selected. And the group just means which folder it's going into. Because we selected model, it's going to go into the model, and you can change it here if you need to. So then we're going to go ahead and click Create. And we've now got this brand new file called question.swift inside our model folder. Now I'm going to get rid of the assistant editor just to give myself a bit of screen real estate. So always try to make life easy for yourself. Get rid of the things that you're not using at any given point in time. Now you can see that this brand new file has virtually nothing in it other than a copyright notice and an import statement. And you can see that this import statement is slightly different from the import statements we've seen previously, such as import UI kit. For example, in viewcontroller.swift, we've got import UI kit, as does app delegate. So if you remember from before, we mentioned that the libraries that we're importing are like these Swiss knives, essentially tools that enable us to build our app the way that we want it to. And just as if you go to the Swiss knife shop, you'll see different types of Swiss knives. For example, you got those super huge, super comprehensive Swiss knives that has like a spoon and a toothpick and tweezers. Those are huge, right? And then you've got some more lightweight Swiss knives that just have the core functionality like a knife and a screwdriver. Now, similarly, you don't want to import and incorporate every single library because you're not likely to need it. So say if you were going on a one-day fishing trip, do you really need a Swiss knife that has a saw? So depending on the use case, you will pick and choose which library you're going to import. So Foundation is slightly lighter weight than UIKit. You can go even lighter weight by just importing Swift. But in order to build an iOS app, you usually should have UIKit or Foundation at the top imported, just so that you can get access to some of the basic things that you'll be using. In the text box below, there's links to each of these libraries, and you can have a look at the use cases for each one to determine which one you'll import in your future projects. So have a look at that. But for question.swift, I'm going to leave import Foundation there. I'm not going to change it. And below it, I'm going to create a new class. So in order to create a new class, first things first, you declare the class keyword, which gets highlighted in this purple color, showing you that Xcode knows that this is a keyword. And the name of the class is going to be question, using a capital Q. And then I'm going to open a curly brace and hit enter to insert the closing curly brace. Now, there's one thing that's quite important here, that in terms of naming conventions, when we're creating functions or when we're creating methods or variables, the convention is that the first word should be lowercase. But when you're creating a class, the first letter should be capitalized, so hence the capital Q in question. Okay, so here we've created a new class called question, and inside it's currently completely blank. Inside this class, i.e. inside the curly braces, we're going to create some properties. Now, in order to create those properties, I'm going to use the let keyword to create a constant called question text, and it's going to be of type string. Then I'm going to create another constant called answer, and it's going to be of type bool or boolean, so i.e. true or false. Now, this question class that we've created is going to be used as a structure for all the questions in our app. So every single question will be structured in a way where it has a question text and also an answer that's true or false. And do you remember earlier on I said that we're going to create some properties for our question class? Well, properties are essentially variables that are associated with a class. So you can also call this a constant. So this can be called a constant. So even though it looks like we're creating a constant, you can also call it a property because it is a property of the question class. Now, up to now, we've basically ignored the differentiation between methods and functions, but actually methods and functions are defined slightly differently. A method is a function that's associated with a class. So if it's within the curly braces of a class, then it's called a method. And if it's not within a class, if it's just free floating, then it is a function. Okay, so let's move on. At the moment, you can see that Xcode is not really happy with my class because it says that question has no initializers. And why is that? Well, at the moment, if you have a look at these two properties, you can see that they don't have a value associated with them. I didn't set them to equal something. And that's essentially what you do when you initialize a property. So give it a starting value. I could say, give the starting value of answer to be true and give the starting value of question text to be, am I real? As soon as I do that, then the errors go away and the question class has some initial values for those properties and it's happy. But this doesn't really make sense in our app because those questions will be created on the fly. So instead, I'm going to use what's called an initializer using the init keyword. So I'm going to write init and I'm going to open a bracket and I'm going to give it some parameters. So this method determines what happens when a new question object is created from this question class. And then I'm going to give it the first parameter, which is the text of the question, and it's going to be of type string. And there's going to be another parameter called correct answer, and it's going to be of type Boolean. So this initializer takes two parameters, and this is what should happen. And I'm going to open and close a curly brace to determine what happens when this class is initialized, i.e. what should be the initial values. And I'm going to set the question text property up here to the text property that we will pass in through a parameter. And similarly, answer is going to equal correct answer. Okay, great. So all the errors have disappeared because we have put in this initialization code. And later on in a different class, say let's, create a different class and call it something, my other class. Now, note how you can actually create two different classes inside the same file. Although this is not the right way to do it, I just want to show you how you would actually go about using the initializer. So in this other class, we're going to create an object from this question class. Remember that classes are like a blueprint, and the object is what gets created from that blueprint. So here we've just written the blueprint for what a question should look like. Namely, every question should have a question text as well as a question answer. And I'm going to create this new object using a lowercase q. Classes are capitalized, objects are lowercase. So let question equal capital Q, question, open round brace, and you can see the initialization code pop up. So it's expecting two parameters. One is the text, which we wrote here, and the second one is the correct answer. So let's say my first question for my quiz is, what's the meaning of life? Now, if you have a look, I can't actually put 42 here because when we created this initializer, we specified that the correct answer should always be a Boolean, i.e. it should only be true or false. And similarly, when we create this object from this class blueprint, it's also telling me that this placeholder is expecting a Boolean value. So let's just put true in there. And there we've got our first question created. Now, if I wanted to create, question 2, I can use the same method to give it a different text, and so on and so forth. I can create all of my questions using this question blueprint. Okay, so I'm going to delete that code because it was just to show you how it would work. Okay, so just to recap, in this lesson, we created a new class called question. And this class question has 2 properties. One called question text, which should be a string, and one is called answer and should be a Boolean. Then we created an initialization method that determines the initial values of these 2 properties. And that comes from 2 parameters that we will pass in when we create new question objects. Now, we also had a look at how we would go about initializing a new object of the question class. In the next lesson, we're going to explain what exactly objects and classes are. So don't panic. This lesson was just to get you to create for yourself a new class and see how it's done. And in the next lesson, we're going to be explaining exactly what it is that we just did, and to understand this fundamental concept of classes and objects. And then we're going to come back and create another class that we need for the app. So you're going to get plenty of practice of creating classes and objects. And the next time you create a class, everything is going to be a lot smoother and a lot clearer. Okay, so I'll see you on the next lesson. Before we start making our app, we should first understand what it is that we're making. So let's break down all the components that make up an iPhone app and talk about the anatomy of an app. There's 3 main components that you should think about. One is the view, which is what you see on screen or what appears on screen. These are buttons and labels, text or images. Then there's the view controller. So this goes on behind the scenes, and this is the code that controls what should happen when a user taps a button, or what should happen when you have a piece of data to display on screen. Then finally, there's the model. The model is what controls the data. It manipulates the data and prepares the data to be served up to the view controller. So let's take a simple app, such as a contact app. So it just manages all of your contacts. And when you open up your app, the first thing that would happen is that the view controller will ask the model for the data of all your contacts, their phone numbers, their images, etc. And the model grabs that data and passes it back to the view controller. The view controller then decides how it should be displayed on the view. And then the app will display all the information that was retrieved in a nice, beautiful format. So this works the other way as well. Say if a user taps on a button that deletes this contact, say John Doe, the view will tell the view controller that the delete contact button was tapped. The view controller will make contact with the model and ask it to remove that contact from its database. So these 3 core components come together to make up what you see as the app. So this is known as the model view controller design pattern, and this is a very common design pattern that people adhere to when they're creating iPhone apps. And the reason why we use the model view controller design pattern is because it has several advantages that make our app more versatile and also easier to manage. Say if instead of having all our app in English, we wanted to populate our app with data that's in French. The model view controller enables you to do that really easily without having to change the view, the controller, or the model. All you have to do is just swap in the new French data, and you can leave the rest of the code untouched. So this way, it's quite easy to produce new versions of your app, retaining the functionality and only swapping out the data. Another reason why people really like the model view controller is the fact that it separates all the different functionality and the different components into individual packages of code. So this way, if there's a problem, in your app, if there's an error or a bug, it's much easier to identify by looking to see whether if it's in the view, or if it's in the controller, or if it's in the model. This way of modularizing code makes it easier to maintain and helps you when you're debugging. Okay, so this is a very brief introduction into one of the design patterns that we'll be covering, the MVC or Model View Controller design pattern. And in future, when we're creating more complicated apps, we'll be going into some of the other popular design patterns, as well as diving a bit deeper into the Model View Controller pattern as well. But for now, all we need to know is that there's 3 core components that make up all our apps: the view, the controller, and the data model. And combined, they come together to create our app. Okay, so that's a brief primer on app anatomy. In the next lesson, we're going to be creating our very first app. So I'll see you on the next lesson. Alright guys, today we're going to tackle one of the most important concepts in this course, and that is what exactly is object-oriented programming. So during the Quizlet tutorial, I've been talking a lot about objects and classes, and in this lesson, we're going to understand exactly what is the difference between objects and classes and how we use them to create sophisticated programs. So to explain OOP or object-oriented programming, let's take you back to the beginning. So as we know, computers run on a whole bunch of ones and zeros. This is known as machine code. Essentially, you could see a computer as being made up of billions and billions of switches. And those switches have one of 2 states. They can be in 1 or 0. So as a computer programmer, we can tell the computer what to do in terms of calculations to perform or processes to run by giving it commands in the form of ones and zeros. While you could learn how to read and program in machine code and just type out billions of ones and zeros in order to make your app run, but that's pretty much the same as brushing your hair one hair at a time. So while doable, it's not very efficient. So hence there were a lot of clever people that came up with programming languages that looked vaguely like English, that a human could use to write out their programs, and the computer can translate into machine code, the ones and zeros, which then it can execute. So back in the 1970s, Dennis Ritchie created a language called the C programming language. And this is essentially the father of all modern programming languages. This is where subsequent languages such as C#, C++, Objective-C all came from. And in fact, a lot of the concepts that were used in creating the C programming language persist in other languages as well, such as PHP or Java, Scala, etc. Now, the C programming language belongs in the category that's known as procedural programming languages. So what exactly are these? Well, procedural programming languages are exactly that. They are where your program is essentially a whole list of instructions that comprise up of a procedure. So for example, you would say do this, then this, then this, then this, and it's very linear. It goes on and on and on. Now the analogy for this is, say if you own a restaurant and you decide to make it a one-man show where you basically only employ a single person to do everything that's required to keep the restaurant going. So you would have to tell this employee a list of instructions that they would have to do every single day that they go to the restaurant and work there. So that could be first open up the shop, switch on the lights, then take orders, deliver it to the table, then go and cook those orders, and then deliver it to the table, and then take the money, and then put it in the till, etc. So essentially, you would be giving this employee a long list of things to do that goes from step 1 to step 2, step 3, step 4. It's like a recipe that you follow in sequence. And the obvious downside to this is that it's not very flexible. And at the same time, your list of instructions or your program gets very, very long and very difficult to debug. So wouldn't it be great if in our restaurant scenario, instead of having a single employee, if we had 3 employees? So you could have one guy who acts as the waiter, you could have one person who acts as the pastry chef, and then you've got one guy who's the cook. So with these 3 people, they each have their own roles and they each have their own particular jobs they know how to do. So then the waiter wouldn't have to learn how to make pastry, and the chef wouldn't have to know how to take orders or deliver it to the table. So essentially what you end up doing is modularizing, and you're splitting up the tasks and the roles into separate objects. So the great thing about this model is that, say if your pastry chef wasn't performing very well, if she was screwing up all the orders and everybody was complaining about the pastries that she was making, you could essentially just take out that single chunk of code, modify it, and then replace it back into the program with the new modifications. You wouldn't have to change anything about the cook, you wouldn't have to change anything about the waiters. This way of modularizing means that your error debugging becomes much more simplistic. You can really narrow down the problem into the individual objects. And also changing that object or modifying the code of that object wouldn't affect anything else that's running in the program. And so this is essentially what an object-oriented programming language is. You've got objects which can send messages to each other. For example, the waiter object might say, "We need some more cakes," and send that message to the pastry chef, and then she responds to that message by creating more cakes. So in this scenario, passing messages around, the waiter doesn't need to know anything about making cakes. All it needs to know is that there is a object in the program who knows all about making cakes, and all he has to do is send that message over there, and then magically he would get access to those cakes that are created. So what are some examples of object-oriented programming languages? Well, there's Objective-C, which is a object-oriented version of C and is used to program the Mac OS that you're running right now on your laptop. There's also Java, which is used to program Android apps. And of course, there's Swift, which is what we're learning at the moment. So now that we understand the basic concept of what object-oriented programming is, let's talk a little bit about the differentiation between objects and classes, because I've been talking about it quite a lot in the tutorials. Well, essentially a class is very much just a blueprint. It contains the instructions of how you can go about creating the objects. So this car class is not an actual car, right? It is not an actual object. It's merely the instructions for how a car would be created. So the specifications for, say, how many seats it has, how many doors it has, what color is the paint job, as well as how it would function. So, how would the motor run? How would the braking work, etc. And an object is the actual car. So the car that gets created from this set of instructions or blueprint. That's the class. So objects have three main things that are associated with them. Firstly is properties, and we've seen that in our question class in the last lesson. And properties are exactly that. They're the properties of the car, things that are descriptive. So what is the color of the car? What is the number of seats? What is the number of doors? And these are defined using let and var, so constants and variables. But when they're associated with an object, they're called properties. The other thing about objects is that they have actions associated with them. So these are your functions that you're creating. How does the car drive? How does the car brake? How does the car turn left? And these are actions that the object can perform. And finally, there's events. This is where you define how the object responds to things happening to it. So for example, when the car is started, what should it do? Or when it rains on the windshield, should the wipers come into action by itself, etc. So these are how the object should respond to certain events happening. And these three things come together into a program. So we define all of these things when we create the class, when we create the blueprint for our object. We set or initialize the properties, we tell it how it should respond to certain events, and also we program what actions the object will be able to take. So if we have a look at the code that we wrote, you can see that we define the properties in this part, where we use two constants to define the question text property and the answer property of all question objects. And then we use the init method to define an event, namely what should happen when a new question object is initialized from the class blueprint. So in this case, what we've said is that when we create a new question object from the class blueprint, we need to give it a text for its question text, and we need to give it a correct answer for its answer property. And finally, I've just added in a function in there just to show you what an action would look like. So remember, we create functions by using the func keyword, and inside this function, the program should be able to do something. So there's a lot of new words that we've been using so far. So let me just clarify how they're used by programmers. So programmers like to be very precise when they're talking to other programmers. This way we can all know exactly what we're talking about without any confusion. So let's try and clarify what those words mean. So when you're talking about constants or variables that are created within the confines of a class, they are known as properties because they are the properties of the object that will get created from the class. So you could use let or you could use var. So for example, for our car class, the properties might be color and type. But when that same code is declared outside of a class, outside the curly braces of a class, then they're known as constants and variables. And similarly with actions, when they're created within the curly braces of a class, they're known as methods. So any function that is associated with a class and hence associated with an object is known as a method. But when that same code is declared outside of the class, then it's known simply as a function. So I hope that clarified a little bit about what is the difference between properties versus constants and variables, as well as methods versus functions. Now, for the most part, a lot of this differentiation is academic. In terms of coding it and using it, they will be pretty similar. You create methods by using the func keyword, you create functions using the func keyword. The only important thing is that when a programmer says to you, your method drive looks a bit odd, then you know what they're referring to. So the key takeaway from this lesson is that classes are blueprints that are used to create objects. And in your program, if you created a whole bunch of classes, if you don't initialize an object from that class, then your code still won't do anything. It's the equivalent of thinking back to our restaurant scenario, where you've got the instructions for each of the employee roles, but you've got no employees. So in the coming lessons, we're going to dig a little bit deeper into all the intricacies of objects and classes. But for now, all we need to know is that objects specialize in certain roles, where they know how to perform certain tasks. And the objects can pass messages around to each other in order to instruct other objects to carry out their own particular specializations. So in the text box below, I'm going to leave you a quote from the late Steve Jobs, where he tried to explain using an analogy what object-oriented programming is. And in the next lesson, we're going to create another new class, as well as showing you how we create an object from that class. So I'll see you there. Okay, so this is where we left off in the previous lesson. We created a new class called question that has two properties associated with it. One is called question text of type string, and the other is called answer of type Boolean. We also created an initialization method that determines what should happen when a new object is created from the question class. Inside this initialization method, we said that we will give it two pieces of data that will be set as the initial values of the question text and answer properties. So next, we're going to create a brand new class. So I'm going to again click on the model folder, and instead of going to file new, I'm just going to right click here and show you another way how we can create a new file. So I'm going to click new file, and again making sure that I've got the iOS tab selected. Under source, I'm going to go to Swift file and click next. Now I'm going to call this new class question bank. And again, making sure that I've got the model group selected, as well as having my code target the Quizlet app, I'm going to go ahead and click create. Now this new Swift file gets created within the model folder, and all I have is a single import foundation line that's been created for me. Now the purpose of this question bank class is to store all of the questions that we're going to use in our quiz app. And each of these questions are going to be formatted using the question class. So they will each have a question text as well as an answer property. Let me show you how we're going to do this. So first of all, we're going to create a new class. And if you remember, the way to create new classes by using the class keyword, and then we give it a capitalized name, which is going to be question bank. Now I'm going to open a curly brace and hit enter to insert the closing curly brace. And within this class, I'm going to hold all of the question data. Now, the first thing I'm going to do is I'm going to create an array of question objects. And I'm going to call this array list, i.e. list of questions. And I'm going to set it to equal open and close square bracket. Now inside the square brackets, I'm going to give it the type of data that I'm going to store in this array. Do you remember previously we could create an array like so by putting in data? We can also create an array by giving it the type of data that will be stored, so integer, for example. Now in this case, the type of the array is going to be the question class. And then I'm going to give a open and close round bracket to complete the construction process for this array. Now let's analyze this a little bit more. So here we've used the var keyword to create a variable. And remember, when variables or constants are created within the curly braces of a class, then it is called a property. So here we're essentially creating a property for the question bank class, and that property is going to hold all the data of all the questions we're going to use in our app. So this variable is called list, and it is set to equal a array, which we can tell by the square brackets, that contains only question objects. So essentially we've created an array of questions that have a question text and an answer. So at the moment this array is completely empty. Now in order to fill it with content, we're going to use the initialization method again. So I'm going to use the init keyword, and then I'm going to open and close a round bracket. Now this is different from what we did in the question class because we actually wanted to pass it some data. In this case, we don't want to pass it any data at all. And so we have no parameters, and that's why the round brackets are empty. Now I'm going to write a open curly bracket, and I'm going to hit enter to insert the closing curly bracket. So now I have my initialization method here. Inside the initialization method, I'm going to put in all of the data for all the questions we're going to use, which we've already created for you. Now, it's no fun typing out 13 question texts and their answers. So what we're going to do is we're going to head over to the GitHub page for Quizlet. The link is again in the text below this video. If you scroll down past the finished app, you will see the quiz text strings. And all that we're going to do is we're going to copy all of this text, and I'm going to use Command C, and we're going to go back to Xcode, and I'm going to paste all of that text between the curly brackets of the init method. So I'm just going to go Command V and paste it in there. Okay, so now we've saved ourselves a lot of time, but we need to understand what it is that we're doing here. So let's have a look at this first line where we're creating a quiz item and appending it to the list. So here we're creating a new constant called item, and that item is constructed using the question initialization code. So do you remember we created this initialization method here that takes two pieces of data, text and correct answer. So here we insert this question text as the data for the text parameter, and we insert the Boolean true for the correct answer parameter. And then we write list referring to our array of question objects, and we use the append method to add this item here to the end of that array. So currently the array is actually completely empty. We've only specified the type of data that should go into the array, but we haven't yet given it any data. By using list.append item, we're adding this item with a question and answer into this array. Now, this is one way of doing it, and it's a little bit wordy because you can see we've used 2 lines of code in order to do that. Now, we can be a little bit more efficient with our code by not having to create this constant called item and then adding it into the list. Instead, we create a new question object on the fly, and then we use the append keyword to add it to the list. And we do this for the rest of the 12 questions. So essentially the format for constructing new objects is by using either a let or a var keyword to create a constant or a variable. So creating a container, then we give it a name, so we call it new question object, and it's equal to question using the capital Q. And that bit of code basically says, please find the instructions that we've created for constructing new question objects. So then Xcode will go over here and have a look at this file and see how new question objects are constructed. And then we're going to open a round bracket and use that initialization method that we created in order to create a new question object. Now, the question object, of course, expects a text and answer. And then once we fill that in with some data, we have a new question object created from the question class using the initialization method. So that's essentially what we've done in the rest of this code. We've created 13 new question objects, and we've added them one by one to our array of question objects. So now we've created our data model, and data models are used to manage and manipulate data. So we have this question bank that contains 13 question objects, and we're going to use those question objects in our app in order to display the questions and check for the answers. Now, don't be alarmed if not everything makes perfect sense straight away. Learning programming is like putting together a puzzle. Now, the pieces by itself won't make a lot of sense. It's only once you have sufficient pieces together does the picture start becoming clear. At the moment, we're just learning about those building blocks, and a lot of those building blocks are very abstract. It's like finding a single piece of the puzzle, and it's kind of just green. I mean, you don't know if it's a part of a tree or if it's a part of a lawn. Only once you start putting everything together does it start to make sense. So all I'm trying to say is don't be put off by the abstraction. Carry on building the code, and we're going to be coming back to these concepts again and again until they make sense. So in the next lesson, we're going to be making use of our question bank, and we're going to get our app to display the first question. And in order to do that, we're going to create an object from the question bank class. So I'll see you on the next lesson. Hi guys, today we are going to tackle a big topic, and that is the model view controller. Now, in the first module, when we talked about the anatomy of an app, we spoke about this concept briefly. But as we're building Quizlet and we're actually using a full model view controller design pattern in order to create this app, I thought this is a good time to address what exactly is the MVC design pattern and why is it useful and how are we using it in our app. So the first thing that we have to address is what exactly is a design pattern? Well, a design pattern is simply a proven solution or a best practice approach to a common problem. So to give a real-life example, a common problem that the early man might have faced is how do you stay warm when it gets dark and cold? Well, very early on, people learned that they could build shelters by taking animal hide and making it into a teepee. But then later on, they realized that actually animal hide is not all that fire retardant. And also, if you have some wild animals lurking around, it's not so difficult for them to come in and eat your family. So then there was an improvement on that design pattern, and people brought out mud huts, which were made out of mud so that the wind can't easily tear it down and animals find it hard to enter. But then people improved on that further, and we have the modern house, which is made out of wood, so it keeps you warm, it keeps you safe, and the majority of us will agree that this is a pretty good design pattern. So instead of having every human who needs to build a shelter go through the painful process of discovering what is the optimal structure to build as their shelter, in the process possibly losing their family to wild animals, instead we've come up with a design pattern or a blueprint that tells anyone who's looking to build a shelter what is the best practice for building a house. So any future house builders can refer to this blueprint and see that, oh, in order to build a house, I should structure it so that I have a foundation, I have walls made out of bricks, and also I should have a roof on top. And so this brings us to the model view controller design pattern. So this is something that came out of the research of Trygve Rienskan. when he was working on Smalltalk at Xerox PARC. Don't worry, nobody can pronounce his name. It's Norwegian, and I'm probably messing it up horribly. But he came up with the model view controller design pattern. And this is a really good design pattern to use when you're building apps using object-oriented programming. And what this design pattern allows you to do is that if you have an incredibly complex app with many thousands lines of code, then you can structure it using the MVC design pattern instead of spaghetti code, which is basically a single file with loads and loads of code that interlink with each other and essentially just a whole mess to work with. Instead, you can implement a structure that will allow you to manage the complexity of your code. Let's first talk about the components that make up the MVC. So the M stands for model, which is a structure that manages the data. It's not the data itself, but it is responsible for creating new entries into the database or reading from the database or deleting entries from the database. So in that way, essentially, it structures the data and prepares it in a format that the view controller can use. Next is the view, and this is essentially just what you see on screen. And in the middle, there is the controller, and it handles communication between the model and the view. So say if you have a contacts app, and you're looking for a particular person's phone number. So you look up Amy's phone number, and that makes a request to the controller. The controller then takes this request and does some processing around it to see whether if this is an appropriate request. And if it is, then it sends a message to the model asking for that data. Now, the model is not the data itself. Instead, the model is like the storeroom manager. It grabs the data from the database and formats it in a structure that the controller can understand, and then serves that data back to the controller. And the controller prepares it for display on the view. So the MVC design pattern can be a little bit abstract. So to bring the message home, I'm going to illustrate this with an analogy. So welcome to our restaurant, and I'm going to show you how it works in this context. Now, in our restaurant analogy, the data will be the raw ingredients. The model will be the kitchen that prepares and structures the ingredients into dishes. And those dishes get passed over to the waiter, which is the controller in this case. And that waiter can take orders as well as serve orders onto the view, which is what the customer sees on the table. So first we'll start off by making a request to the controller or the waiter. We'll tell him that we want to see some pancakes on our table. Now the waiter is going to take that request to the kitchen. The chefs in the kitchen will then go to the larder and fetch the ingredients that are required to make these pancakes, or the data that's required to be served up. And then once the data is brought back to the kitchen, they will prepare the ingredients and turn it into something that the waiter can take back to the customer. And then the diligent waiter will take this dish and present it on the table of the customer. So if we have a look back in our code in Quizlet, you can see that the folders organize our code into the view controller model pattern. So our controller will be something like viewController.swift that controls what gets displayed on screen as well as what data requests to make. Now the controller can process those requests. For example, if you entered a password into a text field and it's 6 characters instead of 8 characters that's required, the controller will deal with that and say that, no, sorry, we can't take that input. And similarly, the waiter can say, no, we can't make a avocado frappuccino with mint on it. Then we've got something like question.swift, which prepares the data in a format that can be easily displayed on screen. And our question bank in this case is the actual data. It contains all of our questions. And so the question model prepares the question data and hands it back to the view controller. And the view controller then displays that data onto the view or onto the screen so that the user can see those questions being displayed and can interact with it. So why do we implement the MVC design pattern? What are the advantages? One, it provides a structure to your code. Once your code gets more and more complex, it can be really hard to get a grip on what exactly is happening where. Now, by splitting up your code into this model, view controller pattern, you can find the relevant things in your code very easily. Additionally, it's a commonly used design pattern and easily recognized by other programmers. So if you bring a second programmer on board who's also going to work on your code, if your code is structured in an MVC design pattern, most programmers will recognize it instantly and be able to work on it without being confused as to how your code is organized. Thirdly, it allows for code reuse. So you'll notice that in the MVC design pattern, the model and the view never communicate with each other directly. As a customer, you can't just run into the kitchen and grab what you want and eat that, because it would be chaos. And the advantage of that is that you can easily change the data without affecting the rest of the code. So for example, if tomorrow I decided that my app was going to be in French, I could quite easily change my data file from the English questions to French questions, and I wouldn't need to change how any of the rest of my code works. So this allows for code reuse, and it is very efficient. And finally, it allows for multitasking. This is also related to how modular the code is. So for example, if you had 3 programmers working on the same project, you could do things 3 times faster by assigning one guy to take care of the view. So they're going to be the front-end designer. Then you've got one guy who's going to design the back-end. How do you want to manipulate, add, verify the data, etc. And then you've got the middle guy who can work on the view controller, determining when and how you present the data to the view. So it allows for many people to work on the same project. So there's a lot of virtues to implementing the MVC design pattern. And I know that a lot of beginner programmers don't like to implement it because it seems like it's more work. But once your code gets to a certain size, without having that structure, whether if it's using MVC or whether if it's using something else like MVVM, it will make your software much easier to maintain. So that's just a bit on the MVC design pattern. If you have any questions about it, feel free to leave a comment in the text box below. Otherwise, I'll see you on the next lesson. Right, so let's get back to where we left off in the last episode. So previously we created this new class called Question Bank in our model folder. And in this Question Bank class, we created an array called list that consists of question objects. Now remember, question objects are objects which have a question text and an answer. Then we use this question structure to create a number of question objects. So we gave it a text and we gave it a correct answer. And we created 13 of these and added each one of these questions sequentially into the array called list. Now this is going to be our question bank. And when we initialize a new question bank object, it will go through this init method and create the 13 questions, adding them to this array, which we can access. Now, if we go back to our view controller, we're going to create a new question bank object, and I'll show you how we do that. So just below the class declaration, I'm going to create this new object. So let's give ourselves a bit of space here, and I'm going to use a let keyword to say that I'm creating a constant because I'm not going to modify the question bank. Let all questions, so that's going to be the name of my question bank, equal question bank, which if you remember refers to the class. So here we go, question bank. I'm going to select it and hit enter. I'm going to open and close the round brackets to initialize a new question bank object. So remember, in the question class, the initialization method actually requires 2 parameters. But in the question bank class, the initialization method requires no parameters, which is why we've got this empty round parentheses. Okay, so now I have my brand new object or questions, which is created using the question bank blueprint or the question bank class. Now the next step is getting our first question to be displayed in the app. So inside the curly braces of viewDidLoad, so not inside the round braces, but inside the curly braces, i.e. these, I'm going to create my first question. So I'm going to use a constant again, so using the let keyword. And my first question is just going to be called first question. And it's going to be set to equal all questions dot list. So inside this object all questions, I'm going to tap into the array called list, and I'm going to grab hold of the first item in that array, which, if you remember, is this question. So the question is Valentine's Day is banned in Saudi Arabia, and it has a correct answer. And when you append this item to the list, when the list is completely empty, that becomes the first item. And all of this appending is done sequentially. So this is question 2, this is question 3, etc. And remember that arrays start counting from 0. So the first item is accessed using the 0 inside these square brackets. So now I've got this constant called first question. And I'm going to put that into the question label. So I'm going to make this label display the question text. Now remember, first question is a question object. So it has two properties, question text and answer. So firstly, I'm going to tap into question label. And I'm going to set the text property. Remember that properties are accessed using dot notation, i.e. this full stop here. So the text property inside question label is going to be set to equal first question dot question text. So the beauty of having a class that structures your data means that when you try to use it or when you try to access it using the dot notation, accessing those properties, it's very straightforward. Okay, so let's run our app. So you can see that the question is being correctly displayed in this question label here. Now these buttons still don't work, and none of these will work either because we haven't programmed it to do so. So when you press each of these buttons, the part of our code that gets activated or triggered is this part, the IB action answer press. So in order for us to check whether if the user got the answer right or wrong, we have to compare their selected answer versus the correct answer. So we're going to create a new variable using the var keyword called picked answer. And this variable is going to hold the value that the user picked. It's going to be of type Boolean, and we'll give it an initial value of false. So next, we're going to go inside the curly braces of this answer pressed IB action, which, remember, they're linked to the true and the false buttons over here, with true having a tag of 1 and false having a tag of 2. So inside here, we can check to see what the sender.tag was, i.e. determine which button was pressed. So if sender.tag equals 1. Remember that we use a single equal sign to assign a value, i.e. question label text should now be equal to this. And we use two equal signs to check for equality, i.e. is the left-hand side equal to the right-hand side. Okay, so then we are going to open our if statement with a curly brace and hit enter. And if the sender tag was equal to 1, that means that they pressed this button. And so we will set our picked answer variable to true. So picked answer equals true. And similarly, we are going to set the alternative option, which is if they pressed the false button, i.e. the one that has a tag of 2. So else if sender.tag equals 2, then in this case, we are going to set the picked answer to false. So once the user has decided on which answer they're going to give, then it's time to check whether if that answer was correct or not. So in order to do that, we've got a method called checkAnswer, which is going to perform that functionality. And we're going to call the method check answer. Now I'm going to give you a moment to remember how to call a function or method, and the place to do it is on this line here. So within the answer pressed IB action, i.e. it should happen when the user presses either of the answer buttons, and after we've checked and determined which answer they went for. So over here we're going to call the check answer method. So pause the video and see if you can call the check answer method. All right, so how did that go? Well, if you remember, calling a method is actually very simple. When we create a method, we use the func keyword, give it a name, and use the round brackets to determine whether if we should have any inputs. Now, when you call the method, you simply call it by its name. So you write check answer with empty round brackets. So what does calling a method mean? It just means that once the program runs to this point, it will go and search within this whole file for where this check answer is declared. And it'll come across this part, which is where we created and declared check answer. And then it will look inside these curly braces and see what it should do. Now, of course, at the moment, it isn't doing anything, but we're going to change that very soon. We're going to implement the functionality of checking an answer. Now, if calling a method or using methods or creating methods are at all confusing, have a look back at the Introduction to Swift module, where we covered methods and functions in extensive detail. It's pretty much the core programming skill that you will need to grasp if we're going to proceed any further. So if it's at all confusing, just go back and have a review of it. The way that the course is structured is that your knowledge layers upon previous knowledge, which means that we're relying on you to be honest with yourself and really question, whether if you've grasp these concepts fully before proceeding on to the next one. It's always really exciting making new apps, and I love it as well. But with each of these new apps and with each lesson in these new modules, we assume that you've gotten the concepts that we've taught previously. While it's very simple to just follow along and type what I'm typing, it doesn't help if they don't make sense. So that's something that we really care about. And if you have any questions, leave a comment in the comment box below this and we'll do our best to help out. Okay, so inside check answer, currently nothing happens, but we need to implement the checking of the answer functionality. So in order to do that, we have to compare the correct answer with the picked answer. Now we've already got our picked answer from the code over here. Now we have to check for our correct answer. Let me just copy this over here. Down here. Now we can use the same process to check for the answer property in the first question. So let's review these two lines again. All that we're doing here is we're creating a constant, so a container to hold the value of first question. And in order to get first question, we're tapping into our data bank, which is called all questions, and we're getting the list array out from that data bank, and we want to grab the 0th element. So if we just have a look in question bank over here, so our array is called list and it contains an array of question objects, and the 0th item is this one, which is Valentine's Day is banned in Saudi Arabia, and the correct answer should be true. So in this line, we tap into the question text property of this first question. So instead of getting the question text property, we now want the answer property. So instead of displaying it in the question label, we can hold it in a constant. So instead of using question text, here we would be tapping into the answer property. So now answer equals a Boolean, but instead of doing this, where we are tapping into the answer property of first question, you can simply add the answer property here. And so this cuts down two lines into a single one. And let's just change that constant so that it makes a bit more sense. So we would call it something like correct answer. So now in a single line, we achieve the equivalent of these 2 lines where we tap into our question bank, grab the array called list, find the 0th element in this list, and grab its answer property. And then we assign it to a constant called correct answer. So that's just a slightly shorter way of doing the same thing. So now I have this constant called correct answer that holds the correct answer from the first question. And I'm going to compare it against the picked answer. So I'm going to use an if statement to check if correct answer is equal to picked answer. And if so, then what should happen is I'm going to print to the console that you got it. But if it was not equal to the picked answer, else, then I'm going to print wrong. Okay, so let's run our app and see if that works. Yay, you got it. So the correct answer is true for our first question. And if I pick the true answer, then it says you got it. And if I pick the false button, it says wrong. So our check answer functionality is now up and running. But there's a problem at the moment. If I keep pressing these answer buttons, I don't get to move on from the first question. So in the next lesson, we're going to talk about how to proceed through our question bank and how to update the questions every single time I choose an answer. So I should be able to choose true, know if I got it right or wrong, and the question should move on to the next one. So all of that and more in the next lesson. And just a note that I'm using a lot of the terminology in this lesson, such as property or method or object or class, and it can be quite overwhelming when those words are not yet in your dictionary. So if any part of this lesson seemed slightly confusing, it'll be a good idea to have a review of the object-oriented programming lesson, where we go into detail about these things, where we go into detail about, objects versus classes or methods versus functions, and get a good grasp of it, and then come back and have a look at this lesson again. If it's all making perfect sense and you're breezing through, then I'll see you on the next lesson. In the previous lesson, we created a question bank object, and we set the question label to show the first question in our question bank. And then inside the answer pressed IB action, we implemented some code to check and figure out whether if the user picked true or false as the answer for that question. And then we called the check answer function, which of course has the functionality of checking to see if the picked answer is equal to the correct answer. And if so, it printed you got it, and if they got it wrong, it just said wrong in the console. Now in this lesson, we're going to implement some code in order for our app to proceed to the next question. So the first thing we're going to do is we're going to create a new variable right at the top of the class here, and it's going to be called question number. And it's going to be of type integer, and it's going to have an initial value of 0. So I'm going to let you do that. Go ahead, pause the video. All right, so that was easy. So we use the var keyword, and we give it a name of question number, and it's of type integer, and it's set to initially to be equal to 0. All right, done. So this variable is going to keep track of the state of our app. So the state can be, so in order to think about a state, so the best way to think about state is thinking about a game. So for example, in your game, you will have a variable that keeps track of which level are they on, how many enemies are on screen right now, how many arrows do they have left in their quiver, etc. And in this case, we're going to use a variable to keep track of the state of which question is the user on. And of course, that starts from 0. So when they first start out the app, they're at the 0th question. And we're going to increase this question number as they complete each question. So let's think back to our app. So on view did load, we get the first question showing up on the question label. and we've got the answer pressed button that processes what should happen when they press the true or the false button. Now, what should happen after they press either one of these buttons? They should not be able to give two answers to the same question. So as soon as you press one of these buttons, you should implement the checking mechanism through the check answer method and tell the user whether if they got it right or wrong. And then the next thing to happen is we should move on to the next question. So therefore, after check answer is called, we're going to increase the question number, this variable, from 0 to 1. So in order to do that, we're going to say question number equals question number plus 1. And for those of you guys who come from different programming languages where you could quite easily do this, so question number plus plus, in Swift 3, so for those of you guys who have not seen this in other programming languages, it's basically the same as this statement up here. It just adds 1 to the previous value of question number. Instead, they want you to do it like this, so plus equals 1, which I suppose allows you to plus equal 2 as well, so the equivalent of doing this. But it's just a shame that they took away the plus plus, because this is such a common functionality that people use. You regularly in programming need to increment by 1. And in fact, if you think about the language C++, it basically means C plus 1. It's just the next version of C. So this is so fundamental to a lot of programming languages, and I don't know why the Swift team decided to get rid of it, but it's gone. So in order to make your code super clear, you can basically just do this. So question number equals the current value of question number plus 1. So current value is 0. After the user presses any of these buttons, we're going to increase the question number to 1. So now we're on to the next question. And so we're going to use this question number to set the question label to the next question. So we're going to use the question label dot text property, and we're going to set it to equal all questions. So remember our question bank dot list, so the list property in the question bank. And instead of hard coding this, where previously we put in 0 to grab the first item, here we're going to use question number to grab the current question. And then we're going to tap into the question text property, and all is well in the world. So compare this, where we previously put in 0, so hard-coded just to grab the first item, with this, which is now dynamic, i.e. it will update every single time an answer is pressed. So let's run our app and see if the reality is how we expect it to be. All right, so Valentine's Day is banned in Saudi Arabia. Let's go for true. You got it. And you've got the question label updating to the next question. And let's answer true again. You got it. And I'm going to keep tapping true until the end of all the questions. Okay, so there are two problems here. Firstly is that my app has crashed because of this error. Fatal error, index out of range. Now, we've seen this in previous modules, so we're going to sort that out later. But the first thing that I want to draw your attention to is, why is it that I've got all the questions right, even though all I did is press the true button? That cannot be, because if you have a look, I'm going to stop the app for now, because if you have a look inside our question bank, you know, the first few answers might be true, but when you go down to the later answers, there's some falses in there. But for some reason, I got all my questions right, even though I answered true every single time. Now, the reason for this is, of course, within our code. In programming, it's great that you don't get to blame anybody else other than yourself for anything that goes wrong. So let's have a look at where we went wrong. Remember, we have this question number that keeps track of the state of the app, i.e. which question the user is on, and updates the question label each time. Well, in our correct answer, we don't do that. It's still hard-coded to the 0th answer. So see if you can fix this line so that when you run the app, it gives you the correct feedback regarding whether if you got the answers right or wrong. Okay, so again, another simple challenge. So basically we're going to change this 0 to question number, which of course is always equal to the current question that the user is on. So now if we run the app, so I'm going to again say true to all the questions. There we go. So we've got, you got it, you got it, you got it. And then this one you got wrong. So in these, the correct answer was obviously false. So there we fixed our first bug. Now the next thing is, how do we solve this fatal error index outer range issue? So if you're up for a challenge, see if you can figure out how you can stop the app from crashing. And in the next lesson, I'll show you the solution, as well as diving a bit deeper into showing you how we can use this marvelous debug panel. So good luck, and I'll see you on the next lesson. All right, so how did you get on? So even if you got it right and you fixed the problem and your app is now working, it's still worth having a look at how we can use the debug console to make our life easier while debugging. So for those of you guys who have worked out the correct answer, the problem lies within this question number variable. So I'm at the point where the app has crashed, and I want to see what is the value of question number right now. In order to do that, I'm going to go into this debug console after the LLDB, and I'm going to type print, and I want to print out the value of the question number variable as it is right now. So I'm just going to find question number. Now you'll notice that this command for print is slightly different from how we do it inside the Swift code. So instead, it doesn't have the round braces. You just write print and you print out whatever variable it is that you want. So hit enter, and you'll see that it's an integer with the value of 13 currently. So question number right now is 13. So essentially what we're doing right now is we're inserting essentially what we're doing right now is that we're inserting 13 in here, and we're going into that list array with all the questions, and we're trying to pull out the question that is at index 13. So essentially you can print out the current values of all your variables in order to guide your debugging. So for example, if I decide to print out all questions, so my question bank dot list, which is that array, you can see that it is made up of 13 values. It tells you it's made up of 13 values, and it starts from 0, which is Valentine's Day is banned in Saudi Arabia, with an answer, and goes all the way to the 13th question at index 12, because it starts counting from 0. So now if we try to use this question number, that's 13, to pull out number 13 in this array, then of course it doesn't exist, and which is why you get the error. Now, another way of looking at this, if you don't want to use the print inside here, is you can actually expand this self over here. Now, self refers to Quizlet view controller, so it's referring to this view controller object. And if you expand this little arrow, you can see that there is something in here called all questions, which is our question bank object. And this question bank object has an array called list, which is made up of question objects, and it has, again, 13 values, starts from 0, which has a question text and an answer, and goes all the way to 12. But our question number is right now at 13, and this list array does not have an item at index 13. So these are two ways that you can use the debug console to guide your debugging work. Now, this is going to come in super handy as your code starts getting larger and larger. There will be flaws in your logic as you're programming. It's human nature to make mistakes. We can't keep track of everything. So the computer is there to help you. Now, let's go back to how we can fix this problem. So firstly, I'm going to stop the app from running so I get rid of all these errors and warnings. And the problem obviously is that every single time that I press one of the answer buttons, I trigger this answer pressed IB action. And inside this block of code, there is this line of code that increases the question number by 1 every single time, to the point where it increases it to 13, and when 13 goes in here, it causes our app to crash. So how can I fix this? Well, what if instead of, well, I have to check to make sure that this question number variable never goes above 12. And if it's about to go to 13, instead of going to 13 and crashing our app, instead we should tell the user that they've gotten to the end of the quiz and offer them the opportunity to restart if they wish. So instead of having this line of code here, I'm going to instead put it inside this method called next question, where we implement this checking functionality. So I'm just going to Command X to cut this line and instead paste it into next question. And then I'm going to call next question here, and essentially nothing has changed. I've merely put that line of functionality into its own method. Here is where we're going to change it though. Instead of passing in whatever it is that we have into here and potentially crashing our app, we're going to implement a line of code that checks to see if question number is less or equal to 12. So we can use an if statement and check if question number is less than or equal to 12. And if so, then please carry out this bit of code. Otherwise, let's print to the console and say end of quiz. And after we tell the user that it's the end of the quiz, we're going to reset the question number back to 0. So it takes them right back to the beginning of the question set. So then I'm going to use our question number state tracker and set it to equal 0. Okay, so now if we run our app, let's see what happens now. All right, so I'm just going to keep pressing true again. And you can see that our app essentially goes on until forever. It gets to the end of the quiz and it says end of quiz, and then it loops back around. Now, while that gets rid of our bug, it's not a particularly good user experience. As the user doesn't get to see the console, they only see what's available on screen. And to them, it just seems like as if the app keeps on going and going and going forever. So in order to make the experience slightly better for the user, we should give them a little pop-up, or what's called a UI alert, that shows them that you've gotten to the end of the quiz, and if you wish to restart, then you can hit the restart button. So in the next lesson, we're going to talk about how to build a UI alert programmatically. So what's the code that you need to implement in order to show them the alert? So all of that and more on the next lesson. I'll see you there. So, in the last lesson, we learned how to implement a checking mechanism and prevent our app from crashing when it's gotten to the end of the question bank. We implemented this checking process using an if statement that checks to see if the current question number is less than or equal to 12. And if that's not true, then the app should print end of quiz to the console and reset the question number to 0. Now, as we mentioned before, these print statements are only visible to the programmer and they're not visible on screen. So how can we inform the user that they've gotten to the end of the quiz and ask them whether if they want to restart or not? Well, this is where UI alert controllers come in handy. So this is what a typical UI alert controller looks like. You get a title, you get a message, you get a cancel button, and you get an OK button. And it detects whether if the user pressed the cancel or the OK button, and you can then determine what should happen next. Now, if we have a look inside the UIAlertController API reference that Apple gives us, it tells us a little bit about how we can use it. So there's an overview as to how this is typically used, and there is an example code section where it tells you how you can implement this. Now, this example code snippet is unfortunately provided in Objective-C, but if you scroll a little bit further down, you have everything that's equivalent over here, down here as well. So this is how you create an alert controller using Swift. You use the init method of the alert controller, and you can configure it to give it a title, a message, and a preferred style. And then you can configure the actions to determine what should happen when they click on either of the buttons. And I'm going to show you how we can implement this in our Quizlet app. So I'm going to get rid of these two lines, and I'm going to have an empty else statement. Inside this else statement is where I'm going to create our alert. So I'm going to use a constant, and I'm going to call it alert. and it's going to be set to equal UIAlertController. And then I'm going to open some round parentheses, and I'm going to select this one, which is equivalent to this bit of code. So essentially it takes a title string, a message string, and also it asks you what style of alert controller you want. So it says that when you're picking the preferred style, you can either choose an action sheet or a modal alert. Now, what's the difference between these two? Well, a modal alert is what we're used to seeing. It's a pop-up that comes up in the middle of the screen and you have a number of options to choose from. But an action sheet pops up from the bottom of the screen and similarly gives you a title message and asks you what actions you'd like to perform. So we're going to go for the alert controller this case. So let's head back into our code, and I'm just going to reopen that round brace to bring up this suggestion box. Now, as much as I love typing, Swift methods tend to be extremely long with really long words with plenty of opportunities to introduce typos. So I'm just going to select this and hit enter so that Xcode inserts everything automatically for me. Now feel free to add whatever title and message you feel like, but it should still make sense for the user when they've arrived at the end of the quiz. So I'm just going to write something like awesome, and message is going to be, you finished all the questions, do you want to start over? And our preferred style is going to be the alert style that we're going to choose. So now we have a alert view controller, but that's not the end, because we don't just want to have a pop-up that has a title and a message. We want to give the users an option to restart the quiz if they wish. So in order to do that, we have to create what's called a UI alert action. And if we have a look at the UI alert action API reference, you can see that you initialize it by giving it a title, so a title for the button. You give it a style, and you also give it a handler, i.e. what to do when they press on that button. So let's dig a little bit deeper and see what UI alert action styles are available to us. So if you click on that hyperlink, you can see that there's 3 types of styles that you can have. You can have the default style, or you can have a cancel button, or you can have a destroy button. So we're going to stick with the default button, and I'm going to go ahead and create this action. So I'm going to call it restart action, and it's going to be equal to UI alert action. Now, this is a part where people tend to introduce typos. We're not creating another UI alert controller. We're creating the UI alert action. Now, if I open my round bracket, I can see this suggestion, hit enter, and I'm going to give it a title that says restart. And the style is going to be default. And the handler is going to determine what happens when that button is pressed. So what I'm going to do is I'm going to select this placeholder, and I'm going to hit enter for Xcode to insert the code automatically. And then I'm going to hit enter again to insert this UI alert action part. So this is what your code should look like right now. And this code placeholder, you can just go ahead and delete, because that's where our code is going to go. Now in here, I could put in all the functionality that I want when the restart action is pressed, but that's a little bit messy. Instead, what I'm going to do is I'm going to call the method start over so that we can direct the code over here and perform all the actions you need to in order to start the quiz over again. So I'm going to write self.startOver. Now, one thing that you might notice is that previously when we called methods or functions, we simply just used its name. Where does this self keyword come from? Well, we're going to dig into this a little bit deeper in future modules. But for now, just remember that whenever you see the word in, you should always think to use the word self. And even if you don't, Xcode will warn you and tell you that you need to insert the self. And the reason for this is because normally when you put in the name of the method, Xcode knows to search automatically within the current file, i.e. self, to find it. But it can be confusing when you're inside one of these, which is called a closure. Now, we're not going to worry ourselves too much about closures right now. That's something that's a little bit more intermediate / advanced, and we're going to cover it later on. For now, all you need to know is that we're calling this method called start over. And when there's the word in, that means we're inside a closure. And when we're inside a closure, we have to add the keyword self. Okay, so now we've created this action. The next step is to add the action to the alert. So we'll say alert.add action, and we're going to add the restart action in here. And finally, we're going to present the alert to the viewer. So present, open round brace, and we're going to use this one. So it's going to be alert, animated. Yeah, we'd like some animations, please. And on completion, i.e. what to do after it's completed the presentation of the alert, we're going to put a nil. We don't really want anything fancy to happen. Okay, so now let's check it out. All right, so again, pressing through all the true buttons, and we get to the last question, and we've got our alert showing on screen. So awesome, you finish all the questions. Do you want to start over? And I hit restart, but nothing happens. It only just dismisses the alert. And that is, of course, because we're calling this self start over, and it's currently completely empty. We're going to prepare the quiz app to restart a new round of all the questions. So in order to do that, i.e. in order to start from the beginning of the question bank, as we did before, all we're going to do is reset the question number that tracks which question we're currently on. We're going to reset it to 0. So question number equals 0 now when you restart over. Now let's run our app and see what happens. So when I get to the end of the quiz, when I hit restart, we're all expecting that we would start back up at the beginning of the app. But actually, in fact, nothing happened. So what's going on? Well, if you have a look, what happens is that when we press that restart button, we trigger the restart action. Now, what does the restart action do? Well, it calls start over. And inside start over, all that we do currently is we reset the question number to 0. So other than changing that behind the scenes variable, it doesn't have any actions associated with it. And it's only when we press one of the buttons again, i.e. triggering this IB action, do we end up going to the next question. But instead of going to the next question, it's actually going to the second question, because in this answer pressed IB action, we increase the question number from 0 to 1 before we call the next question, which actually displays the question text and updates the answers. So in order to fix this bug, all we need to do is to call the method next question whenever we start over. So now what happens when we press that restart button and the computer goes over to start over is that we reset the question number variable back to 0, so we're back at the beginning, and we instruct the app to go to the next question method. And then it checks to see if question number is less than or equal to 12, which it is because it's currently 0. In that case, then you're going to set the next question text in the app. So let's run the app again to see if our modified changes has improved the user experience. Okay, so now let's see what happens when I hit this restart button. The app goes back to question 1 and carries on working through all the questions. So there you have it. You've got a quiz app that has 13 questions from a question bank. You can check to see if the user got the correct answers or not. The user can restart the quiz by using our UIAlertController. Now, there's a few things that you might have noticed that's still not quite right with our app. Namely, that the score doesn't change, we don't tell the user which question they're currently on, and this progress bar stays still instead of advancing across the screen. So we're going to update some of these user interface elements in the next lesson, and I'll see you there. Alright, so currently our app is able to loop through all 13 questions in our question bank, And we've got a UI alert controller that lets us know when we've completed all 13 questions. And we can hit the restart button to loop back to the front of the question bank. So the first thing that I want to do is I want to tidy up the code file and see if there's any loose bits of logic that we can refactor in order to make our code run slightly more efficiently and to make more sense when we come back to it in the future. So let's just review and see how our view controller class works at the moment. So the first thing that happens when our app loads up is the viewDidLoad method. So inside this method, we're creating a new object called firstQuestion that is set to equal to the 0th element in the list array of all questions in our question bank. And then we set the question label.text properties, so this part, to equal the first question's question text property. And so we've got this Valentine's Day is banned in Saudi Arabia displayed up here. Now next, we're able to choose true or false, and depending on which button we press, the IB action answer pressed gets triggered. Now if the sender tag is 1, i.e. if the user pressed the true button, then we set the picked answer to equal true. Otherwise, we set the picked answer to equal false. Next, we trigger a function called checkAnswer. And checkAnswer basically just creates a constant called correctAnswer that's derived from the answer in the question bank, and then checks to see if the one that the user picked, i.e. picked answer, is equal to the correct answer. And if it is so, then in the console we print you got it, otherwise we print wrong. Once checkAnswer has completed, then we go on to the next line in this code and we increase the question number by 1 so that we can track that the user is on question 2 now. Now then we call this method called nextQuestion, and so the computer goes over to this line and executes everything that's inside nextQuestion. Now nextQuestion checks to see if our question number, i.e. the current question the user is on, is less than or equal to 12. Remember, arrays start counting from 0, so this is equivalent to checking to see if we are on question 13 or below. And if so, then we are going to update the question label with the next question text. But otherwise, we are going to show an alert and allow the user to restart the question bank. And the restart action calls a method called startOver, which basically sets the question number back down to 0 and calls the next question to update the question text that's shown up here. Now, let's see if we can make this a little bit more efficient. So in the viewDidLoad, we manually pull out the 0th question from the question bank and we update the question label.text. Now, if you have a close study of these two lines, it's essentially the same as what this line does. And at viewDidLoad, the question number will be less than or equal to 12. So instead of having to write all of this code out, we can simply call nextQuestion. So as soon as that the view loads up, it goes to find the next question method and checks to see question number currently is 0, so it's less than 12, and therefore brings up the first question text. So let's just run the app and make sure that that's exactly what happens. So the view loads up and predictably nothing has changed in our app. Everything is still working. It's managed to pull out the first question and put it onto the question label by using this next question function. So we've saved ourselves one line of code. Now there's just one last thing that we need to address. If we have a look on our storyboard, you can see that there's a progress label that's been placed in there. There's a score label, and there's also a progress bar that should progress all the way to the end of the screen. But currently, none of these are working because we haven't put in the code to make it work. So in the next lesson, we're going to be addressing these user interface updates, and we're going to be making a method to update all of these labels with the current state. So all of that and more on the next lesson. Alright, so now that we've refactored our code and we're happy with the logic, there's one more thing to address. So for the keen-eyed among you guys, you might have noticed that while we're going through the app, none of these score labels or progress labels or the progress bar actually update. And that's because we haven't told it to do so. So let's do that now. So in order to keep score, we'll need a variable that keeps track of the state of the score. So similar to how we had a question number variable that keeps track of which question the user is on, we're going to create a variable called score that's going to be of type integer, and it's going to start from 0. Now, when should the score update? Well, it should probably increase every single time the user gets a question right. So if we have a look inside our check answer, there's an if statement here that checks to see if the correct answer equals the answer that was picked by the user, i.e. this is the part of the code that dictates what should happen when the user gets the question right. And currently all it does is that we print to the console, you got it. So inside this block, we can increase the score by 1. So this is a shorthand way of saying essentially score equals score plus 1. So the new value of score should equal the current value of score plus 1. So these two lines essentially do the same thing. One is a slightly shorter way of doing it, and the other one is, I think, a slightly clearer way of going about it. So I think if you're starting out as a programmer and you want to be able to understand your code at a glance, I think the second one is slightly better. So I'm just going to delete the first one. And we only keep one of these lines, because otherwise we'll be increasing the score by 2 every single time they get an answer right. Okay, so now that score is updated and we've got this variable that's keeping track of the state of the score, we need to be able to show this to the user. Well, we're going to use the score label. So we will update the score label with the current score. Now, where does it make sense for this to happen? Well, we could put it inside this part of the code and we update the score every single time they get a correct answer, but this doesn't really make a lot of sense because it's not really a part of the check answer functionality. We kind of want it to be its own functionality, the updating of the user interface. So if you have a look within the code file, there is a function that we created called update UI or update user interface. Currently it's completely empty and it doesn't do anything yet, but we can change that by updating the score label in here. So score label is a UI label, and we can use the dot to access its properties. And among its many properties, such as its size, such as its color, we're going to access the text property, which is expecting a string. Now, if we set this to equal score, which we know to be an integer or a whole number, then Xcode is not going to like this very much, and it's going to give you an error that says cannot assign value of type integer number to something that's expecting a string, because the score label is expecting text and you're trying to put a number in there and there's a mismatch of types, so it's complaining. So let's fix this by using something that we did previously, which is escaping the string. So we use 2 quotation marks to explicitly state that everything inside the quotation marks will be a string, will be text. And we will use the backslash and round braces to say that we are escaping the string, and inside here we're going to insert our score variable. If I run the app again, you'll notice that nothing has changed. And the reason for that is because even though we've created or declared this function update UI, we've never called it. If I search in my app for update UI, you can see that this is the only instance where it comes up. And you can see over here in the search bar, there's only one instance of it. So that means we have to call it somewhere. Now, where does it make sense for the UI to update? Every single time we check to see if the question number is less than or equal to 12, and if so, we should update the question label with the next question. Maybe after we update the question label, the next thing we should do is to update the user interface. So it makes sense for me for that method to be called after the question label is updated. Now let's run our app and see if that works as expected. Okay, so let's go through answering our questions. The score started from 0, and as soon as I get an answer right, so remember when I get an answer right, it says you got it in the console, my score increases by 1. My score is currently 5, and then I get the next one wrong, and the score doesn't update to 6, which means it's working as expected. Now, there's a slight problem. The score is currently displayed just as the score number. Now, to a user, that will be very confusing because they won't know what the hell that is. So let's fix our code by adding the word score in front of this number. And to do that, all we have to do is go into this bit of text and write score, colon, and give it a space. Now, if we rerun our app, you can see that the score now says 0, 1, 2, 3, 4, 5. All right, so now that our score label is working, the next thing to address is the progress label. We want to be able to show the user how many questions there are in total in the question bank and which question they're currently on to show their progress. So remember that we have this state tracker, or this variable called question number, that tracks the current question the user is on. So we can use that to update the progress label, which is essentially this part, in order to show the user which question they are on. So again, inside the update UI method, we're going to tap into the progress label and again into its text property, and we're going to set it to equal. Again, escaping the string and adding in question number out of 13. So that's the total number of questions in our question bank. So let's run our app and see how that functions. Okay, so it starts out with 0 out of 13, goes to 1, 2, 3, 4, 5, 6, and all the way to 12 out of 13. Now, why is it shifted by 1? Why is it that when we're at our first question, it says that we're at our 0th question, and when we're at our 13th question, it says that we're on our 12th question? Well, the reason for that is because we started question number at 0, and we did that because we're trying to tap into our array in our question bank. And remember that arrays start counting from 0, so the most convenient way was to use the index 0 to start with. But for the user, that won't make any sense. Normal people don't start counting from 0. So instead, all we need to do is just to add 1 to the question number. So when it's 0, it becomes 1. When it's 12, it becomes 13. And now our progress label makes a bit more sense to your average user. So that's working well. Now, the last thing we have to address is this progress bar. We want this bar to progress along the bottom of the screen, showing us visually our progress in the question bank. So of course, this is again going to be tied to the question number variable. And the way that we're going to do this is we're going to work out the width of the screen, and we're going to divide it by 13, and then we're going to multiply it by the question number. So let me show you how this works. We're going to go back into our view controller, and inside update UI, we're going to look for the progress bar, and we're going to set its frame, i.e. the rectangular shape, and we're going to set its size and then its width. So this is the width property of the size of the frame of the progress bar, and this is going to be set to equal the view, which is basically the background view, the size of the screen. And again, we're going to go for view.frame.size.width. So this is now the width of the screen. And we're going to divide it by 13. And then we're just going to do a little bit of maths. We're going to multiply this by the question number. And Xcode gives us an error. It says that you cannot multiply a CG float with an integer. Remember, question number is a whole number, it's an integer, and the width property is of type CG float, core graphic floating point number, i.e. it's a number with decimal points. So in order to convert this integer into a core graphic float, all we have to do is write CG float and then enclose question number in some round braces. And again, remember that our question number starts off from 0. So in order for this to work, we have to add 1 to this part as well. And so now with this little bit of maths, our progress bar should progress along the bottom of the screen. Okay, so we're on question 1 at the moment, 1 out of 13, and you can see that we've got a little bit of the progress bar. Now let's just progress through 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, and that's completed the entire set of questions. Let's reset to 1, and it works perfectly. Okay, so sometimes we found that students have gotten confused by this bit of maths that we've done to calculate the width of the progress bar. Now I'm just going to explain it over very quickly. If this makes perfect sense to you, then don't worry about it, just skip over it. But essentially, I just want to make sure that this is clear in everybody's mind. Essentially, this line of code says that the width of the progress bar, so this yellow part, should equal the total width of the screen divided by 13, because we have a total of 13 questions, multiplied by the current question that the user is on. So essentially, this is what it would look like. So this is the width of the progress bar currently, and this is the width of the view currently. If we divide it by 13, we essentially chop the width into 13 pieces. And then every time that the user completes another question, we add another 13th to the width of the progress bar. So if the current question the user is on is number 5, and then we essentially have 5 of these pieces, and we increase the size of the progress bar to represent that we are on number question 5 out of a total of 13. Okay, so there's one last problem. If you keep playing the game over and over again, you'll see that your score keeps on increasing and increasing. Now, this might be by design because you want to encourage the users to go through the question bank again and again, but it might also be a bug because you want to show them the score that they got each time they went through the question bank so that they can compare how they're doing now versus previously. So to end this lesson, I'm going to leave you on a challenge and have a think about how can you update the score in the code so that it resets to 0 every single time you restart the question bank. And in the next lesson, we're going to be using somebody else's code, namely a code library, in order to give the user feedback in terms of how well they're doing, if they got the question right or if they got the question wrong. So I'll see you on the next lesson. All right, so did you get the challenge right? Did you figure out where to reset the score label? So it was very simple. Our code is currently completely modular, and they've got these names that explain what it does very clearly. We've got a method that updates the user interface. We've got a method that's responsible for progressing to the next question. And we've got another function that checks the answer. And finally, we've got a function that is responsible for what should happen when we restart the game. So naturally, this is where we should update the score label to 0 so that we restart the game with a fresh scoreboard. Okay, so that was pretty easy. Now, the next thing that we're going to do is we're going to figure out how we can give the user feedback every single time they answer a question. Now, at the moment, when we answer a question, and if we get it right, we can see it in the debug console. But remember, your users can't see this part. This is only for the developer to debug and to address any issues. So we have to be able to give our users feedback, whether if they got it right or wrong. And in order to do that, we're going to use what's called a HUD, or a heads-up display. So similar to when pilots fly airplanes and they get these heads-up displays telling them about the weather condition or that they're running out of fuel. Well, hopefully not. We are going to build something similar into our app, namely a small pop-up that shows the user every single time they click on one of these answers, whether if they got it right or wrong. So how are we going to do this? Well, in order to build that functionality ourselves and to make it look good, it'll take us weeks. So instead, we're going to use something called a code library. So this is a third-party code library that somebody else has written, and they have very kindly made it open source. That means that the code is visible to all, and other people are allowed to use that code within their own projects and essentially get access to really cool functionality without having to code up all of it yourself. So in order to do this, we're going to head over to github.com, which is probably the largest searchable repository of all of these open source libraries. So we're going to search GitHub. Now we're going to search GitHub for something called Progress HUD. And the first one that we see is Progress HUD. And when you scroll down on the README of this repository, you can see that the maker gives us a demo of how it would look. So it can show you a spinner wheel showing the progress of something loading in the background, or it can show you a confirmative success action or a error notification. So this is essentially how it would look like in our app. And that's pretty perfect for what we want to be able to do. So let's try and implement it into our code. So I'm going to show you a very manual way of importing this project. In future modules and projects, I'm going to show you a slightly more sophisticated way of doing the same thing. But it's important to understand how we actually incorporate other libraries of code into our project. So let's go about it in the long way first. So I'm going to click on Clone or Download, and I'm going to download the zip file to my downloads folder. I'm going to click on the zip file to unzip and extract the file. And now you should have something called Progress HUD Master in your downloads folder. Now I'm going to open up this Progress HUD folder, and there's another one called Progress HUD inside it. And I'm going to select all three of these, Progress HUD.h, Progress HUD.m, and Progress HUD.bundle. And then I'm going to go into my Xcode, and I'm going to drag all three of these files into my supporting files folder. And it's important that when this pop-up shows up, which is the choose options for adding files pop-up, make sure that this checkbox next to copy items as needed is ticked, and make sure that we're targeting our Quizlet app. So let's click Finish to add those things. And now Xcode is being very helpful, and it's asking you, would you like to configure an Objective-C bridging header? And the reason for this is because the Progress HUD code is written in Objective-C, whereas our project is written in Swift. So what Xcode can kindly do is create a bridging header that allows us to use Objective-C code in our Swift project. Okay, so now that that's completed, let's first have a look at this code. So there's quite a bit of code that helps us create these heads-up displays. And Objective-C codes always have a header file, so the file.h, and they have a method file, so the file.m. And in Swift, they're combined into one, such as viewcontroller.swift. But in order to use this Progress HUD file, we first have to import it in this bridging header. So over here, we're going to write a tiny bit of Objective-C code, and you'll see that it's very similar to what we do when we use the import statement in Swift, but it just looks a little bit different. So we start out by using the £, and we write import, and we're going to use quotation marks to enclose the name of this library, which is progresshud.h. Now, what we're doing here is we're importing the header file of this Progress HUD, and you have to be sure that you've typed out this exactly as it says over here. There can't be any typos. Otherwise, Xcode won't recognize what this is. Now, of course, an obvious improvement when we're importing Swift modules is that it actually gives you auto-suggest, which makes life a little bit less error-prone. But it's okay, because this method will allow us to import Objective-C libraries into our code. And because developers have been using Objective-C for a number of years in order to develop iOS apps, a lot of these third-party libraries of open source code is also written in Objective-C. So it'll be useful for you to know how to do this for future projects. Okay, so step one was dragging those files, the .h and .m and the bundle, into the supporting files folder. Step two was creating the bridging header. And step 3 was importing the header file progresshud.h into this bridging header. Okay, so now those 3 steps are done, and we are now ready to use the code inside Progress HUD. And I'm going to show you just how easy it is to use a third-party library. So remember that we have this method called checkAnswer, which is responsible for checking to see if the user got the questions right or if they got it wrong. So instead of printing to the console saying that you got it, what we're going to do is we're going to use the Progress HUD. So here we go, Progress HUD dot show success. And we're going to choose the one that allows us to give the user a bit of text, so the status one. And inside here, we're going to write correct. And if they got it wrong, instead of printing to the console, which nobody can see, we're going to again use Progress HUD dot show error, and we're going to tell them wrong. Okay, so that was basically it. And that's all you had to do in order to display quite a fancy little pop-up. So let's see it in action. So Valentine's Day is banned in Saudi Arabia. True, correct. Slug's blood is green. True, correct. Approximately 1/4. Okay, I'm going to get one of these purposely wrong to show you what it looks like. Wrong. Correct, wrong. Look at how this component beautifully puts in the images, the text, the pop-up box, as well as the animations for showing it and dismissing it, and all of that functionality, all of that code that we didn't have to write, and all we had to do was drag and drop it into our project and write 2 lines of code in order to use it. So this is the beauty of third-party libraries. And as somebody who's used a lot of third-party libraries, you'll notice that even with enterprise apps or apps that have been built by large companies, you can see that they also use third-party library components in there, because there's no point reinventing the wheel. If somebody has already written all of this code, made it available, and solved these problems, you can then reap the benefits of somebody else's hard work, and in the process have access to something really beautiful and save yourself a whole lot of time. And depending on the license of the third-party libraries, some of them are for commercial use as long as you give credit to the author, and there's a whole variety of different types of open source licenses, and you can have a read into it to see in which situations you can and can't use it. And it's really important to give credit to the original author of the code, because after they've labored for so long, the least that you can do to give them credit and show the world how great their code is. So essentially, once we understand how to use open source libraries and how to find them, which I'll tell you more about in the coming modules, then you open a door to potentially endless possibilities. It's like having access to this giant Lego library, and you can take whatever it is that you want to build your own projects. So now that we've completed the Quizlet app, I just want to say that this is a step up in terms of complexity. You might want to review some of the lessons in this module because we introduce a lot of new concepts. The code gets more complex, the logic gets slightly more sophisticated, and we're introducing a lot of new components. So if any part of the code is not clear, just have a look back, just rewatch some of these videos, and especially something like the model view controller or classes and objects. It's so abstract that it usually takes a couple of exposures to these concepts before they start clicking in your mind. And in future modules, we're going to be using these concepts again and again and again, so there won't be a lack of exposure ahead. There'll be plenty of challenges ahead, and there'll be plenty of chances to review all of these concepts. So don't worry if it doesn't all seem as clear as day. So I hope you enjoyed building the Quizlet app. And if you come from a different specialty like medicine or law, and you've got a bunch of questions lying around, it'll be really cool to build them into a quiz app, which you can put onto the App Store and help other people revise for exams or to practice questions. And you'll see that there's actually quite a lot of interest. There's not a lot of overlap in terms of people who are programmers and say actuaries, or people who are programmers and doctors. So these quiz apps occupy a really good niche. And if you build anything really cool, let us know about it, and we'll do our best to shout about it to the whole world. So I hope you enjoyed this module, and I will see you on the next lesson when we're going to embark on yet another coding challenge. All right, guys, another week, another app. So in this challenge, you're going to be building the Destiny app. Okay, so what is this? Now, for those of you guys who have grown up in the 80s, possibly 90s, we had these really, really awesome books called Choose Your Own Adventure books. And basically it was a storytelling experience where you could determine what happened in the ending based on the decisions that you choose for the protagonist or for the storyline. So they were really cool and really popular back then. Recently, we've seen a revival of Choose Your Own Adventure games in the app format. And the best known and probably best implemented, for me anyways, is Lifeline, which is the story of an astronaut who was lost somewhere in space, and the only person that he happens to be able to communicate is you. So through the interface of the app, you're able to receive messages from this lost astronaut, and it's very binary. There's two choices. You can decide to ask him certain questions or tell him to do certain things and guide him either to safety or to death. So it's a really engaging storytelling experience, and at the same time it feels a bit like a role-playing game because there's that decision aspect to it and the rich storytelling. So that's basically what we're going to be building. So we'll provide most of the storyline, but of course, after you've completed the app, you can feel free to go as crazy or change the storyline as much as you like. So essentially, we have a sort of murder mystery story, and you have a bit of story text at the top, and you have two options. You can choose option A or choose option B, and then the story goes on depending on what it is that you chose. So that's basically the app, and a lot of this challenge is about solidifying some of the knowledge that you've seen and that you've used up till now. So it's going to involve a lot of conditional statements, so if and else, as well as getting you to think about how to track the state of the user in the app. So essentially it's just a bit of a brain teaser / consolidating a lot of the knowledge that you've gained up to this point. So I would say that this challenge is actually quite challenging, but it's also a lot of fun. All right, so without further ado, let's get started with the challenge. All right, so I hope you gave that challenge a real go because I know it's a little bit tricky and it's almost got a little bit of a brain teaser element to it. But if you do complete it, then I'll know that you have good grasp of conditional statements, so if and else, as well as tracking the state of your application. So it's a really, really important exercise that you should attempt at least once. So if you're here, then you probably got stuck or you just want to see the way that I chose to do it. So first things first, let's figure out what we're going to make. So we've got this story structure, and the first screen that we see is a story and two options. If we choose one of the options, then we're going to go down one of the paths. And you can see that the really obvious thing is that the story 3 path is actually repeated in this app. So if you head down this route, or if you head down this route, you both get to story 3. And we're going to come to that in our code base a little bit later on. But again, it's a good idea to have a look at the story structure and get familiar with how it flows, and then have a look at the story outline where you see more contextual information around the story-based app. So this is the story, and this is answer 1A, which takes you down this path, once answer 1B, which takes you down this path, etc. So first step is to download the skeleton project. So we're going to go to our London App Brewery repository, and you can either git clone if you're familiar with Git and the terminal, or you can simply just download the zip file. And once you've got the zip file, we're going to extract it. So we have this Destiny iOS 11 master, and inside we've got the pre-made skeleton project. Now, even though we've pre-made the project for you, you can feel free, if you want to, make this entirely yourself. It's just a way of saving you time if you want to, but if you don't, then it's really, really simple to make this skeleton project. So here we have a text view, which you can find in here by just searching for text view. And it's got some lorem ipsum in here, so it's just some text that is going to show you what it will look like when it's rendered on screen. And then I've got these two buttons, top button and bottom button. And the important thing is that the top button has a tag of 1 and the bottom button was set up with a tag of 2. So as I say, you can do all of this yourself. You've done this plenty of times before. Then you just need to link up these IB outlets. So top button is here and bottom button is here and the story text view is over here. So this is what we're referring to with these three variable names, top button, bottom button, and story text view. Okay, so now if you want to set it up all by yourself, then go ahead and do so. But otherwise, if you're following along using the skeleton project, then we're going to get started using this, where I've already put in all the story text strings as well as the steps that we need to go through. Okay, so we've opened destiny.xcode project and we've had a look through it. Then step 2 is to look at the storyboard and the view controller. So the storyboard is of course main.storyboard, and we mentioned that the two buttons each have tags. This one has a tag of 1, this one has a tag of 2. And when top button gets pressed, it triggers this IB action called button pressed. So remember that when either of these buttons are pressed, top button or bottom button, because they're both linked to the same IB action, then this part of the code will trigger. And this is where we're going to differentiate between whether if the top button was pressed or the bottom button was pressed based on the sender's tag value. So this one would have a sender.tag of 1, this one would have a sender.tag equals 2. And that's how we know which answer they decided to choose. Okay, so that's step 2. Let's go on to step 3. And I'm going to switch into a single view just so you can see it a bit better. So the first thing that we have to do is set the story text view to display story1 by updating its text property. So we're here for our to do for step 3. So we need to set the text for the story text view here. So to set the text property of the story text view, then remember we need to tap into the dot notation. So we're saying story text view dot text, which is the current text that's displayed by the label. So remember when we said image view dot image, that's the image property, and this we're tapping into the text property. So that's what this bit of instruction means. And we're going to set it to display story1, which is this part here about your car blowing a tire. So story text view dot text is equal to story1. Pretty simple, right? Okay, so the next step is setting the text that's on the buttons. Unfortunately, with labels and text views, it's really easy to set the text. But with buttons, it's slightly bit more complicated. So I show you how to go into the documentation and see how it's done. But basically what you need is you need to use this method, which is called setTitle. So if we try and do setTitle for the top button, we'll say top button dot setTitle. You can see that this is the method that we want, and it sets the title to use for the specified state. So hit enter. And it has two placeholders. One is the part where you're going to say what is the title of the button, and another is for the state of the button that you want that title for. So if the button was highlighted, or if you got it held down, or if it's disabled, or if it was, then maybe you would want different titles for it. But in this case, we want to set the title of answer 1A for the top button. So where was that? Answer 1A, right? So let's change the title to answer 1A. And the control state we said was going to be dot normal, right? So dot normal. You can see that there's actually a whole bunch of other conditions. Disabled, focused, highlighted, and you can look through them to see what they're actually all about. And you can have a good read there if you're interested. But at the moment, we just want dot normal. And then we want to do the same for the bottom button. So bottom button dot set title, and the title is going to be equal to answer 1B in this case, and again for the normal state. Okay, so that's step 3 completed, and we're going to go on to the next step. Step 4, modify button pressed to take the story one step further. So button pressed is of course down here, and we're going to put our code just below this comment here where it says step 4. So you can see that we've already linked both the top and bottom buttons to the IB action called button press. So when you press the top button or the bottom button, this bit of code is going to be triggered. At the moment, it does absolutely nothing. But what we want to do is that when the user clicks answer 1A, i.e. the top button, then we want to take them to this part of the story. So we're going to change the story text and we're going to change the titles of the two buttons. So in this case, if the top button was pressed, so let's write some pseudocode. So this is not real code, but basically we're saying if top button was pressed, then we want to change the story text view to story 3 and change the top button title to answer 3A, and then do the same to bottom button, right? And change that to answer 3B. So this is the part of the diagram that I'm following right now. Now let's go and change that pseudocode into real code. So how can we tell if the top button was pressed? So this is the part where we tap into that sender.tag property. So remember, the top button has a tag of 1, bottom button has a tag of 2. And when either of them gets pressed, we trigger this IB action and we pass in the sender object. And the sender is basically the button which triggered this IB action. So if they press the top button, then it's going to trigger this IB action, and the sender object here is going to be equal to that button. But we want to check the tag property of that button. So we can say if sender.tag is equal to 1, then that means that they pressed the top button. Then in that case, we want to change the story text view to story 3. So we've already done this here, right? We can say story text view dot text is now equal to story 3, right? This is the path they're going down. And then we can change the top button title to answer 3A. So top button dot set title is answer 3A, and for control state dot normal. And we can do the same for the next part, which is bottom button dot set title, which is going to be answer 3B, and again for control state normal. So we just converted our pseudocode into real code. But as you can see, our formatting's gone a little bit awry, so we can hit Command A to select the entire set of code, and then we can hit Option Control I to re-indent everything so that it looks beautiful, so that we can see clearly which parts are inside which curly braces. And it's good practice to try and tidy up your code every so often, just so that you can see where the braces end. So for example, you should be able to look at every single closing brace and follow it directly up and see where the opening brace, or which line the opening brace is on. So for example, if this if statement contains everything between here and here, I can see that quite easily by just following that closing brace up. So now we've handled the part where if they press the top button, so if the sender tag was 1, i.e. the button that triggered this whole bit of method was the top button. But now we have to address what if they pressed answer 1B, right? In which case they should go towards story 2. So if we've already checked to see that it's not tag 1, and we know that the other one is tag 2, you might think that we can just say else, right? But it doesn't quite work like that, because if you have a look at the main storyboard, we mentioned that everything is by default given a tag of 0. So if you have another item on your screen, say if you had an information button or a back button or whatever else you would decide to put on here, it would have a tag of 0 and it would trigger that else statement. So instead, we have to be a little bit more specific, and we're going to use an else if in this case. So we're going to say else if the sender.tag was equal to 2. In this case, then we definitely know it's the bottom button that got pressed. So we can say that the story text view should be equal to story 2 because answer 1b, so the bottom button leads to story 2, and we're going to change the 2 titles again. Now you can either copy and paste, but I would recommend, just to get in extra coding practice or extra typing practice, to just type it all out. And you get used to this whole using the dot notations and the single versus double equal signs, a whole bunch of syntax just by typing out a lot of code, and it helps you learn as well. So story text view dot text is now equal to story 2, and top button dot set title is equal to answer 2a for control state normal. And bottom button dot set title is equal to answer 2b. And for control state dot normal. All right, so that's step 4 completed. And remember, as I say here, that 2 equal signs is when you're testing for equality, i.e., does some value equal 5? But a single equal sign is when you're assigning a value. So you're saying something is equal to 3 now. So that's a really important differentiation, and make sure that you don't let it trip you up. Okay, so step 4 is done. Let's go to step 5. So in step 5, we're going to define an index variable. And the reason for this is every single time that the user presses the top or the bottom button, this part of the code is going to be triggered. So if you imagine that the story is now on story 3 and the top button says, say, whatever is in answer 3a, if they press that top button, we're going to re-enter this part of the code. And because at the moment we're only checking for whether if the top button was pressed or if the bottom button is pressed, then we're going to be basically stuck here forever, going around, looping around. And it's not going to continue through our storyline. So you can go ahead and test that out and see for yourself how that works. But basically, we need to define an index variable or a number that keeps track of where the user is. So we can check to see where is the user and which button did they press to show them the correct information. So it's kind of like in your video games where you keep track of the level of the player. So if you're on level 1, maybe you've only got 1 monster that needs to be spawned. But if you're on level 10, then maybe you should have, 100. So it's just about keeping track of which level, or in our case, keeping track of which part of the story the user is on. So this part, step 5, is where we're going to initialize our variables. And in this case, we have a variable that's going to be called story index, and it's going to be initialized with the value of 1. So to create a new variable, we say var. The name was story index, and it's going to be set to equal 1. And that represents the fact that on starting our app, the user starts at story 1, and then they progress through the story by pressing on the answer buttons. So that was an easy step. So let's move on to step 6, where everybody tends to get stuck on this particular challenge. So now we're saying that use the if statement and this story index to try and check to see where the user is in the story and let them progress through the story depending on those 2 variables, i.e. which button did they press and which part of the story are they on. We're saying that you can use the and or the or operator to accomplish this. So if we have a look back at that story structure, you can see that at the beginning of the app, we start out on story 1. So story index is tracking this and it's set to 1 initially. But if they press the top button, i.e. answer 1A, then the whole app changes so that the text that's displayed is story 3. Now the buttons show answer 3A or answer 3B. And now they're actually on story 3. So when they're here and they press one of the top or the bottom buttons, they shouldn't be going back here again to story 3. And to differentiate between whether if they're here or whether if they're here, we need to use that story index. So if they are here, then the story index is 1 and the tag was 1, right? They pressed the top button. But if they were here, then the story index is 3, but the tag is still 1. So let me show you this in code. So instead of saying if sender.tag is equal to 1, we're going to say if sender.tag equals 1 and the story index is equal to 1, then we definitely know that they are right here, right? So story index is 1 and they press the top button, then in which case they should go down this path. But if they pressed the bottom button, i.e. the sender tag was 2 and the story index was 1, then they should go down this path. So we have to add that and statement in there, and we're going to specify their story index, which is 1. So this line checks to see if they are here. Now we go on to the next level in our game, right? So say if they press the top button, they go down this way. So let's address this part first. So now our user is here, and these are the two options, answer 3A and answer 3B. If they press answer 3A, we want to show story 6. So how do we check to make sure that they are there? Well, once the story text view changes to story 3, i.e. once they are here, we're going to change that story index so that it's no longer 1, but it's now assigned a value of 3. So now this is saying the user is inside story 3. And if they go down this path though, then the story is now assigned an index of 2. So we're going to say story index equals 2. So the next time that this block of code gets triggered, we're going to check to see if the story index was 3 and the sender tag was 1, in which case they are definitely here and they should see story 6. So we can say else if sender.tag is equal to 1 and story index is equal to 3. And in that case, the story text view dot text should now equal story 6. But inside story 6, because it's one of the endings, there are no more button options. So we're going to have to remove the buttons from the screen. And as we said in the instructions, you do this by saying top button dot is hidden, and you set that to true. And you do the same for the bottom button. And now the two buttons will disappear, and the story text view will show you the ending of the storyline. Now let's go on and address this part where the story index is 3 and the sender tag is 2. In this case, the story text view should display story 5, and again we're removing both buttons because it's an ending. Okay, so now that's done, let's move on to the next step, which is what if the user was here, i.e. the story index is 2 and they press the top button, so the sender tag is 1. Well, we haven't actually got any conditional statements that address that at the moment. So we're going to have to write another else if statement. Else if sender.tag is equal to 1, so they pressed this button, and the story index is equal to 2, so they're inside story 2 and press the top button rather than pressing the top button in story 1 or story 3. So in this case, we're going to display story 3 with these two options. Now you can see that this is completely identical to here. So this route and this route are the same. They both take you to story 3. So if you're lazy, you can simply copy and paste this down into here. Now if you want to type it out, then it's simply story text view dot text equals story 3 and top button equals answer 3a. And story index is now equal to 3. Okay, so those two parts were pretty much identical. And in keeping with the dry principle, there's actually a way that you can prevent yourself from writing these 4 lines of code repeated in 2 places. Now, one solution you might think of is making a method, but it doesn't really make sense to make a method just for such a small fragment of functionality. The other thing that you can do is, if you realize that this is checking if sender tag is equal to 1 and story index is equal to 1, and this one is checking if sender tag is equal to 1 and story index is equal to 2. So in that case, what you can do is you can actually put a bracket around here, and you can say if sender tag is equal to 1 and story index is equal to 1, or story index is equal to 2. So now we don't even need any of this anymore because we're doing the same thing in this statement. So we're saying if the sender tag is equal to 1 and the story index is equal to either 1 or it's equal to 2, then we're going to do this, right? So we can delete all of these 5 lines and save ourselves a little bit of space and a little bit of typing. But now we have an interesting problem. So once they are here, then if they press the top button, they go to story 6. But this route is exactly the same as this one, i.e. going from answer 3a to story 6. They're both the same. So the question is, do we have to write a separate else-if statement? And the answer is no, because at this point, the story index is 3, and they press the top button, so the sender tag is 1. And that condition is already addressed over here. So we don't need to retype this code because it's already taken care of. And nor do we need to do this part because it's right here. So the only thing that we need to do, and the last thing we need to do, is to address this last path, which is else if sender.tag is equal to 2 and the story index is equal to 2 as well. In which case the story text view dot text is equal to story 4, and we're going to hide the top button and also the bottom button. Okay, so that's all of our code that addresses this entire story. Now, one thing you might have noticed is that in the endings, I haven't changed the story index. And the reason is because the buttons are hidden, so we won't be able to trigger this IB action if there are no buttons to trigger it, right? But if you wanted to add a restart button where you restart the game, then it might be worth checking to see if you're at one of the ending indexes, say 4, 5, or 6, in which case you should be able to show a restart button, and then that restart then resets the story index and sets up this entire thing here. So if you wanted to do that, then you should set these story indexes. So this one is going to be equal to 6 because we're inside story 6. This one is going to be equal to 5, And this one is going to be equal to 4. And now, outside of this if statement, we can check that if story index is equal to 4, or story index is equal to 5, or story index is equal to 6, then we want to be able to show a button on screen, right? So now if you drag on a button, and maybe put it up here, and let's call that button restart. Maybe make it white so it's a bit more visible, and make it resize. And then we're going to link this up to code. We're going to put it right down here. So let's call that, make that an action, and let's call that restart pressed. Change this to a UI button, hit connect. Then the other thing that we need to do is to give this restart button a IB outlet. And the reason is because we want to set this restart button to be hidden by default. So when the view is loaded up, the restart button should not be visible, because in my game, let's say that it's only visible once you get to the end of the storyline, right? So you can add an IB outlet and then go into view did load and change the is hidden property. So we can say restart button dot is hidden equals true. And then once you do get into one of the ending stages, then you can say restart button dot is hidden is now false. So we show it on screen. But what happens when you press the restart button? Well, it should reset the story index back to 1. And it should restart the game using the initial story and answers. So I'm just going to copy that and put it in here. So you might notice that this is a little bit repetitive, right? This part is pretty much the same as this part here. So if you want, you can also make a method. So let's call it restart. And all it does is it has all of these parts here. And then instead of having that code in there, we can just simply call restart, and we can also get rid of all of this and call restart as well. So if we run our app now, okay, so your car has blown a tire on a winding road in the middle of nowhere with no cell phone reception. You decide to hitchhike. A rusty pickup truck rumbles to a stop next to you. A man with a wide-brimmed hat with soulless eyes opens the passenger door for you and asks, "Need a ride, boy?" And you're going to say, "Yeah, let's hop in." Being as safety conscious as we are, let's just get into this stranger's car. As you begin to drive, the stranger starts talking about his relationship with his mother. He gets angrier and angrier by the minute. He asks you to open the glove box. Inside, you find a bloody knife, 2 severed fingers, and a cassette tape of Elton John. He reaches for the glove box. And you think, "I love Elton John. Hand him the cassette tape." Or, if you're slightly more safety aware, you'll say, "It's him or me. You take the knife and stab him." I love Elton John, so let's go for this option. And now we get to one of the endings, which is where you bond with the murderer while crooning verses of "Can you feel the love tonight?" I'm not even going to try and sing that. You should be grateful. Trust me, it's not a good thing. He drops you off at the next town, and before you go, he asks you if you know any good places to dump bodies. You reply, "Try the pier." So you had a great relationship with the murderer, and now, magically, our restart button shows up, and if you click on it, we restart, but you'll notice that there's a slight bug here. We've restarted the story, but we haven't made our buttons reappear. If you have a look over here, we've set the buttons to be hidden in all of these ending scenarios. So in our restart method, we also have to add top button dot is hidden equals false, and bottom button is hidden equals false. And that should address that little problem. So if we go back the same path again, you can see now if we hit restart, we get the initial story, but the restart button is showing up at the beginning, which is a little bit strange, right? And that is because our restart button dot hidden is true is inside the view did load, which only gets called when the view shows up. So what we have to do is put that inside the restart method. So now when we go into view did load, we simply do all of this, but also when we restart the game, we also do all of this, which is all the restart actions. So let's try it again. And now if we hit restart, the restart button disappears, and we've got these two buttons showing up, and we've got the initial storyline. So I hope you enjoyed that, and it's definitely quite a bit of a challenging challenge. I hope you gave it a good go, and if you didn't, then please go back and try it again. And, maybe edit the storyline, change it to whatever you want it to say. Make a small choose your own adventure game for any of your favorite stories, or maybe something that you can just make up on the spot. Now, some of you guys have asked, would you do it in the same way if you were making a fully fledged app? Say if you had a storyline that had maybe 100 or 200 options and possibilities, would you still do it like this? Then the answer is no, because your data set is going to get very, very big, and it's going to be pretty unmanageable to try and trace the logic. And also doing this for a very large app is extremely tedious and not what you would want to do. So this challenge was mainly to solidify your understanding of if, else, and else if statements, so that you can really understand and get to grips with conditionals, as well as using the tags and being able to set titles on buttons, etc. But in real life, you would probably use a different data structure, probably something like a tree data structure. And I've included a link in this lesson to an article where you can read more about that. I hope you enjoyed this. And again, I know I'm going to sound like a broken record, but please, please try out the challenge for yourself. Even if you struggled in the beginning, try it now and do it from memory rather than step by step follow along, because this is really how you're going to get good at this and be able to understand all the tutorials that are yet to come. But I hope that was fun. I'll see you on the next module. Hello everyone, in this module we're going to talk about auto layout and setting constraints. So this is all about how to make your app look great on every single screen size and orientation. So here's our Dicey app in the iPhone 6 sized simulator, and as you can see it looks perfectly nice, but what happens when I rotate it so that it goes into landscape? Well, the design still remains the same as it was on the canvas in our main.storyboard, but now that the phone has changed orientations, the design hasn't adapted with that orientation change. And similarly, if you try to run the app on an iPhone 6 Plus or an iPhone 7 Plus, which has a larger screen size, your design will still remain the same size and it won't stretch to accommodate the larger screen size. So this is kind of a bad user interface. People bought the iPhone 6 with a larger screen for a reason. They want their apps to take up the whole screen. screen. So how can we fix this? How can we make our designs look beautiful no matter where it's displayed or in which orientation? Now, some of you guys might have already come across this problem, especially when you created your own apps from scratch, such as when we created Dicey. Now, one way of fixing this problem, say if you have an iPhone 6 Plus and you wanted it to look good on there, is to actually change the canvas size in your main.storyboard. So currently our design is on a iPhone 7 sized canvas, which is pretty much the same dimensions as the iPhone 6. Now, if we change the canvas to a iPhone 7 Plus, you can see that we've got these extra edges. Now, one way you could do this is by stretching some of the image assets so that they accommodate the change in the dimension. So then we could rearrange everything on screen so that it looks great for the iPhone 7 Plus. So now if we reran this app, it would look exactly as it does on screen. So you can change the design to fit a particular canvas size. But the problem is that if you put your app onto the App Store, it's going to go out to loads of people with different phones. So one person might be downloading it on a iPhone 6 Plus, another person might be downloading it on an iPhone 5, and they have completely different dimensions. And that's what we're going to address today. How do you make your designs look great no matter what screen size and no matter which orientation it's in? Now, in order to achieve that, there's two solutions. Solution one is programmatic, so we can use our code to determine how each of the user interface elements, such as an image or a button, should be displayed on screen. And I'm going to show you that in the next lesson. And the second way is using auto layout and setting constraints. So essentially setting rules for the computer to follow. So for example, saying that my button should always be in the center of the screen, or it should be pinned to the edges of the screen. And we're going to dive into that a little bit later on. But firstly, I want to show you how we can achieve the same thing using code. So the first way that we're going to approach this problem is programmatically. Now on the left, I've got an example iPhone, and I'm going to show you what happens when I write certain pieces of code. So I'm going to write my code inside View.did.load. So if you remember, this is the part of the life cycle of the app when the view gets loaded up. So essentially when you open up your app and just before the app appears on screen, this method gets called View.did.load. And we're going to put our code at this time point. So I'm going to write a line of code that creates a new UI view. So it's called square, and it's constructed using the UI view class. So remember, this is just a blueprint that we use in order to create objects. So using the UI view blueprint or class, we need to specify a number of things in order to create this UI view. So the most important thing that we need to tell it is the frame, i.e. what is going to be the size and position of this view on screen. So in order to specify the frame, we're going to create what's called a CG core graphics rectangle. It's actually going to be a square in our case. Now, in order to create this, we need to specify 4 pieces of information. So that's going to be the X position of the rectangle, the Y position, the width, and the height. Now, X position I'm going to set as 0. So remember that on iOS, 0, 0 is in the top left corner. And you can imagine it like a graph that extends in the X-axis towards this way and the Y-axis down here. So X, Y, 0, width 50, height 50. So that essentially will create us a little square up here. Now, the problem with UI views is that by default, they are see-through, so they are transparent. And so in order to make it not transparent and be visible, we'll have to set the square's background color property to a red UI color, user interface color. And finally, we're going to add that square onto our view. So remember, by default, every single view controller has a view. So then we're going to add a subview on top of this view, and the subview that we're going to add is square, which we created up here. So if I run this piece of code, then you will see a square 50 by 50 points appear in the top left corner of the iPhone. Now we can edit some of this code in order to make this square appear differently. So for example, we could change the width to 100 and change the height also to 100. So we can change the size of our square by manipulating these two parameters. So then if we run our app, our square would be a lot bigger, 100 by 100 points. The other thing that we can edit is the position. So if we change the X position to 50, so 50 from the left, and the Y also to 50, so 50 from the top, then what happens is that our square will move to the position of 50 by 50. So imagine that graph again, X-axis, Y-axis, and when we're specifying position, we're always specifying the coordinates of the top left corner of the element. So in this case, it is the top left corner of this square. And we said that it should be 50 on the x-axis and 50 on the y-axis. So it's positioned like this. Now we could go around creating buttons, views, images like so. We would only have to substitute the UI view part, i.e. the constructor, to something like UI image view or UI label or UI button in order to create those things and then put them onto the screen using a frame that we create. But what if we ran this code instead of on an iPhone 6 size screen, we ran it on an iPhone 6 Plus or an iPhone 7 Plus? So the screen has completely different dimensions, and when you execute the same code, the square will appear different on this screen versus the previous screen. It's still 50 points on the x-axis and 50 points from the y-axis, and it's still got a width of 100 and a height of 100, but this one is almost in the center of this screen, whereas previously it was almost slightly shifted to the right. So if this is your app logo or if this is an important button, when users see it on different screens, it'll look differently. So this is essentially the same problem that we have previously when we designed our app in the main.storyboard, and then later on when we ran our app on the iPhone 6 versus the iPhone 6 Plus, you see that the position of the elements are placed differently. So essentially what I'm trying to say is that even though you can specify an exact position and an exact size of whatever it is that you decide to put on screen, whether if you did it programmatically as we did here, or whether if you did it in the interface builder by dragging things onto the screen and placing it where you think would look good, at the end of the day, it will still look different on different screen sizes. So how can we solve this problem? Well, we can think about what other readings we can get from the phone. So we know that in order to create this square, we needed to provide 4 pieces of information. One is the X position, the second piece is the Y position, so how far down it should be, and then it's the width and the height. Now, as we said previously, the X and Y position determine where the top left corner of your object is going to be positioned. And then we've got the width and the height. So in order to position this square so that it looks similar on different screen sizes, what we need to do is we need to determine the width of the screen and the height of the screen. So we can actually do that in our code by calling self.view. So self is the current view controller that we're in. A view is the background view, so the one that covers the entire screen. And then we're going to get its frame. So remember previously when we created our square, we needed to determine a frame by giving it these 4 pieces of information. Well, the background view also has a frame with these 4 pieces of information. And we're going to tap into the width property. So by doing this, we grab hold of how wide the current screen is. So that means if we're running this on an iPhone 6 Plus, this value is going to be different versus when we run this code on an iPhone 6. Then if we divide that value, that width, by 2, we get to the midpoint around here. And we can do something similar with the Y position. So if we use self.view.frame again to get the size and position of the background view, and then we get its height property, which is this arrow here. And then we again divide that by 2 to get to the midpoint. So if we keep the width and the height of the square constant as it was before, so 100 by 100, now if we use these X and Y positions, which are calculated based on the size of the background view, then our square will get positioned accordingly. So now our square's position is determined by the size of the screen. There's a relationship here because the larger the screen, the larger the width and the larger the height, and so the square will always be positioned at a similar point. Now let's say that we want this square to be right bang in the middle. Then we can't just use self.view.frame.width because we're determining the position of the top left corner and not of the center of our object. So in order to get our object to be centered on the screen, we'll have to take into account the height and the width of this object so that we can shift it along. So say if our X position, instead of just being half the width of the screen, if our X position, i.e. the position of this top left corner, was half of the width of the screen minus half of the width of the object, and our height was half of the height of the screen minus half the height of the object. So then if we rerun our code using these parameters, then our square will get placed into the center of the screen. And using this little bit of maths, our square will always be positioned in the center of the screen, no matter the size of the screen, because its position is determined by the size of the screen. So now if I run the app, you'll see the square appear in the middle. So great, looks perfect. Now let's try it out on some different screen sizes. Let's go for the iPhone 6. And our square is again placed right in the middle. So in this lesson, I'm going to teach you how to use auto layout and the interface builder to visually design your constraints. But in order to do this, we first have to understand the theory behind auto layout. How does the computer calculate the position of the element? So conceptually, I would say that there's two ways that you can set up your constraints. One is through pinning. So for example, we've got our square in the center of our screen and we're going to pin it to the edge of the screen. So we're saying that the top edge of our square should always be 100 pixels or 100 points rather from the top edge of the screen. And similarly, we can go about doing that for all four edges. So essentially, we're saying that the edges are always going to be a certain distance apart from the edge of the screen. Now, this achieves a particular effect when we run the app on a larger screen size. So say if we are running this on an iPhone 6 Plus, remember that the constraints will always remain the same. So this was 100 and this was 30, and it's going to be the same and it's going to keep it constant on the larger screen size. So then our square expands so that it still meets the rules of those constraints, so that the top edge is still 100 points from the top edge of the screen and the right edge is still 30 points from the right edge of the screen. So this is one way of doing it, and this is through pinning the edges of your object to a fixed distance from the edges of the screen. Now, the other conceptual way of doing this is through alignment. Now, we're saying that we want to keep the width and the height constant, and then we say that we want the square to always be positioned in the horizontal center of the screen and always in the vertical center of the screen. So then, in this case, when we move to a larger screen size, we're still keeping the same width and the height constraints, and also we're saying that it's going to be in the center, horizontally and vertically, of this larger screen size. So then our square will look like this. So essentially, you achieve two very different looks through these two different ways of setting up constraints. But the most important thing is that no matter how you set up your constraints, you have to provide the computer with four pieces of information. And that's again the X position, the Y position, the width, and the height. So in the first way here, when we used pinning, the X and the Y position of the top left corner of the square is determined based on the distance from the top edge of the screen. So if the top edge of the square always has to be 100 points away from the top edge of the screen, then the Y position is always going to be 100. And if the left edge of the square always has to be 30 points from the left edge of the screen, then the X position of this top left corner is forever going to be 30. So X equals 30, Y equals 100, and the width and the height is determined dynamically based on these constraints. Now, if the screen size is a little bit bigger, then the width and the height will be bigger because it will stretch out the square. Now, in some cases, especially when the aspect ratio of the screen changes, such as when you go from portrait to landscape, this pinning method will not keep the dimensions constant. So for example, if this phone went into landscape and we still kept these same constraint pinned to the edges, then you'll find that your square will become a very squished rectangle because it still has to be 30 points from the left edge, 30 points from the right edge, when those edges are going to be much, much further apart. But the option on the left keeps the square the same size, so it doesn't scale when you go onto a larger screen size. And it will center it in the center of a screen or in the center of a container. We're going to talk a little bit more about containers in the next episode. But essentially, all you have to keep in mind is that whenever you're setting constraints, how is the computer going to determine these 4 pieces of information? And which conceptual method of setting constraints are you going to go for? The pinning to the edges method or the alignment method? So let's take a look at how the computer can arrive at these 4 values in each of these ways of auto layout. So the first way we're going to look at is the pinning method. And the X and Y values are pretty simple. The X position is simply equal to the distance between the left edge of the screen and the left edge of the object. And the Y position is simply equal to the pin from the top edge of the object to the top of the screen. So those two are quite easily solved. Now, what about the width and the height? Given that the computer knows the width of the screen, let's call it Z, then the width is simply equal to Z minus 2 X's. So this is equal to X, and this is equal to X, then this width must be Z minus X plus X. And the height can be similarly worked out by taking the height of the screen and subtracting from it 2 y's. So a minus y plus y will equal the height of the object. So this is essentially how the computer can calculate the width and the height based on all of these pinned constraints. Now let's have a look at the other example where we use the alignment method. So in this example, the simple things are the width and the height because the height is fixed and the width is fixed. So those two are ticked off instantly. Now, what about the X and Y values? Well, we would use a similar method to what we did programmatically. We would take the width of the screen, let's call it C, and we would halve it and then subtract from it half of B so that this point's X value equals C divided by 2 minus B divided by 2. And we spoke about that earlier on in the programmatic examples. I'm not going to go into it in too much detail. And similarly, we can do the same thing with the Y value of the position. We can take the height of the screen D and divide it by 2 and subtract half of A in order to get that Y position as well. So again, all 4 values can be calculated based on these constraints that we've set. So whether if it's in future examples, whether if it's in the tutorials, or whether if it's in the challenges, just keep in mind how is the computer going to calculate these 4 values based on the constraints that you've set. And if you've given it a way to calculate all 4 values, then everything is going to check out and it's going to work exactly as expected. Now, if one of these values are ambiguous, then Xcode will actually tell you in a warning or in an error, telling you that this is not going to look right when it gets made on the screen. So when you see errors relating to auto layout or constraints, always come back to first principles and think about, am I providing a way for the computer to work out the XY positions as well as the width and the height of the object? In the next episode, we're going to take our Dicey app, which was created at the end of Module 4. So when we created the Dicey app, we didn't put in any constraints. So that means when we run the app on a larger screen size or in landscape, it'll look very strange. So instead, we're going to use auto layout and add constraints to that project so that the Dicey app will look good no matter which screen size or orientation. So I'll see you on the next lesson. So here I've got in front of me a fresh copy of the Dicey app that doesn't include any auto layout or constraints. Now you can use the Dicey app that you completed in Module 4, or you can download a fresh copy in the link in the text box below. So my advice is download the fresh copy, because then your app will look exactly the same as mine and you'll be able to follow along with me. All right, so let's get started. So as you can see, I'm currently using an iPhone 7 canvas size. Now, if you have a look at the different canvas sizes, there's a iPhone 7 Plus, iPhone 7, the iPhone SE, and the iPhone 4S. Now, there's no iPhone 6 because it's the same screen size as the iPhone 7, and the iPhone 6 Plus is the same size as the iPhone 7 Plus, and the iPhone 5 is the same size as the iPhone SE. So don't be confused if you can't find the screen size of your particular phone. So we're going to stick to the iPhone 7 canvas, which is a 4.7-inch screen. And on here, we've got the designs for our Dicey app. And as you can see, when I change my app to a smaller screen size or to a larger screen size, none of the designs scale. So we're going to be putting in our auto layouts. So the first thing that I'm going to do is I'm going to show you some of the concepts that we explored in the slides before in real life. So if I go into my object library, remember you have to have your right pane open up and you have to be inside the object library by toggling this button. And I'm going to search for a UI view, and then I'm going to drag it onto the screen here. Now I'm going to size this by going to the size inspector, and I'm going to change the height and the width to 100 each, and then I'm going to position it onto the center of the screen by just getting these guidelines to pop up for me. There we go. Okay, so here's our square that's bang in the middle. And in order to keep it in the middle, I'm going to add some constraints. So the first method, if you remembered, is using pinning. So pinning is done through this button. It looks a bit like a box and whisker plot. So when you click on this button, you'll see this little pop-up that allows you to add new constraints. Now, the first thing we're going to do is we're going to uncheck the constrain to margins box. Now, the order of how you do all of this matters. So if you can, follow along with me so that you remember which order to do everything in. So first, we're going to uncheck constrain to margins. This means that instead of setting constraints to the margins of the screen, we actually want it to set it to the edges of the screen. So get rid of that. And next, at the top here, you can see that number is exceedingly small. So if you hit the drop down button, you can see that you can either set a constraint to the Dicey logo, which it currently is, or what we want instead is setting it to the top of the view. So right up here. So I want to set a constraint that pins the top edge of my square to the top edge of the view. And I want that to be a fixed 283 points. Now I'm going to do the same for the bottom. So right now, the 109 point is set to a distance from the roll button. Instead, I want my constraint to go all the way down to the bottom of the screen. So I'm going to select the view. And finally, I'm just going to click these two dashed lines in order to activate the left and the right constraints. And then I'm going to click Add 4 Constraints to make them active on my design. Now, at this point, before you click the Add 4 Constraints, if you click anywhere else and you get rid of this pop-up, nothing would have happened. It won't insert any new constraints. So you have to click on this button for it to work. Now, once that's complete, you'll see 4 blue lines appear on screen and they show the constraints. So for example, if I click on this one, you'll see that it's starting at the top of the screen and it ends at the top edge of my square, and it has a constant of 283 points. So that's saying that the top edge of my square should always be 283 points away from the top edge of the screen. And it's the same for the other ones. Now, if we accidentally, for example, forgot to add one of these constraints, for example, the one on the left, then you'll see that other constraints will start showing up as red. And you'll start getting these tiny warnings telling you that the width and the horizontal position are ambiguous for this view. And that's because previously the computer could work out the width of this square. So it's essentially width minus A and B, and then you get C. So let's undo that by hitting Command Z, and you can see we've now again got 4 active constraint. Now you can already preview what this would look like on different screen sizes. So for example, if I go over here and toggle to the iPhone 7 Plus size, you'll see that the square gets stretched into a rectangle. And that's because the aspect ratio of the iPhone 7 Plus is different from the aspect ratio of the iPhone 7. So my square is now a rectangle. Now, when I go into landscape, you'll see an even bigger problem occur using this pinning method. So it tells me that my top constraint for my top edge is 283, and my bottom edge to the bottom edge of the square is 284. That means that my square actually will get compressed to a negative size. And Xcode won't have any of that. Now, what if we wanted to use the other method? So we can get rid of these constraints by clicking on this little triangle sign, and we can say clear constraints. Now that gets rid of all 4 of those on the view. You can see that there's actually 2 layers here. One, when you click the clear constraints here, that clears the constraints on the current selected view, so just this square. If you click clear constraints in the bottom part, then it will clear the constraints for all views in this view controller. Now that's quite a dangerous one. That's basically the reset button. So now that we've gotten rid of those constraints, let's add in different constraints in order to use the alignment method. So remember that in order to do that, we wanted to keep the height and the width constant, and it will complain after you do that, give you a little warning, because we still haven't specified the position. We've only specified the size. So then we're going to go into this align button, which looks a bit like a bar graph, and then we're going to tick horizontally in center and vertically in center. And then we're going to add those 2 constraints. And you can see that Xcode is now happy because your warnings are gone and all your constraints are in blue. Now, when your constraints are in red or yellow, then that's usually a problem. And it means that you might have to go back a few steps and figure out what's going on screen. So this is working well. And if I show you some of the different sizes, then it works as expected, essentially keeping it the same size and keeping it right in the middle. Okay, so that's essentially showing you how the alignment method and the pinning method works in the wild. So enough messing around, let's get rid of this square and all of its constraints associated with it. And let's get on with laying out the constraints for our Dicey app. So one of the first things that you'll notice is that right in the middle of the screen, there's actually nothing that we want to be there. We don't want a dice to be in the middle of the screen like this, because it would be kind of weird. Instead, we want the dice to be evenly laid out like so. Now, in order to keep it designed like this, what we're going to do is we're going to introduce a container. So essentially a UI view that contains these 2 dice, which we can then center. So again, go into the object library and search for a UI view and then pull one onto the screen and essentially cover both dice. And then I'm going to select Dice Image View 1 and Dice Image View 2, and I'm going to nest it under this new view that I created. Now you can see that when the circle of this blue line is aligned with everything else, then this becomes a sibling relationship. But when that circle is off to the side a little bit, like so, then it's a child relationship. So I'll show you the difference. So this is the equivalent of putting something inside a folder. And this is the equivalent of creating another folder. So it's a little bit fiddly, but essentially if you point your cursor at the actual view word, then you will create a child. So now our 2 dice image views are nested under this new view, and you can see that you can open and close this view to see all of its child elements. Now, had we done this wrong and we made it a sibling, then it would look like this, and they would all be on the same hierarchy. Nobody's contained in anybody else. So in order for this to be a container, we have to have it contain the dice image views, and we should name this something else so that we don't get confused between this one versus this one, etc. So I'm going to change the name of this view by clicking on it. Wait 1 second, click on it again, and now you'll be able to edit it. And we're going to call it middle container. Hit enter. And that's it. Okay, so that didn't do anything. It was just mentally for us to know which one is the middle container. And I'm going to rearrange my dice so that they are touching the left and right edges of this new container. And then I'm going to make this container just a little bit smaller. So the dice height is 100. So I'm going to make this container's height also be 100. There we go. And then if we move the container to the center of the screen, you can see that there's the horizontal guideline and vertical guidelines have both popped up. And then I'm going to move this so that it's touching the top and bottom edges as well as the right and left edge. So our two dice image views are nested inside this middle container view, and the top edge of the dice is touching the top edge of the container. The left edge is touching the left edge of the container, and it's vice versa for the other dice. Now, we're going to make this middle container be positioned in the horizontal and the vertical centers of the screen, just as we did before with our square. And then we're going to fix its height and width. So you remember how to do this, so just go ahead and try it out. So first thing to do is click on this button, the box and whisker plot button, and we're going to fix the height and width of this container. Now, just check to make sure that you've got the container selected and not one of the dice, because we want to set the constraints for the container. Okay, so those two ticked, add two constraints. And next, while it's still selected, we're going to click on a line and make it horizontally and vertically aligned in the center of the screen. So now you can see no matter which size we're on, our dice image views are pretty much in the center of the screen. Right, so that was pretty easy. Now, another thing that you might have noticed when I went to the iPhone 6 Plus size is that even though our middle container is in the middle, our background looks very odd because it's shrunken. And so in order to fix that, what we're going to do is we're going to head back into the iPhone 7 canvas size, and I'm going to pin all four edges of the background to the edge of the screen. With zero distance, essentially. So we're going to head into the add constraints, and I'm going to click all four of these so that it's 0 points away from the edge of the screen always. Add constraints, and now you'll see that if I'm on the iPhone 6 Plus, it doesn't matter. It's always going to be stretched to the size of the screen. Now, the other thing I want to make sure is that the dice are always positioned in this way inside the container. So I'm going to set some constraints for the dice in relation to the container. And what I want is that I want the dice to be 0 points from the top edge, 0 points from the left edge. So it's essentially stuck to that corner. And then I'm going to fix the height and the width of that dice. So essentially I'm going to say pin this edge, and then pin the height and width. And then I'm going to do the same with the right dice. I'm going to say pin this top edge, pin the right edge, as well as the width and the height. And now our dice, as well as the middle container, is complete in terms of setting constraints. And so we can move on to our other elements. So as you can see, when I go to larger screen sizes or when I go to landscape, everything else is still messed up, but our dice is looking perfect. So at least that's something. Now, in order to make our other UI elements, such as this image view or this button, stay essentially where they are, we can't pin it, we can't make it centered on the center of the screen. So we're going to introduce another container, and we're going to have it be in the middle of the container. So go over to this object library again, and we're going to drag on another view, and I'm going to put this right at the top left edge of the screen, and I'm going to make it almost touch this middle container. So if I have a look at this middle container's position in the size inspector, I can see that its Y value is 283.5. So I'm going to make the height of this 283.5. So now they're essentially touching each other. And what I'm going to do is I'm going to pin this new container, which I will rename top container. Next, I'm going to pin this top container to the left edge of the screen, to the top edge of the screen, to the right edge of the screen, and the bottom edge should be pinned to the top of the middle container. So essentially, if we click on this pin button over here, And I'm going to make sure that all of these numbers read 0. And this 0, of course, refers to the closest neighbor, which if you hit the drop-down button, it'll show you that it's 0 points to the middle container. And then we're going to activate all 4 of these constraints, and then we're going to add them on. Next, I'm going to add another view in the bottom of my screen, and I'm going to resize it so that it barely touches the bottom of the middle container. And I'm going to rename it bottom container. So you can either adjust this manually by just moving it around. Essentially, you're aiming so that when you click on this, it should read 0, 0, 0, or 4 edges. So currently it's reading 96.5 because it's 96.5 points away from the top container. So it's this edge. But we want it to be relative to the middle container. So in order to do that, we have to make this a little bit smaller. And so if you remember, the height of this top container was 283.5. So we're going to make the height of the bottom container the same, 283.5. And the Y position should be 383.5. So you can either go around fiddling with the design manually and checking to make sure that you've got zeros all around this container, or you can just set it in the size inspector by changing the Y position to 383.5, X is 0, width is 375, and height is 283.5. Now remember, these are the numbers for the iPhone 7 size canvas. If you're designing this on a different canvas, all of these numbers will be different. So make sure you're in the right canvas. Okay, so now that's done, we're going to set our constraints. So again, we're going to click on the pin button, and then we're going to set all 4 constraints so that our container, our bottom container, is stuck to the bottom of the screen, the left and the right edges of the screen, as well as the bottom of our middle container. So, and then we're going to add these 4 constraints. And you can see there's no warnings, everything's blue, so Xcode is happy. That's exactly how we want to keep it. Now, we've got a whole screen full of white, so it's a little bit difficult. So when you're designing containers, it's a good idea to give them a bit of color. So let's go into the attribute inspector and just give it a random color. It could be anything, doesn't really matter, just green, red, blues, whatever it is that you want. Okay, so there's 3 colors, and you can see that the edges are barely just touching each other. So now, if we have a look at this in different sizes, for example, iPhone 6 Plus looks pretty evenly distributed, iPhone 5, iPhone 4, landscape, portrait. We've essentially created these containers that will always evenly distribute themselves depending on the size of the screen. So let's head back into the portrait mode for the iPhone 7 canvas. And we're going to put in our designs. So the Dicey logo should go into the top container. So let's again nest it into the top container. And the roll button should be in the bottom container. So let's put that in the bottom container. Next, we have to make sure that the logo and the button stay in the center of their containers. So with the logo selected, we're going to fix its height and width. And then we're going to keep it in the horizontal and vertical point in the container, which remember is the top container here. And do the same for the roll button. Okay, so now we're pretty much set up and ready to go. If you go ahead and run the app, you can see that the app looks and works fine in portrait mode, and this is on the iPhone 6. And if I rotate it, it looks just as well in landscape and still works perfectly. Now all you have to do is make all of these containers see-through, so by changing the background color to default, and you've got your beautifully designed Dicey app working seamlessly in different sizes as well as in different orientations. So I want to give you a few things to think about after this lesson. One is, why are these dice so close together, even in landscape mode? Is there a way that we can make it go further apart when it's in landscape mode versus when it's in portrait. So essentially with auto layout, you first visualize how you want your app to look on different screen sizes, how you want it to be laid out in different orientations. And then you go in with your containers, with your pinning and your alignment in order to make your app look good. Now, auto layout can be a bit confusing, so if none of this made any sense, have a look back at the last lesson where I explained how pinning is different from alignment and how each of them works. In order to really solidify this knowledge, in the next lesson, we've got a challenge for you. So it's a completely blank screen, and I'm going to show you how I want the screen to look on different screen sizes and in orientations, and you have to work out how to put in the constraints so that it does that. All right, so looking forward to that, and I'll see you on the next lesson. All right, it's time for a challenge. Now, if you go to the URL in the text box below, you'll be able to go to the London App Brewery GitHub account and download the Auto Layout Practice Skeleton project. Now, this project is essentially a blank canvas. There's nothing that you have to do inside the view controller. All you have to be aware of is that there is an asset called Artboard and an asset called Notebook. So you have two images basically. So this is how the finished app should look. Now I'm running it on an iPhone 6 simulator at the moment, but it shouldn't matter which size you're running it. You should have a artboard that's centered in the top half of the screen and a notebook that's centered in the bottom half of the screen. And when I rotate into landscape, you should still see roughly the same proportions like so. Now, just a hint, because we're using two containers in this case instead of the previous three, and we don't have that middle container that's got a fixed height, you might have to find yourself needing this equal heights option. So have a think about it. This one's quite a bit of a challenge, and see if you can consolidate some of the information that we presented in the previous lessons to see if you can set up your own constraints for this challenge. So if you have any questions, feel free to again ask us in the comments below, and I'll see you in the next module. All right, so in this lesson, we are going to review the solution for the Auto Layout Practice Challenge. So we're going to download the starter project over here. And as always, if you're familiar with Git and Terminal, then just go ahead and git clone. Otherwise, you're going to download the zip and extract it. All right, so there's our Auto Layout Practice, and we're going to double click it to open. All right, so if you remember, the goal was to have an app that would look like this in portrait, where the top image and the bottom image both take up half of the space of the screen. So the top half will be the palette and the bottom half will be the notebook. And when the phone is rotated into landscape, then it would still keep those proportions. So the top half will be the palette, and again, the bottom half will be the notebook. So let's get started. So the first thing that we need to do is, if you have a look inside assets.exe assets, you've got the artboard and you've got the notebook. Now we're going to go to our main storyboard and add two image views. So one at the top and one at the bottom. So the top one is going to be the artboard and the bottom one is going to be the notebook. And of course, we're going to say content mode aspect fit. And for simplicity's sake, you can select both of them and edit them together in the attribute inspector if you wish. Another neat trick is if you're creating a lot of buttons, for example, or a lot of image views, is to hold down the option button and then click and drag to produce a copy. That's the same thing. So that's just a neat trick in case you ever need it. Okay, so if we review the principles that we learned in the last lesson on auto layout, we dealt a lot with containers. So it's no different here. In a future lesson, I want to teach you more about stack views where we don't rely on containers so much. But for now, we're going to implement what we learned in the last lessons. And that will be embedding our image views inside two containers. And we're going to specify the relationship of the containers to the edges of the screen, and then specify the relationship of the image views to the containers. So to find a container, of course, we go in here and we look for a UI view, And there it is, view. Here we go. And we're going to drag it on the screen. So as you can see, if we pull this down all the way to the bottom, you can see that the height of our view, the total height, is 667 points. So what we want to do is we want to resize this top container so that it is half of 667. So 667 divided by 2 is 333.5. So let's go ahead and change the height to 333.5. And as you can see, it being white on a white background is not terribly great. So let's go ahead and change the color to maybe a blue color. And then I'm going to hold down Option and I'm going to click and drag to make a copy. And this one, let's make it green. Yeah, that looks good. All right, cool. So now we are going to set the constraints. So I'm going to say 0, and then 0, and 0, and 0. So it's basically 0 from the top, 0 from the right, 0 from the left. So it's going to stick to the edges of the screen for these 3 sides. And then for the bottom side, it's going to stick to the top edge of the nearest neighbor, which is of course the other UI view. So it's important you have a look and check what is the nearest neighbor that's specified. So is it the view, or is it the notebook, or the bottom layout guide, or another view? So in this case, it can be a little bit confusing if you've got 2 views. So it helps if you actually rename these in the document outline. So let's call this one top view, and let's call this one bottom view. So you can see now, if we go back into the constraints, let's put back those 0, 0, 0, and bottom is also 0. And if you check now, you can see that we're saying 0 to the bottom view and not this one, which is the main view. All right, so go ahead and hit enter and add those 4 constraints. Now we're going to do the same with the bottom container, but this time it's going to be 0 from the bottom, 0 from the left, 0 from the right, and 0 from the top view, right? So that means that this is going to be stuck to the bottom 3 sides, and these 2 views are going to be stuck to each other. So go ahead and add those 4 constraints. So at the moment, you can see that we've still got an error, and the reason is because the height is ambiguous for both the top and bottom views. So how do we fix that? Well, the easiest thing is, because we want it to always take up the top half of the screen, and this one always take up the bottom half, we can select both of them and say equal heights. So we add that in and our errors disappear. So now if you have a look in here and you change your canvas into landscape, you can see it's already doing exactly what we want it to do, which is splitting the top of the screen and splitting the bottom of the screen along this horizontal axis. Okay, so now all we have to do is to embed our artboard into the top view and embed our notebook into the bottom view. And as we said before, when you're moving these things around, you have to look really carefully at where that line is falling, because if that line is on the same height, say here, with the top view, it's not the same as if you nest it inside. So what I always try to do is aim the pointer of my cursor to the name of the view that I want embedded in this case bottom view, and it will fall inside that container. So let's put that back over here. All right, so now all we need to do is to specify these image views relationships with its container. So remember, whenever you're making these constraints, if you have a look in the drop-down menu, you can see it's relative to the container, which in this case is the top view, which is this blue square here, right? So we're going to say, instead of pinning its position, which you can do, and let me just quickly show you what that actually looks like. So if we pin it to all 4 sides, it looks great like this in portrait, but let's change the landscape and you can see it looks a bit odd. And this is all to do what we explained in the auto layout tutorials. Because you're keeping those structs the same distance, when it rotates the landscape, you don't have so much height anymore. And if you keep those relationships the same, then it's going to look very, very odd. So let's go back to portrait and let's Command Z to undo those constraints. So the alternative, if you don't want to go back, is you can actually have a look at the constraints by going into the size inspector. And you can see we've got all 4 of these, and you can delete them one by one by selecting and hitting backspace. Okay, so now our artboard's a little bit messed up, but that's fine. Let's just change the height and width back to, say, the same as this one, which is 240, 128. So 240, 128. Okay, so we're happy with this layout and we want to keep it in these proportions when it goes into landscape. So what we're going to do is we're going to say fix its width and height, and also align it horizontally and vertically in container. So container in this case, of course, refers to the parent UI view in which it's nested in. So that's the top view here. So let's add 2 constraints. And if we go into landscape, you can see that looks exactly how we want it to. So let's go ahead and do the same with our bottom image view. So pin its width and height to the same, and then make it horizontally and vertically aligned. All right, so now if you run your app, you can see that you've got exactly the same desired effect as we showed you in the challenge video. So all you have to do now is just to clear the background color. So let's go and change it to default, which is nothing. And there you have it, your app that is laid out using constraints, pinning, and alignment. So as I mentioned earlier on, I want to bring out a lesson on stack views and how you can use auto layout with stack views rather than using containers. So that's yet to come. So if you have a look at the next lesson, and if it's still not there, then keep your eyes peeled. I'll let you know once it's live. So see you on the next module. Alright guys, so in the last few modules, you saw us go into detail on how you use container views alongside pinning and alignment to create constraints that specify the layout of your screen in under different conditions. So be that landscape or be that a larger screen size. So in this lesson, I want to focus on almost a different strategy, and this is something that is relatively new. So originally, constraints using containers, at least when you're using the interface builder, was the predominant strategy. But since recently, Apple introduced something called stack views, and a lot of developers have jumped on board simply because it's a lot easier and it addresses more day-to-day problems when you're trying to lay out your screen, which is how do you put a number of items on the screen that are distributed evenly across either the width or the length of the screen. So today, to show you that, I'm going to try and replicate a simple interface, which is just simply the calendar that we've got on Mac. So at the top, you've got this section, which is going to be a UI label that's going to show you the numbers, and then you've got these operators, etc., and we've got the numbers. So we're going to try and recreate this layout using auto layout inside Xcode. And in the process, we're going to learn about stack views and how you can use them in your projects to make creating the interface a lot easier. So let's get started. So the first thing I'm going to do is create a brand new Xcode project. And as usual, we're going to choose a single view app, and I'm just going to call mine Auto Layout Calculator and hit next. And go ahead and create this. All right, so here's our brand new project, and we're not really too concerned about the programming part. Predominantly, we're just going to focus on the main.storyboard. You can go ahead and code up some functionality for your calculator if you wish, but for now, I just want to walk you through how to use stack views inside Interface Builder in order to lay out your screen. So the first thing that we'll need is some buttons. So let's search for a button. and I'm going to lay this out. So let's say that the width was maybe 50 by 50, so a nice square. And then we're going to change its background color and make that a nice blue color. And then we'll make the text more visible by making it white. And I'm just going to make that a bit bigger, maybe a 30-point font that's bold. And we'll change the text that's inside here to say maybe number 1. So we're going to have a whole bunch of these buttons laid out on screen in order to create our calculator interface. So instead of going through that tedious process of dragging it on screen and updating the properties and changing the size, all I'm going to do is just create a whole bunch of replicas of this button that I've already created. So to do that, all we have to do is hold down the Option key or the Alt key on your keyboard and then click and drag, and you'll get a new copy of it. And then click and drag for another one and click and drag for another one. So now we have 4 of them, and if you select all 4 and then hold down the Option key again, click and drag, you'll have 4 new ones. And we're going to need 4 rows of 4. So I'm going to select all 8 of these, Option, click, and drag. So that was a lot quicker than going through the traditional process of putting buttons on screen. All right, so now that we have all of those, a quick thing I want to show you was that if you have, say, an IB action that's linked up here, let's just call it button pressed, right? And you make a copy of it by Option dragging. Now this item is also linked to the same IB action. So when you hover over this, you can see that both of them are linked up. So if you want to create a whole bunch of buttons that are going to be differentiated by tags or going to be pointing towards the same IB action, then this is a much easier way than, sort of connecting these things up one by one, right? Which is going to be a lot more time consuming. All right, cool. So that was that. So let's have a look at our calculator. We've got 5 rows of 4, so we just need 1 more row of this. So I'm just going to Option and drag. There we go. Okay, so at the moment you can see that the layout is pretty rough and ready, I guess. You can obviously, move it around or, arrange it, but you know that when it goes into landscape, then all of your efforts are lost and everything looks like a mess, right? So this is where stack views are going to come and save the day. So the first thing that we're going to stack up is this horizontal row. So we're going to specify that these 4 items are going to be stacked together in a single horizontal row. So if you select all 4 items simply by clicking and selecting, and then you click this button, which is the embed in a stack view. Alternatively, you can go to editor and then you can go into embed in, and then you've got stack view here as well. So both ways work. This one's just a lot quicker. Okay, so now you can see that we've got our 4 buttons, but they just have no space between them. In fact, they're slightly overlapped. But don't worry about that, because we're going to fix this. We're going to change this property. The thing about selecting stuff once you've got stack views is that it's a little bit confusing. So if I select here, I've actually got that button selected. But if I try and select this entire thing, then I've got the stack view selected. It's usually much, much easier to select whatever you want inside the document outline. And if you can't see your document outline, then just pop it out using that button here. So I'm going to select the stack view. So now we're going to change the distribution property. Instead of fill, we're going to say fill equally. So now, if I still have this stack view selected, and I go and add some constraints, say 10 from the left of the screen and 10 from the right, and I add those two, you can see that our buttons are now distributed equally along this horizontal axis. So this is a horizontal stack, one after the other. And you can see that it's difficult to tell where one button ends and the other one begins because they're all the same color, right? So instead, we're going to select the stack view and you can add some spacing, let's say 10 points of spacing. So now we've got 4 buttons that are equally distributed along this horizontal stack. They've all got 10 points of space in between them. So that now looks a lot nicer than this, right? So the next thing I'm going to do is to do the same for the next 4 items. So if I select all four and I put them into a horizontal stack. So Xcode is actually quite clever in that if you select all of these buttons, which are more or less vertically on top of each other, at least by eye, then if you hit the stack, it actually stacks them into a vertical axis. But if you select elements that are roughly along the same horizontal axes and you stack them, then it puts them into a horizontal stack. Now, of course, you can change this still, so you can change it from horizontal to vertical, but that's just a neat thing that Xcode can do. Okay, so we're going to do the same thing. We're going to change distribution to fill equally, and then we're going to change the spacing to 10 so that we have the same thing. Now, instead of doing the same tedious thing for all the rest of these buttons, I'm actually going to delete all of these. Instead, I'm going to select this stack and I'm going to Option click to drag out a few more of these. And I'm going to delete this set which has the constraints in it. Okay, so now we have these buttons, but you can see that vertically they're not really associated in any way, right? So what we can do is, in the same way that we put all four of these items into a horizontal stack, we can select all of these 5 stacks, these horizontal stacks, and put them into a vertical stack. So if you selected all of these stacks, we're not selecting the buttons, remember, we're just selecting the stacks, and then you say place inside a stack view, then Xcode will automatically place all of the stacks inside a vertical stack view. And now, if you change the distribution to fill equally and spacing to 10, then you can see that we've got a nice grid of 4 by 5 elements. So now all that we have to do if we want this to fill the entire screen is to add some constraints. So let's start off by saying it's 0 from all edges of the screen. So now you can see that our entire stack, so both the horizontal and the vertical ones, are distributed evenly on our screen. And even when you go to landscape, the relationship is maintained. So there's still 4 columns of 5 rows, and they're equally distributed in the available space. So that was pretty neat, and that wasn't too hard. But if we have a look back at our calendar, you can see that at the top, we've actually got this place where the numbers show up, right? So let's go ahead and try and add that in. So we don't actually have to destroy our stack in order to do that. If you just go in here and search for a UI label, and we can place that on here, and it's really important where you place it, because if you drag it around, you can see that if that blue line shows up, then that label is going to go into that horizontal stack, and it's going to be equally distributed. But if instead I put it here, then it's going to go in the vertical stack and also be evenly distributed, taking up the entire row. So what I want is for it to be right at the top of the stack up here. So it's still included inside this vertical stack, but it's now right at the top. So this is where our numbers are going to be. So your whatever numbers you have. And I'm just going to go through the process of making this look a little bit nicer. So let's give it a gray background maybe, should be okay, and a white colored font, and then make the font size a lot bigger, make it right aligned, and just making it look a bit more like this, right? We could probably go even bigger with the numbers. Let's make that 50. All right, cool. So that doesn't look too bad, but there's one thing that you might want to fix, which is the fact that in labels, all the text goes right up to the edge of the label. So instead of having a label inside the stack, what we can do is we can actually put the label inside a container, so a UI view. So if I search for a UI view and I put that in here, now it's going in as another element in the vertical stack, but actually I want to embed this inside this view. So you can see that that blue highlight is what's showing me that this is going to be embedded. So that can go in there. And now if I select this label and I add some constraints, let's say maybe 10 from the left and 10 from the right, hit enter, then I'm going to have that little bit of space. So instead of having the gray background in the label, I'm going to change that to see-through, and the background view is the one that is going to be the light gray color. So you can see that there's still two red lines, and that's because we've told it how to position this label in the horizontal axes, i.e. 10 from the left of this view and 10 from the right. We haven't told it how to position the top and bottom, so it doesn't know where to put it here or to put it here, etc. So let's go and add some more constraints. So it's going to be 0 from the top and 0 from the bottom. So in summary, if we go and select this UI label, and you can actually clear all of the constraints for this selected view, make sure that you don't clear constraints for the entire screen, but clear the constraints for the entire view, and then still check that that label is selected. Then you can add in the constraints of 0 from the top, 10 from the left, 10 from the right, and 0 from the bottom. Now, if you hit enter, then there won't be any errors anymore, and it'll look exactly how you want it to look. So now let's go to landscape, and you can see that looks pretty neat, right? Looks pretty good. Okay, so now let's try and replicate our calendar a little bit further. So namely, these ones are going to have to change. So that's going to be a C, that's going to be a plus minus, that's going to be a percentage, this is going to be divide, and this is going to be multiply, minus, plus, and the equal sign. This is going to be a decimal point, and this is going to be 0. And now we have our first slight issue. So you can see that in the calendar, this 0 actually takes up 2 spaces. So instead of having 2 buttons here, there's actually only 1 button, but that button can't be equally distributed. So how do you specify that this button should be weighted 2 times above each of these? So this should take up 2 times the width of this. Well, you can use one of the constraints. So if I select the 0 and the dot, and I go into here where I have my constraints, and I say equal widths. Okay, so that sounds a little bit confusing for now, but just bear with me. And then I'm going to select the middle and the equal sign, and also say equal widths. And now you can see I've got a whole bunch of issues in there, but don't worry about that. What I'm going to do is I'm going to select the stack view, and instead of saying fill equally, I'm going to say fill proportionally. And now I'm going to go and change some of these constraints. So if you select the equals button and you go and check out the constraints, you can see that you've got this one here, and you can click on edit to change it. And what I want to change is this multiplier. I want to say that it should be a 1:2 ratio multiplier. So if I hit enter, you can see that my constraints are now setting it so that these 2 buttons are equal in widths with a multiplier 1. So this width equals this width. But these 2 have a equal width constraint, but it has a multiplier of 1:2. So this one is 2 times as big as this. Now, because we've got this spacing, so 10 points each, it's about 30 points, you actually probably have to make that multiplier a 2.1 for it to look right. But now we have our button 0 down here, and it's looking a lot more similar to what we've got on screen, right? So really all that's left to do is to change some of these background colors. So let's change that to maybe a dark gray. And then change these to a orange color, I think it was. Let's go for tangerine. And now there's just one last thing that I would like to change to this layout, which is giving it a little bit of padding around the edges so that these buttons aren't right up to the edge. And to do that, the constraints that I'm setting for are the entire stack view. So this is actually the vertical stack view, but it's a vertical stack view consisting of all the horizontal stack views. So it's basically our entire bunch of UI buttons and views. So we can go ahead and select that entire stack view, and I'm going to see if there are any constraints at the moment. And you can see that there's trailing and leading and bottom and top. So we can edit that. At the moment it's 0. We'll change that to 10 from the right, 10 from the top, or maybe we can even go a bit more, maybe 20. Say 20 from the top, 20 from the right, 20 from the left, 20 from the bottom, and 20 from the top. All right, cool. So now if we have a look inside our landscape and portrait, our calendar looks pretty nice, right? So stack views are a really, really neat way of distributing items equally or proportionally along an axis, be it horizontal or vertical. Now, one of the things that you might encounter is that sometimes maybe you don't want these to be exactly equal. Maybe you want it to be dependent on the content that's inside. Say if we had this button that was, instead of 1, maybe it was 3.14159, right? And say it's pi. And you can see that because it's so long, it's actually been truncated. So what if we wanted this horizontal stack to not be distributed evenly, but be distributed proportionally to the contents? Well, we can go ahead and select this stack. So this is the button I've selected, but this is the stack that contains it. And then we can go into the attribute inspector, and instead of fill equally, we'll change to fill proportionally. So it's still relatively laid out. Instead of these buttons being equal size, they're actually sized accordingly with their contents, but they're still distributed along the same horizontal axis. So that's just another variation. And you can actually play around with some of these stack view properties. For example, equal spacing or equal centering, so that each of the centers lie on, all 4 points of the horizontal axis. And basically, it gives you a lot more flexibility and makes it a lot easier when you're trying to distribute things proportionally along the horizontal and vertical axes. And in most cases, when you're laying out an app, you'll find this to be far quicker and far easier to do than using containers and constraints and alignment. And it works a lot nicer. And of course, on all screen sizes, the rules will be applied. So I hope you enjoyed that tutorial, and if you want, you can go ahead and set yourself a challenge to make this calculator actually perform calculations. So link up each of these buttons and make it do the job of calculating. But of course, that's completely optional. It's just that if you want to test yourself and challenge yourself, then go ahead. All right, so I hope that's been fun. And if you have any questions about stack views, then feel free to leave a question at the question answer area, and I'll do my best to try and point you in the right direction. So that's all from me in this module. I'll see you on the next module. All right, guys, welcome to the next module. So we've had programming in Swift for beginners, but of course we're no longer beginners. So this module is all about taking a deeper dive into some of the more complex concepts that we've come across in the last few app projects. So this is mostly going to be about classes and objects, properties, inheritance, what does the override keyword do, and what are initializers, what are optionals, what are those question marks that you see all over the place. So it's essentially some of the theory behind what we've been using so far. And it's just taking an opportunity to play around with the code a little bit so that you really, really understand what it is that you're writing. So the first thing I'm going to jump into is looking more at classes and objects. So just as a reminder, classes are essentially a blueprint that determines various properties. So say a blueprint for a car might have how many seats it will contain, what is the size of the motor, how many valves does the engine have, etc., etc. And once you use that blueprint to build an actual car, then that is essentially the object. So the car has properties, which are essentially variables or constants that you've used before, but when they're associated with an object, they're called a property. And then objects also have actions. So these are your functions in normal code. But of course, remember when they're associated with an object, they're called a method. And that basically determines how the object works, how it can do things, such as drive in this case. And finally, there's events. And these are trigger points when the object should do something. So for example, with our view controller, that's view did load or view did appear or any of the events within its life cycle. And so we're going to dig a little bit deeper into classes and objects and play around with the code a little bit. All right, so first things first, we're going to open Xcode and we're going to create a new Xcode project. So you can either go through the welcome screen or you can of course go through File and New and Project. Now we're not going to create an iOS app this time. This is really important. Instead, we're going to go under the Mac OS tab and we're going to select the command line tool. Now, the reason why we're creating a command line tool rather than an iOS app is because I don't want any of the fancy stuff, the flashy view controllers and the assets folder distracting us. All we want is just a very, very simple program that can be run so that we can see exactly what the code is doing rather than how the UI is behaving or, having view controllers and all of that kind of stuff. We're going to keep it really, really simple. So under Mac OS, select command line tool and hit next. And then we're going to call it classes and objects. And making sure that the language is selected as Swift, and then we're going to hit next, and then just save it wherever you like. Now, if we have a look at this new project we've created, the most important thing in this program is this file called main.swift. Now, this is where your code will execute from, and it will go from beginning to end here. But you can also create additional files just as we did before when we created our data models, etc. So the first thing we're going to do is we're just going to hit run and see what this program does thus far. Now, you can probably predict what's going to happen because the only code that we've got is a line that calls the print statement, telling it to print to the console, which remember is down here, hello world. And so it does, hello world, and then your program ends because there's nothing else that you've asked it to do. Now, this is slightly different from what we've done so far because we've always had a visual interface. We've always had a view. In this case, we don't have any of that. All we have is what you see here, which is just this program called classes and objects, and the program is run using this main.swift file. So this is a really simple program, and it's really clean, and it's really easy to see what's going on. So first things first, we're going to delete this line, hello world. Now the next thing I'm going to do is I'm going to create a new class. And in order to do that, I need a new Swift file. So having either class and object selected or the main.swift selected so that my new file goes into the right folder, all you're going to do is go to File, New, File, and we're going to select Swift file over here, still under Mac OS, and we're going to go and hit next. And we're going to call this file car. Now just check to make sure that this new file, car.swift, that you're creating targets the classes and objects program that we've got here. So make sure that little checkbox is ticked and then go ahead and just click create. Okay, so now you can see we've got two Swift files now. One is the main.swift, which is where the code is run, and the other is our car class, which is currently completely empty. So let's go ahead and change that. Now, the first thing we're going to do here is construct a new class. Now, this has been done for you automatically whenever you create a new view controller. In order to see what's happening, we're going to create a class for ourselves. Now, the first line of code that you'll see is import foundation, and that's as I explained before, basically just packing a Swiss knife into your backpack for your hike. It basically contains a whole load of code that allows you to do certain things. For example, math functions, for example, the arc for random function, etc., etc. So leave that be. And what you're going to do is you're going to write a keyword called class. Now you can see that keywords are always highlighted in this kind of pinkish color. And one of the things that you have to remember is that you can't actually name your variables the same name as an existing keyword. So for example, if I just go ahead and delete that and I try to say var class, this is not cool because it knows that var is a keyword, it knows class is a keyword. And this is very, very confusing for Xcode. And you'll see that it actually gives you an error. It knows what you're trying to do. It knows what you're about. And if you click on that error, it actually tells you that you're trying to use a keyword as your variable name. And it can't be used because it's way too confusing. But you can fix it by giving it backticks around it. Now, this is not ideal because this makes it look different to other variable names. But as Xcode says, if this name is unavoidable, use the backticks to force this through. Now, you've got to love how Xcode is always really passive aggressive, like all the time. But essentially it's telling you this is not what you want to do, but if you have to, go ahead, knock yourself out. So that was just explaining how there's certain keywords that you can't really use as a name for your methods or for your variables. But in this case, we actually want to use the keyword class in the proper way, i.e. creating a new class. So the first thing you write is class in lowercase. Remember, the casing matters a huge deal. If you don't want Xcode to go all passive aggressive on you, then we have to observe its rules. Okay, so the class is the keyword constructor. This is telling Xcode that I want to create a new class. The next part we have to write is the name of this class. And the name of my class and the name of your class is going to be car. Now, remember that the convention for Swift, and indeed for a lot of other programming languages, is that when you're creating a class, the name of the class should be capitalized, hence the capital C. Whereas when you're creating a variable or a method, then it should be lowercase, like so. Okay, so we've got an uppercase car, and that almost completes our class construction. The next step we're going to do is open a curly brace. And remember, when you open a curly brace, you always have to hit enter so that Xcode automatically inserts a closing curly brace. And that is your class completed. Now, this is a completely empty class because between the curly braces of the class, there's nothing. It does absolutely nothing. This is like a blank blueprint. In order to make this class do something, we're going to add some more code. And the first thing I'm going to add is a property. Remember that properties are essentially variables and constants when they're outside of a class, i.e. outside the curly braces of a class. But when you create a variable or a constant inside the curly braces of a class, then they're called properties. And our car obviously needs a number of properties. We need to determine, for example, what is the color of the car? So let's create a variable called color. And we're going to set it equal to black. So everything that comes off the line from this factory using this car blueprint will be a black car. Now, if you've ever been to a car factory, and I highly recommend the BMW World in Munich. It's quite a blast. It's like a 1-hour tour, and you get taken through the painting workshops, and you can see how they use the electrostatic charges to save paint by drawing the paint spray onto the body of the car. I digress, but it's really awesome. If you've never been to a car factory, do it once. Trust me, this story has some relevance to what we're doing here. Okay, so all the cars coming out of our factory using this particular blueprint is going to be colored black. Now remember that properties are essentially variables or constants existing within a class. So you use the var keyword or the let keyword to declare it. It has a name. Remember, it should be camel cased, so the first word is always lowercase. And it has a value upon creation. Now let's add another property, and that's going to be the number of seats in our car. Now go ahead and create a property that's called number of seats, and give it an integer value, remember whole number, integer value of 5. All right, so that was super easy. It's basically the same as above. We're going to use the var constructor, number of seats, and then we're going to set it equal to 5. Now, there's a few variations on this. Some of you guys might have created a constant. So let number of seats equals 5. That means that the value that's never going to be changed. So if you're only ever going to make cars with 5 seats, then that works fine. But if at a later stage you want to change the number of seats, then you want to use a var. Now, another thing that some of you guys might have done is you might have used the colon and int to declare that this is going to hold an integer data type. So this variable or this property is always going to be an integer. You can't have, the number of seats equal to a. That doesn't make any sense. So that is exactly the same as this, because here we're asking Xcode to infer the data type based on the value that we're putting inside. So we're saying it's going to be 5, and Xcode is like, well, 5 is an integer, so this variable or this property can only hold integers. All right, so that little bit of confusion over. Okay, so now we've created 2 properties for our car blueprint. If at this point we decide to create an object using this blueprint, then it will be a black car with 5 seats. Now in the next lesson, we're going to add another property, but this property is going to be the type of the car, and we're going to introduce you to a concept called enumerations, or enums for short, and we're going to talk about why we need this special data structure and how to use it. So see you on the next lesson. All right, so in the last lesson, we created a brand new class called car from scratch. And our car has 2 properties, a color property, which is set to black, and a number of seats property that's set to 5. Now, the next property that I want to add is the car type, such as sedan, coupe, hatchback, etc., etc. And we want to be able to represent this data in a clear way. Now, here's a problem. How would you go about doing that? Now, we could say that we could create a variable called car type. Then how do we represent that information? Well, we could say that maybe when we say 0, we mean hatchback. And when the value of car type is 1, then it means it's coupe. And then when it's equal to 2, then that's a sedan. But the problem is that you're going to have to write that encoding somewhere. You're going to have a little, book or a comment that says 1 is this, 2 is that, 3 is that. Now, if God forbid you got sacked and some other guy jumped into your job, he would be extremely confused as to what you're talking about when you keep using car type 2. So in order to make it as clear as possible, we're going to use something called enumerations, or enums for short. So essentially creating an enum is equivalent to creating a new data type. So for example, integers are whole numbers, which is a data type, and they can be 1 through to forever. Strings are a data type, and they essentially are strings of characters strung together. We're going to create a car type data type, and it's going to have a number of different options. So let's do this first, and then I'll show you how we're going to use it. So I'm going to delete this line. And outside of my class declaration, outside of the curly braces of my car class up here, so this is a style choice, but you'll find that most programmers like to create their enumerations at the top. This way, when you glance through a page of code, you can see right at the top already what all the encodings are. Okay, so we're going to use the keyword enum. And 2 things to note. One is that it gets highlighted in the keyword color. So the same color as import, the same color as class, the same color as var. And the other thing is that Xcode actually tells you what it is that you're doing here. Enum is a keyword for Swift enumerated type declaration. Okay, so that's exactly what we want. And then we're going to give our enum a name. So it's going to be the car type enum. And again, it's going to be capitalized. And then we're going to open a curly brace. And remember what you do when you open a curly brace? You hit enter so that it gets closed. Within this curly brace, we're going to write another keyword, which is case. So this is one of the cases of our car type enumeration. Bear with me and you'll see how it works. Our first case is going to be called sedan, not sedan. Our next case is going to be coupe. And the third one is going to be hatchback. Okay, so we've got 3 car types. Of course, you can go on and on and on, but for convenience and for time's sake, let's just say that there's 3 car types in the world. And what this enumeration allows me to do is have a custom data type. So instead of using the integer data type or instead of using the string data type, I'm going to use my custom data type to declare a new property called type of car. And it's going to have the data type, guess what? Car type. And it's going to be set to equal dot coupe. Okay, so let's have a look at that line of code that we just wrote. We created a new property called type of car. It has a custom data type of car type, and the value of this property is dot coupe. So you use the dot notation to access all of the enumeration types. And in fact, if you just write dot and wait for a few seconds, Xcode will give you all the cases in your car type enumeration. So we're going to go for the coupe. Now that dot looks familiar. Do you remember when we set the button title? So I'm inside the code file of the Destiny app, and you can see that when we set the title on one of the buttons, for example, the bottom button, we use the setTitle method and we put in a title, could have been any string like blah, and then it has this for UI state, and the UI state is in fact a enumeration, and we're using the normal state. But if you hit the dot, you can see all the other cases for that enumeration, such as when the button is focused, when the button's highlighted, etc. And we selected the dot normal state. And so this is exactly the same. This is a enumeration that we've created so it's visible. In this case, Apple created that enumeration, and so it's not visible, but it's the same process. So here we go. We've got a property called type of car that has a data type of car type, which is an enumeration that we created that has 3 possible cases: sedan, coupe, hatchback. And we selected that our car blueprint will be building coupes. Okay, so that was a little bit on basic enums. And in the next lesson, we're going to be taking our car class or a car blueprint, and we're actually going to turn it into a real car object. And we're going to play around with the code a little bit more in order to get our car to do exactly what we want it to. So I'll see you on the next lesson. All right, so in the previous lessons, we've created this new car class, which has 3 properties currently: the color of the car, the number of seats, and the type of car. Now, in the last lesson, we looked at using enums to encode our car type so that we're not using something ambiguous like zeros, ones, threes, etc., but we're actually using a custom data type that has 3 cases: sedan, coupe, or hatchback. Now, in this lesson, we're going to talk about how we can turn that car blueprint into an actual car object. Now, the first thing that you might note is that if you have a look over here, that the car.swift file icon is slightly grayed out, and that's because it's not yet been saved. So just go ahead and hit Command S, and you'll see that icon go white. Now this is really important because sometimes when you're trying to refer to something in another file and is not yet saved, the autocomplete doesn't always work as you expect it to. So when you see any gray icons, just go ahead and hit Command S to make them white, and that'll reduce your chances of error as well. Okay, so we're going to be creating our object inside the main.swift file, because remember, when our program, classes and objects, gets run, this is the page of code that it's initially going to look to see what it should do. So over here, we're going to create a new object, and it's going to be a constant. So we're going to use the let keyword, and our new object is going to be called myCar. And it's going to be created using the car blueprint or the car class. So in order to create an object, the syntax is going to be let the name of your object, in our case it's called myCar, equal to the name of the class. Remember, the name of the class is always capitalized. And then you have an open and close parentheses. Now, we're going to talk about that parentheses in the next lesson. But for now, we're just creating a very simple object that is using the car blueprint. Now, my car has been created, but we don't really see any cars on screen or anything at all. So let's try and expose some of the properties of my object, my car, and see how our car looks. So I'm going to use a really simple print statement, and I'm going to print my car dot color. I'm going to print my car dot number of seats, and finally I want to find out what is the type of car of my car object. Okay, so we're going to go ahead and click build and run, and the computer's going to read from top to bottom, creating a new object from the car class, and then it's going to print out to show us what are the various properties of this object. So let's go ahead and click play and have a look in our console over here. So build succeeded, and the first thing we printed was my car's color, which is black. Then the number of seats is 5, and the type of car is a coupe. So those are all the properties that we've got for our car object. And essentially this lesson was all about showing you, using very basic code, how we create classes and then turn those classes into objects. So in the next lesson, we're going to look at making our car a little bit more personalized. We're going to look at how we use the initializer in order to modify how our object gets created from the class. So all of that and more in the next lesson, and I'll see you there. All right, so in the last few lessons, we looked at creating our own custom car class that's under the car.swift file. We created our own properties for the class, namely the color, number of seats, and type of car. And in order to encode the type of car, we created an enum that is essentially our own custom data type that contains 3 different cases of what car types we could create. So then we went into main.swift, which is where our program starts running from, and we created a new object from that class or from that blueprint called my car. And it was initialized with empty brackets, and then we ran the code and printed out the values of all the properties that essentially we've created a bog standard 5-seater coupe from our car class. Now, we're not the sort of people who have bog standard factory line cars. What if we wanted a customized car? What if I say to the factory that, it's great that you have your standard cars that come off the assembly line, but I want a special car because I'm a special person and I need to be able to drive around the streets and have everybody look at me because I'm just that sort of person. So what do you do then? Well, this is where class initialization comes in. And that's what we're going to talk about in this lesson. So the first thing that I want to modify is I want my car to have a custom paint job. I know that the standard cars that come off the factory line using the car class, i.e. the car blueprint, comes out as black. Now I want it to be red. Now how do we change that color property without making every single car that comes off the assembly line red? Well, this is where initializers come in. So there's 2 ways of going about this. The first option is going into main.swift and typing out my car, i.e. fetching the actual car object, using the dot notation to tap into the color property and changing it to red. So now if we print the color of my car again, you'll see that it has changed to red. So let's run the program again and let's have a look in the console. So initially when we printed out all the properties of our car, it was a 5-door black coupe. And after we took it back to the garage, changed its color, it is now a red 5-door coupe. Now this is the real life equivalent of driving your brand new delivered car back to the factory and giving it a paint job. What if I don't want to change the color? What if I wanted my car to come off the assembly line as red? So essentially what I want is to be able to have a custom setting on my car's paint job when it's going down the assembly line. So this is the equivalent of going on the BMW Builder Your Own website and picking a custom color. So believe it or not, all the cars that come off the BMW assembly line are actually colored by default black. And you can add a custom top coat by changing it to red or whatever color it is that you want. So this is what we're going to do for our car class as well. And in order to do that, we're going to create a custom initializer. So the first thing I'm going to do is delete these 2 lines of code. And we're going to use a different method to initialize the car to a custom color. So head back over to the car.swift file, and we're going to use the init method to create a custom initializer. So initializers are the part of code that determines what should happen when a new object is created from the class blueprint. So just below all of your 3 properties, we're going to write the init keyword. And as you can see, Xcode says that this is the Swift initializer declaration, a set of statements that prepares an instance of a class, structure, or an enumeration for use. So that's exactly what we want. And then we're going to open a round parentheses, and I'm going to put in the parameter name. And in this case, it's going to be customer chosen color. And it's going to be of data type string, because that's the way that we've decided to encode our colors. Now we could have also created a enumeration for our car color, and that might be something that you want to go and experiment. Essentially put in a set of all possible colors like they've got here on the BMW website. But in this case, we're going to keep it like this. And the next thing we need to do is open a curly brace and of course hit enter to insert the closing curly brace. And inside these curly braces is what should happen when a new object is created from the car class. And in our case, we want to be able to change the color property, so this one, to equal the customer chosen color. So essentially what happens now is when we create a new object from the car class, the initialization method will get triggered and we can pass in a customer chosen color, and the color property then gets set as that color. So let's head back over to the main.swift file, and now you can see that there's a new error. And if we click on it, it says missing argument for parameter customer chosen color in the call. And if you remember previously when we created our car object, we wrote car, which is the car class, and then we used a set of empty parentheses. And that's because our previous car class didn't have an initializer that had a required parameter. So this, if you remember our teachings on functions and methods, by putting this line here, we're requiring an input every single time we initialize or create a new object from the car class. So let's go ahead and change that by deleting those empty parentheses and opening a new set. And you can see that Xcode will suggest to you automatically what it is that you should put in between those parentheses. So once it starts suggesting, I'm just going to hit enter instead of typing it all out. And it's expecting an input in this placeholder that's going to be of type string. So we want our car, our custom car, to be colored red. So now let's have a look at what's going to happen in our code. So even though in our car class we've specified that the default color should be black, we've created this initialization method that offers a way for the customer to put in a custom color when the car is built. And the color property is then set to this customer chosen color, overriding this default black color. So now if we run our code, what do you think we'll see in the debug console? So as I always say, programming is all about predicting what should happen based on your actions. And then if it doesn't work out the way you expect it to, then to debug and figure out where it went wrong. So let's go ahead and click play or run and see what we get printed as the mycar.color. And there we go. We've got a custom 5-door red coupe. And the color property is now set as the custom property. So this is how you use initializers. Initializers allow you to override the default settings on all of your properties, as well as a number of other things. If we go back to the slide where we talked about all the things are available to objects, the initializer is an event, and it's the time point where the object gets created, or in programming terms, initialized. And in our case, we've just said at this time point when the object gets initialized, we want to set the color property to a custom color. So in the last lesson, we spoke about how you can use custom initializers to set the properties of your object to a specified input, such as here where we've got a customer chosen color. So we've turned our little car factory into a world-class car manufacturer on par with BMW and all the big players now. Now there's just one problem. If we currently try to create a car, say let my other car equals car, it won't let us leave the parentheses empty because it has a required initializer. So this, if you think back to the analogy of the car factory, is a little bit resource intensive. It's nice to be able to personalize your car color on the assembly line, but it's also extremely costly, changing the paints over, washing out the paints, etc. So what if we wanted our car factory to be able to normally produce bog standard cars, i.e. ones without any custom colors, but then occasionally we have a customer who's a little bit more loaded and we want to be able to give them a custom color? Well, in the programming world, this is where designated and convenience initializers come into play. So let me show you how that works. So the first thing I'm going to do is delete this new line, and we're going to head back into the car class. Now, when you use the init keyword to create an initializer, this creates what's called a designated initializer, i.e. it has a compulsory parameter that you need to give it. You can't ignore any of these parameters. So if I had another parameter, say number of seats, that I could set as well, you need to specify every single parameter input. So now if you go back to main.swift, it has another error because you haven't provided an input for number of seats. So in order for our car class to be able to have an option where we can initialize it with just the default values without giving it any inputs, we need to change this designated initializer. And in order to do that, we're going to delete everything that's within the brackets. And we're going to delete this as well. So our designated initializer is now empty. And that means that every single time we create a car using the car class and the round parentheses, we just create a bog standard black 5-door coupe. Now, the next thing that we want to do is to be able to add in an optional initializer, what's called a convenience initializer. And the way that we do that is using the keyword convenience init. So similar to how we did it before with the designated initializer, we're going to open some round parentheses, and we're going to put our parameter name in here. And it's going to be the same as before. So customer chosen color. And it's going to be, again, type string. And then we're going to open and hit enter. So in our convenience initializer, the first thing we're going to do is trigger the designated initializer. So we're going to use self, referring to our own class, i.e. the car class. And then we're going to write init, open and close round parentheses. So what this does is that when you trigger the convenience initializer, the first thing it does is initializes a default copy of the object. And the next thing it does is that we're going to set the color property of the car class to our customer chosen color input. So now if we go back to the main.swift file and we create another car, so we've already created a new object called my car using the designated initializer, so creating a car object with the default property values. And then we're going to create a new one now using our convenience initializer. So this is our rich customer's car, so some rich guy's car equals car, open bracket. And you can see already Xcode is giving us two options. Do you want to use the designated initializer that initializes all the properties to the default values? Or do you want to use the convenience initializer, which allows you to put in a custom input? Well, that's the one that we're going to use for this rich guy's car, and this guy wants a gold colored car, as you do. So now if we print out the properties of this rich guy's car, so I'm just going to copy and paste the print statements and change this to some rich guy's car. And if we run our code, let's see what we get in the debug console. So you can see that the first 3 print statements relate to the object my car, and the first 3 outputs are a black 5-door coupe. The next 3 print statements relate to some rich guy's car, which is the object that we created using the convenience initializer. And as you can see, he's got a gold 5-door coupe. So in this lesson, we looked at convenience and designated initializers. Now, the designated initializer makes sure that all the properties of the object have values. And the convenience initializer is essentially an add-on to that. And it's able to build upon the designated initializer so that you can customize one or a few of those properties. And it allows you to create custom objects for very specific use cases. Now, one of the things that we used in this lesson is this keyword self. And you would have come across this word quite a few times now in the code that we've written for our app project. Now, in the next lesson, we're going to explain what self does and how inheritance works for classes. So all of that and more on the next lesson. See you there. All right, so we created a car class. Then we looked at how we can create objects from that car class. And then we learned about initializers that can be used to change the properties of the object. Now, I hate to break it to you, but our car is still a bit of a dud. It doesn't yet do anything. If we look back at the slide where we talked about what objects are capable of, we can see that we've already explored and talked about properties in great detail. We've also looked at events in the form of the initializer method. Now we're going to talk about actions, and we're going to add a very basic action to our car so that it's able to drive. So below the convenience initializer code, which is this part, I'm going to create a new function, which, remember, when a function is inside the curly braces of a class, it's known as a method. So I'm going to be creating a method called drive. So of course you remember you first use the func keyword to create a function or a method, and the name of my method is going to be drive. And then I'm going to have some empty parentheses because it's not going to take any inputs. And then I'm going to open a curly brace and hit enter to automatically insert the closing curly brace. Now, even if you're creating a toy car or a robot car, there's a lot of potential code that you could write. Now, we're not going to do that because I'm going to talk about something quite specific. So all that I'm going to do is I'm going to write a print statement that basically says car is moving. So now let's go ahead and give our method a spin. So if we head back over to the main.swift file, now I'm going to get rid of all of these lines because I want to talk about something else. So here, what we're going to do is we're going to tap into that drive functionality. And I'm going to use my car, which, if you remember, is the object that we created using the car class. So my car, and I'm going to use the dot notation to tap into either its properties, color, number of seats, type of car, but also here you can see the drive method. So M is for method and V is for variable. And I'm going to hit enter to tap into that drive functionality. So now if I run my code, let's see what happens in the debug console. So you can see that it prints car is moving. And this is, of course, from calling the drive method over here. So remember again, when a function is defined within the curly braces of a class, it's no longer called a function, but instead it's called a method. So here we've created a very simple method that adds a bit of functionality to our car class. And once we've created an object using that class, we're able to get that object to perform the drive functionality. So the important thing about methods is that they are always associated with an object. It's the drive capability of my car that prints this line into the console. Now contrast that with something that is just a function. For example, the arc for random function. we're able to print the result of the arc_for_random_uniform function without associating that function with any object. We don't have to say mycar.arc_for_random, and that's because it's a function and so it's not associated with an object. But at the end of the day, functions and methods are both bits of code that perform some sort of action. Don't get too bogged down on the terminology of things. As long as you understand how it works, then it's all good. Let's delete that line. And in the next lesson, we're going to use this drive method to talk a little bit more about class inheritance. So I'll see you there. So in the last lesson, we looked at the difference between methods and functions, and we built and enabled this drive capability to the car class. Now, in this lesson, we're going to talk about inheritance, and to do so, we're going to continue this car analogy. So our car is able to drive, which is great, but we've noticed that there's a lot of traffic in our city, and our users are all talking about this self-driving car from some company called Tesla. So what we're going to do is we're going to build our very own self-driving car. But a self-driving car is kind of different from a normal car. So in order to build this self-driving car, we need a new blueprint. So go ahead and create a new Swift file and call it self-driving car. In that new file, you're going to create a new class, again called self-driving car. So pause the video and see if you can go ahead and do that. Okay, so how did that go? So we did the same thing when we created the car.swift file. Essentially, all we need to do is to select the classes and objects folder so that we can create a new file within that folder. And then we go over to File, New File. And under macOS, we create a new Swift file and we hit Next. And as I said, we're going to call it self-driving car. And again, checking that it's going inside this classes and object folder over here, and also that it targets our program, which is called classes and objects. And then we're going to go ahead and create this new file, and there we go. It's appeared right over here. So under import foundation, we're going to create a new class called self-driving car. So remember, to do that, we need the class keyword, and then we write the name of our class, which is self-driving car. And then we open a curly brace and hit enter. And there it is. We've got a new self-driving car class created. Now, a self-driving car has a lot of the same properties as a normal car. It needs a color property, it needs a number of seats property, and it needs a type of car property. So if you remember, the first rule of Fight Club is don't talk about Fight Club. The first rule of programming is that programmers are lazy. So I don't want to type all of this out. I don't even want to copy and paste it. What else can we do? Well, we can make the self-driving car class inherit from the car class. And in order to do that, all we need to do is to put in a colon and write car. So now our class self-driving car inherits all the properties and methods from the car class. So in programming, we would say that the self-driving car class is now a subclass of the car superclass. So it's like how there's George Bush Sr. and George Bush Jr. The car is the senior and the junior is the self-driving car, which inherits all the capabilities and properties of the car class. But don't take my word for it. Go ahead and try it out. See for yourself. Go into main.swift and create a new object from the self-driving car class and call that new object my self-driving car. Then make that car perform the drive method and then check to see what is the color of a default self-driving car. So go ahead and pause the video and see if you can go ahead and do that, and see if you can do that. All right, so I hope you guys have given it a go, because it's very easy to follow along and listen and nod, but only until you start typing and put code into the computer do you actually start understanding and getting a good grasp of all of this. So I really urge you to follow along with what I'm typing, but also to complete the challenges. Okay, so the challenge was to create a new self-driving car object. So we're going to do it down here in main.swift, and I'm going to create something called my self-driving car, and it's going to be created from the self-driving car. And then I'm going to open and close some empty parentheses. And I wanted to perform the drive functionality with this new object. So my self-driving car dot drive. There we go. And then the other thing that I wanted to do was to check its color. So my self-driving car dot color, and then we'll just print the result of that to the console. So let's go ahead and run the program and see what gets printed. So this first line is the my car object driving, and the second line is my self-driving car driving. And finally, the color of my self-driving car is printed as black. So there we go. So everything that a car has or can do, a self-driving car can do and can have. So this is essentially inheritance. Now, inheritance in programming actually works very similarly to inheritance in real life. So I'm going to use the animal kingdom to explain exactly how all of these superclasses, subclasses, and inheritance actually work. Now, if you remember from biology classes, at the top of the pyramid, there are the animals. And we've created a very simple class called animals that has a single method associated with it, and that's being able to breathe. Now, that's pretty simple. Now, what if we created some classes that inherited from this animal class so that they too can breathe? So we can create a class called the mammals, which inherits from the animals class. And remember, we specify inheritance by using the colon symbol. And then we can create another class called birds, and they also inherit from animals. So both birds and mammals inherit this breathe functionality by inheriting from the animals class. But in addition, birds, for example, not only can they breathe, i.e. have access to this method, but they've also got their own unique method, which is fly. So birds can breathe and birds can fly. Now, mammals also inherit the breathe functionality from animals. So mammals can breathe, but mammals also has a unique property of its own, i.e. it has hair. Now, believe it or not, but Wikipedia says this is one of the most unique things about us. I'm really sad about it too. So go mammals, we have hair. That's great. So essentially what I'm trying to illustrate is that we've created two subclasses from a superclass. So animals is the superclass of mammals, and mammals is the subclass of animals. Now, subclasses inherit from their superclasses, just as children inherit from their parents. And mammals inherit the breathing capability, and birds also inherit the breathe capability. Now, let's go one step further and create another subclass from the mammals superclass called humans. Now, humans inherit from mammals, so not only does it have the property has hair, but it also has the functionality breathe. So it's inheriting everything up the line. So humans can breathe, which is inherited from the animals superclass, and humans also have hair, which is inherited from the mammals class. And finally, humans have their own unique capabilities, such as use computer or write Swift code. So this is all just to illustrate the point of subclasses, superclasses, and inheritance of properties and methods. So just to drill it home, subclasses inherit from superclasses, and they inherit all the functionalities and properties from their superclass. Now, what if we don't just want to inherit the same capability? So for example, if we had a fish class that inherits from the animal class, not only is it able to breathe, but it's actually got a different version of the breathing functionality, i.e. it's able to breathe underwater. So in order to override a particular functionality that a class inherits, namely the breathe functionality, we use the override keyword in front of the breathing functionality that's inherited. And then we write super.breathe, i.e. do everything that your inherited version of breathe does, but then do something extra, i.e. breathe through your gills or breathe underwater. So this way, the breathe method for the fish class is inherited from the breathe method of the animal class, but it's then modified so that it's able to breathe underwater. So if you look inside the viewcontroller.swift file of any of your apps, so currently I've got Quizlet open right now, you remember that there was this override func viewDidLoad method that we used really frequently. Now have a look at this. Essentially, what this does is that this particular class is called viewController, and it inherits from something called UIAlertController, and that is the superclass of viewController. Now, in that superclass, there is a method called viewDidLoad that specifies everything that should happen when the view loads up on screen. Now, in our viewController, because we want to tap into this time point when the view loads up, we use the override func viewDidLoad line of code. That means that we know we inherit viewDidLoad from the superclass, but then we're going to override it so that it also does our own thing. The first line inside the curly braces is super.viewDidLoad, and the super refers to the superclass of viewController, which of course is UI viewController. Now this line says in that UI viewController, we're going to perform the viewDidLoad method. So do everything you need to do in order to load up the view, and then you're going to do what I want to do within my viewController. So that's essentially all it is. All right, so we've seen the theory of inheritance. Let's go ahead and modify our self-driving car class in order to put some of that theory into action. So firstly, open up your self-driving car.swift file. And the first thing that we're going to add to this class is a new property called destination. Now remember that if you have a normal car, the destination is determined by the driver. But in a driverless car, we're going to have a way of modifying and inputting a destination for the car to drive towards. So I want you to create a property called destination that is of type string, and it's going to have a default value of 1 infinite loop, which is of course the address of Apple's headquarters. So that means that the default destination for our self-driving car is always going to be driving back home to where it was created. So pause the video, go ahead and try it out. All right, so how did that go? Now, first thing we do is we write keyword var, and then we're going to write the name of the property, which is destination, and it's going to be of type string, and it's going to be set to an initial value of 1 infinite loop. So that's a unique property to the self-driving car. It has nothing to do with the car class. And the next thing that we're going to do is we're going to put in the drive functionality for the self-driving car. Now, if you just go ahead and write a new method, say func drive, and you try to put that in there, you will get an error and Xcode will complain. If you click on the error, it'll tell you that the overriding declaration requires an override keyword. Now, what does this mean? It's saying that by inheriting from the car class, you already have a method called drive. And it's saying that if you're trying to override the inherited drive method, you're going to have to include the override keyword. So remember that when you have an error with a white circle in the middle of it, it has a suggestion as to how you can fix this. So go ahead and hit enter to insert the override keyword in front of your method drive. So now what we're saying to the computer is that I know I've inherited this drive method that contains everything that the drive method has in the car class, but I also want to give it some additional capability. So in order to tap into the capabilities of the inherited drive method from car, i.e. this line, what we have to do is we have to use the super keyword. And super refers to the superclass of the self-driving car, which is, as we know, to be car. And Xcode is also very helpful telling you that super is referring to the car class. And then we're going to use the dot notation to access its drive method. So by writing super.drive inside this overridden method, before we do anything else, the first thing we want to happen is for it to carry out all of the code that is included in the inherited drive method. So print car is moving, essentially. And then afterwards, we want to put in our own custom capabilities. So for a self-driving car, that means driving to the destination. So I'm going to keep this simple and just write a print statement. So now, when we create an object from the self-driving car and we use the drive method, it's first going to carry out all the functionality in the drive method of the superclass, and then it's going to carry out the added on functionality that's unique to the self-driving car. So let's go ahead and give that a spin. If we head over to main.swift and just get rid of some of these lines of code so that it's less confusing, and let's get rid of these two as well, just to make it super clear. So all we have left is we created a new object called my self-driving car using the self-driving car class. Next, we're going to call or use the drive method in my self-driving car. So now if we go and hit run, let's see what happens in the console. First line, car is moving, that comes from this line, super.drive, which, if you remember, goes into the inherited drive method and carries out everything that's in there, i.e. print car is moving to the console. Now, the next line in our souped up version of drive is to print driving towards the destination. And of course, the destination was set by default to one infinite loop. So it prints driving towards one infinite loop. So essentially, with those few lines of code, we were able to inherit from a superclass and inherit its properties as well as its capabilities. And then we used the override keyword to override or add to that inherited functionality and make it more specific to this subclass, self-driving car. Now, I know there's a lot of new words that's being thrown around in this lesson, so if you're confused or if anything doesn't make sense, just go back and re-watch the last video as well as this one so that you really get to grips with inheritance, because we use it a lot in our Swift programming and app projects. And as always, if you have any questions or if anything is unclear, feel free to ask in the comment section below, or tap into our community on Slack. So in the next lesson, we're going to be talking about optionals. We're going to address why we've been using all those question marks and exclamation marks in our code. So all of that and more in the coming lessons. See you there. Now, for the keen-eyed among you, you would have noticed in some of the code that we've created or some of the code that has been created for us by Apple's templates that you would have come across these question marks and exclamation marks. Now, this is a good point to address exactly what these things are. So let's head back to our self-driving car example. Now, in this class, we've created a property called destination, and this is meant to be where the self-driving car should head towards. But when we created this new property, we gave it a default value of one infinite loop, which is the headquarters of Apple. But in reality, that's a little bit autocratic. Why should every single self-driving car that comes out of the factory have its default destination set as the Apple headquarters? I mean, you can imagine this Skynet situation where all of the car fleet starts driving by itself, heading back towards Apple's headquarters with you in tow. But, besides aside scenarios where AIs take over the world and kill all humans, let's think about this problem on a more practical level. It would make more sense for the self-driving car to come out of the factory with no destination set. So the destination should be nil or nothing. And in programming, nil, which is nothing, and an empty string is completely different. So this is actually data. Whereas if we set it to equal nothing, then there is absolutely no data. In programming, very often you'll find the need to have properties or variables that start off with a nil value, but only later gets filled in with a value. So for example, if you had a form where people had to fill in their names, that might initially start off with a nil value, and only after the user's completed it do you get a value inside that variable or property. So in our case, we want the destination property to be nil until the user sets it. But what if the user doesn't set it and later we try to use it? If you try to do any sort of calculation or execute code that contains a nil value, then you'll get a bug and an error that will crash your program. And this is a very specific type of bug. In programming, it's called the nil pointer error. In programming, it's called the null pointer error. So that's basically where you try to do something with a variable or with a property that contains a nil value. So instead, when we're programming in Swift, the right thing to do is when you want to create a property, so this is at the creation stage, remember when we use the var keyword, you can use a question mark after your declaration. So you've said var, which is creating a new variable, or in this case, a property, its name, and its data type. And finally, question mark simply says this could contain a nil value. Now that error has gone away, but we've now got a new error. And if I click on that error, the message tells me that the value of the optional is not unwrapped. Did you mean to use an exclamation mark or a question mark? Now to translate that to English, it means that when we create this property that has a question mark at the end, we've created what's called a optional. Now, that means it might contain a value or it might not. But in order to use it at a later point, such as what we're doing here, you'll have to force unwrap the optional. And you do that by using an exclamation mark. Now, what that says to the compiler is basically you, the programmer, swearing on your life that this property or variable definitely is not nil. So that's what that exclamation mark says. It says, I know what I'm doing. This destination property is never going to be nil at this point. And I'm happy to put an exclamation mark as a signature saying that I, the programmer, is 100% sure. Xcode, stop trying to be helpful. So as you can see, the errors go away, and this is basically Xcode leaving you to your own devices and saying, whatever, human, you can deal with the consequences. So the problem here arises when we try to run our code. So remember that in the main.swift file, we created this object called my self-driving car, and we tried to get it to drive. Now, when it starts trying to drive, it will go into this function and try to print driving towards destination. And as you can see, what has happened is that our program has crashed. There's a line showing you where the crash occurred. And in the debug console, you can see this error message. Fatal error, unexpectedly found nil while unwrapping an optional value. And that is entirely our fault because we put in the exclamation mark telling Xcode that it's fine. You can go ahead and unwrap this optional. It will contain a value. It's never going to be nil at this point. But in fact, nowhere in our code do we actually give the destination variable a value. And the compiler can't compute something that is nil. You can't print nil. It just doesn't work. So essentially what I'm trying to highlight is that this is one way where you can fall down with optionals. Whenever you find yourself putting in an exclamation mark, this is essentially you pressing the manual override button. And you're getting rid of a lot of the safety features of the Swift programming language. So it's meant to act as a point where you as the programmer has to think carefully about whether if this property or variable can be nil. And only in cases where you are certain, or usually in cases where programmers are lazy, you see this exclamation mark. Now, let's say that we've realized that our program has crashed because we haven't given the destination variable a value. Then we can obviously head back. Let's just stop the code and head back into main.swift. And before calling this drive method, we're going to give the destination a value. My self-driving car dot destination equals 1 hack away. So let's make all of our Apple cars go towards the headquarters of Facebook. So once we've set the destination and we hit run, then you'll see that our program works perfectly. Cars moving, driving towards 1 hack away. So even though it works now and we fixed our bug, this is not where we call it a day. Because what if next time we try to use self-driving car and we forget to set the destination again? Your program or your app will crash, and on the user side, when they're looking at their app, they won't be able to tell what is going on. You will just see your app crash and quit, and it'll throw the user back onto the home screen of their iPhone, which will inevitably result in loads of 1-star ratings and reviews. So in order to prevent that, we're going to use a safety mechanism so that this situation never ever happens. And the safety check is basically a if statement. So what we're going to do is, before we call this print statement where we use this destination property, we're going to write an if statement. So if destination does not equal nil, then and only then we will print driving towards the destination. So in this case, even if we go back to main and we just comment out that line where we set the destination. So just as a reminder, that means the destination property is now nil because we have not given it a value anywhere in our code. And if we try to run our app, you will see that this line does not get printed, but our program also doesn't crash. So now our app is infinitely safer than it was a moment ago. Now, there is a slightly swiftier way of doing this, and its name is called optional binding. So let's change our code to use optional binding to check and make sure that the destination property definitely has a value before it gets used in any line of code. So we're going to modify our code to change it to if let user set destination equals destination, then print user set destination. So now if I run the app again without a value for destination, you'll see that the same thing happens. You don't get this line executing, but the app does not crash either. And this is essentially the syntax for optional binding. And if we just examine this line a little bit closer and see what's happening, essentially we're using the let keyword to create a new constant called user set destination. And the value of that new constant is set to equal the value of our optional, which is called destination. Now, the lines of code between the curly braces of this if-let statement only gets executed when destination is not nil, i.e. when it has a value. Only when it has a value can it be assigned to this new constant user set destination, and we use the variable user set destination instead of using the optional destination. Now, the benefit of this is that if you look at our code, by using optional binding, we don't need to force unwrap anything. You won't see a single exclamation mark in sight. And that means that our code is safer. It will only execute in the cases where it's safe to do so. So that, in a nutshell, is how optionals work. And we've spoken a little bit about the unsafe way of using optionals, which is force unwrapping. And we've also spoken about how to use optionals safely, which is by using optional binding. Now, in the next lesson, I'm going to talk a little bit more about optionals. Because it is kind of abstract, we're going to show you what the concepts are behind the scenes. So I'll see you there. So as you've seen in the last video, we've spoken a little bit about what optionals are and how they can be used. Now, because this is such a core concept in Swift programming, we're going to try and drill these ideas home. Essentially, what the hell are optionals? Instead of looking at code, let's imagine instead that we have a box. So remember, our variables are boxes. And in this box, we're going to put in a cat, right? So Tommy is going inside the box. Now, additionally, we're also going to put a bottle of poison into the box, which is very easily broken into and can explode at any time, killing our cat, Tommy. Now, if we go ahead and wrap up our box and we imagine that we can't hear any sounds, we just leave the room or go on a long haul holiday. Now, the question is, when we come back, is Tommy the cat alive or dead? So many of you will recognize that this is essentially the problem of Schrodinger's cat. So the idea that the cat is simultaneously alive and dead until we open the box, or in our case, if the box represents an optional where it can contain nil or it could actually contain a value, then only when we unwrap that box do we find out if it is nil or not. Now, only once we've unwrapped that box can we figure out if there is a value or not. Now, option 1 is that Tommy is alive and well, the poison was intact, and he's happily alive. Now, option 2 is that the poison exploded, killing Tommy the cat, and we now have a dead cat in a cardboard box, which is not a great situation to be in. So creating a variable that has a question mark at the end means that we're creating an optional. And that means you have this closed box situation where it could contain a value or it could contain nothing. Now, only when we try to use the variable do we need to open the box and find out if it contains an actual value or if it contains nil. So in the cases where our box contains nil, then our program will crash. But in the cases where the box does contain a value, then our program will continue to run smoothly. Now, using the exclamation mark after the name of the variable is called force unwrapping. And that's basically, in our situation with the box, is just tearing off the tapes, force unwrapping, and dealing with the consequences, whatever it may be. Now, the other option that we spoke about, which is called optional binding, in that case, what we're saying is that we want to shake the box first and see if it contains anything. If it seems to contain nothing, then we'll just leave the box alone and ignore it instead of crashing our program. Now, if we shook that box and it did indeed contain something, then we will proceed to continue to execute the rest of our lines of code. So if we look at the code again, in order to declare a new optional, the syntax looks identical to when we create a new variable or a new property. Now, the only difference is this question mark that we tag at the end. And what it does, this question mark, is that it changes the data type of this destination variable from a string data type to a optional string data type. Now, those are two distinct types, and every other data type, for example, integers or floats or UI label, has an optional counterpart. Now, in order to use a variable of a optional string data type, you have to put the exclamation mark at the end. And what this effectively does behind the scenes is that it converts that variable from having a data type of optional string to a data type of string. And that is called force unwrapping. Now, as we said, force unwrapping has its problems because it's basically a manual override over the safety mechanisms. And if destination at this point is nil, then this line will cause your app or your program to crash. Now, the safe way of doing it is by only implementing the code that could contain a nil value inside an if statement. So only when that optional is not nil does it get used in a line of code, and preventing any crashes because of this. And as we mentioned, the Swift way of doing this is by using the if let keyword. So if let a new constant equal the value of our optional, If that optional has a value, then this line of code gets executed. Now, the thing that you should notice here in this Swift code is that there are no more exclamation marks. We're not force unwrapping anything. Instead, we are playing it safe and we're checking to make sure that the destination variable does indeed contain a value. If so, then it should be set to a new constant called userSetDestination, and we will use that new constant, which definitely has a value from now on. And if the value of destination is nil, then this check does not pass and none of this code in between the curly braces gets executed. So in this module, we've spoken about some harder topics in Swift programming. There's quite a lot of code that we've covered, and there's some very abstract concepts like optionals or inheritance. Now we're going to be using all of these concepts in the coming tutorials, and your understanding will become more solidified as you begin to use some of these concepts instead of just seeing them in an abstract way. But as always, if you have any questions, feel free to ask your questions in the comment below this video. Now, if you try to run your app at this point, you won't see that permission pop-up come up. And the reason for that is because you need to add a description for those pop-ups in order for them to appear. And in order to do that, we have to go and edit the property list or the P list. So when you create a new Xcode project, by default, you will have an info.plist file that gets created in your supporting files folder. And if you click on it, you can see that there's a whole bunch of different properties which you can set the values to. Now we're going to leave all of the default and preset ones alone, but instead we're going to add 2 new properties. So in order to add a property, you go to the part where it says information property list, and you're going to click on the little add button here. Now by default, it fills it with something called application category. So if you delete the application category and start typing privacy with a capital P, then you'll start seeing the suggestions pop up. And the one that we want is the one that says privacy, location, usage, description. And we also want the one that's privacy, location, when in use, usage, description. So just go ahead and click on that one and add the other one as well. So now if you expand this field, you can see that you've added 2 new keys to your property list. One is privacy, location, when in use, usage, description. And the other one is privacy, location, usage, description. Now, the reason why we're selecting them from the drop-down list is because you have to type these keys precisely. So when you call this method, request when in use authorization, Xcode will go and look for the description or the value of these 2 keys, and it will use them to display a pop-up to the user. And if these are named ever so slightly differently, if you just made a typo or a spelling error, then it won't be able to find it. So it's much easier looking for it in the drop-down list and just clicking on it so that Xcode inserts it automatically. That'll save you quite a bit of headache. Now, the next thing we have to do is give each of these descriptions a value. And this is simply writing, and this is simply figuring out, and this is simply what our pop-up is going to say when it asks the user for their location permissions. So we're just going to write, we need your location to obtain your current weather conditions. And I'm going to copy and paste that into the location usage description as well. So now I have 2 new keys and they each have a value that is of data type string. Now that was showing you one way of editing your property list. The other way of doing it is through code. So if you right click on the info.plist, you can actually open it as source code. And that's because this file is normally structured using XML, or Extensible Markup Language. And for those of you guys who are familiar with HTML, this should look quite familiar. Now, the reason why we didn't ask you to add in these keys and their values in the XML is because in Xcode, the error handling and the color coding of XML is not great. So it's less error prone when you edit it using the So it's less error prone when you add the keys through the property list. But the next thing that we need to do will require the XML format, and that's because we need to add in quite a few keys. So if you head back over to that repository page where we downloaded our project from, so github.com/londonapbreeze/Klima, you can see that right at the bottom of the README, you have this section which says Fix for App Transport Security Override. And this is the part, and this is the code that we're going to insert into our property list. Now, the reason why we need to do this is because Apple have specified that iOS devices should only communicate to APIs that have a HTTPS, which is a secure protocol for transferring of data. Now, the problem we have is that in order to access the APIs on OpenWeatherMap through HTTPS, you actually have to go to one of their paid plan options. And because we're more interested in showing you how the coding part works or how to call APIs, we're going to leave it up to you whether if you want to pay for API access to OpenWeatherMap. So we're just going to use their free tier, which unfortunately does not have SSL, and so we can't use their HTTPS address. So to work around that, we've included this bit of code. And that basically allows the iPhone to load data from an HTTP URL. So all you need to do is select all of this code and hit copy. And then you're going to insert it just below this string, the part where we said we need your location to obtain your current weather conditions. You're going to hit enter and then paste it into here. Now, when you right-click and view this plist as a property list again, you can see that your app transport security keys have now been formatted and magically been inserted. And this will allow you to call the OpenWeatherMap APIs without needing their HTTPS URL. So once that's done, we're going to hit save, and then we're going to run our app on a simulator. Now, when you launch your app, the first thing that you should see is this pop-up that uses what you wrote in the plist, i.e. we need your location to obtain your current weather conditions, and it requests the user to give location access. So go ahead and click allow, and that'll mean that our app will be able to tap into the GPS sensor for the next part of our module. Now, if you accidentally press don't allow, don't worry, you can go to hardware and go and simulate the home button pressing. And you can go into settings, location services, make sure it's on. And then for Klima, you can enable the while using the app location permissions. So if that's not enabled, then the next part of the code won't work because the system just won't let it have access. So currently our app doesn't do anything yet. So this temperature label was hard-coded, and this loading label just says loading because that's what we typed into the label. Nothing is actually loading, nothing's happening because we haven't told it to yet. In the next lesson, we're going to look into how we can use the location manager to grab the user's current GPS coordinates. So all of that and more on the next lesson. See you there. All right, so now that we've been given permission to access the user's location data, it's time to write the code that grabs that location data. So we're going to head back over to weatherviewcontroller.swift, and just below where we request our when in use authorization, so that was your location data permissions, we're going to call another method. So we're going to use the location manager object, write a dot to tap into its methods and properties. And we're going to call the method called start updating location and hit enter. And this basically starts up the process where the location manager starts looking for the GPS coordinates of the current iPhone. Now, you can have a read of this method in terms of how it works and how you use it. But the important thing to remember is that this is what we call an asynchronous method, which means that it works in the background to try and grab the GPS location coordinates. If it worked in the foreground, i.e. if it was on what we call the main thread, then it would freeze up the entire app. You won't be able to interact with it until it's done looking for the GPS location. Now, depending on the accuracy that you're looking for, that could be quite a few seconds where the app doesn't let the user do anything, click any of the buttons, and for all intents and purposes, look like it's crashed to a normal user. So that's not a very good user experience, which is why these kinds of intensive methods tend to happen in the background. Now, what happens once it does find the location? It has to report back that location somehow, right? Well, what happens is that this method will run in the background looking for the GPS location. And once that location becomes accurate enough, then it will send a message to this view controller, because we said that we are the location manager's delegate. We are the location manager's boss. So it will send us, i.e. the weather view controller, a message saying that I'm done updating the location. Here are the coordinates. And in order to receive that message, we have to include a method called didUpdateLocations. So just below the part of the comment where it says write the didUpdateLocations method, we're going to write function. Okay, so this is the one that we want. And the description of that method says that tells the delegate that new location data is available. So remember, the delegate is the weather view controller. So once the location manager has finished looking for the data, it will send a message through this method telling the weather view controller that it's got the data. So we're going to go ahead and hit enter so that Xcode can insert all of that code for us so we don't have to type it out. Now, here's something that'll make your life a little bit easier. Whenever lines of code get a bit too long, they will wrap over to the next line, and that can make it look kind of confusing. So if you don't have a lot of screen real estate, i.e. if you're not working on like a 21-inch iMac, then it might be a good idea to get rid of some of these side panes so that a single line of code is kept as a single line, and it'll be a lot easier for you to try and discern what's going on. So this is the method that gets activated once the location manager has found a location. And inside these curly braces is what will happen once that has been completed. Now we're going to add another delegate method from the location manager that is called didFailWithError. You can see that this is the method that we want, and it comes from the location manager. And its description is that it tells the delegate, i.e. weather view controller, that the location manager was unable to retrieve a location value. And that can happen for a number of things. Maybe it's because the user is in airplane mode, or maybe they have no internet access. So there's a number of things that can happen that leads to this method being triggered rather than this method. So what we want to do is that if there was an error in retrieving the location, we want to print to the console the error. And then we want to tell the user that there was an issue retrieving their location. So we're going to use this label here, which, if you remember, is linked to an IB outlet called city label. And we're going to make that label display location unavailable so that the user knows that there's something going on. Maybe, get out of the tunnel, maybe turn off airplane mode. So we'll set the city label .text property to location unavailable. So now we've dealt with the situation where there's an error with finding the location. Let's deal with what should happen when we actually do get the location back. So that's going to go inside these curly braces. Now, the first thing to point out is that this method gets triggered when there is an error, and you can tap into that error using this parameter called error. Now, in this case, when the location manager actually manages to find the location, then it saves it into an array, as you can see by the square brackets, of core location objects. Now, if we have a look at CL location objects, it says that the object incorporates the geographical coordinates, so the latitude and longitude, as well as the altitude of the device's location, along with values indicating the accuracy of the measurements and when these measurements were made. So a CL location object contains all of those things. So when you ask the location manager to get the current location, as we did with this line of code, start updating location, each time it gets a new value, it adds it to this array. So we end up with an array of a whole bunch of locations. Now, we're only interested in the most accurate location. So you can assume that this location manager narrows down the accuracy over time. So maybe the first location it gets is a rough estimate, and then it gets more and more precise. So the last value in this array is the one that will be the most accurate. So that's the one that we want. So we're going to create a constant called location, and it's going to be set to the last value in this array of locations. Now, in order to tap into the last value, all we need is to get the locations dot count, i.e. how many values are there in total, and then we're going to grab the last value. So if there's an array with 4 objects, then the count will equal 4. But remember, arrays are counted beginning with 0, so 0, 1, 2, 3, 4 will not exist. So that's why we use locations.count -1 in order to grab the last value. So the first step that we have to do with any of these locations that come back from the location manager is that we need to check to make sure that they are valid. And a very simple way of doing that is by simply checking to see if the location's horizontal accuracy is greater than 0. Now I'm going to explain why we just wrote that. So if you imagine the latitude and longitude plotted on a map of the world, the horizontal accuracy is the radius of a circle indicating where the user is likely to be. So the higher the value, then the higher the spread of possible locations. But when that value is negative, i.e. below 0, then that represents an invalid result. And so our check is to make sure that the value that we're getting back is not invalid. And if so, then we will ask the location manager to stop updating locations. And you always want to do this when you are implementing the location manager or trying to grab the GPS data, because this is a very energy-intensive process. Unless you want to destroy the user's battery and end up getting a whole load of bad reviews, you should stop updating the location as soon as you've gotten a valid result. Okay, so now that we've got a valid result, let's print it out and see what it is. So let's print . So here we're using that location constant, which should be the last location in that array and the most accurate location we've got. And we're tapping into its coordinates. And then from the coordinates, we're getting the longitude property as well as the latitude property. So let's give it a try. Let's run our app on the simulator and see what happens. So by running it on the simulator, you might get an error that says this: KCL, so CL stands for core location, error domain code 0. And this is basically telling you that the simulator doesn't have its own location. It's not like an iPhone, which actually has a GPS. So if you try to run this code on your own device, then you shouldn't be getting this error. But because we're running it on a simulator, this is what it reads. Now let me show you how you can fix that. So the simulator has simulated locations as well. And in order to get to those, you have to go to the debug menu, then go to location, and we're going to say that we're currently at Apple's headquarters. So now all of a sudden, our location manager code is working and it's printing out our longitude and our latitude. So if you head over to your browser and you go to a place called latlong.net, and then you go to the latlong to address page. And if we copy the longitude and the latitude, let's find out where our simulator is at. So after reverse geocoding, it tells us that we are in Cupertino in California, which if you zoom in on the map is the Apple campus. So that's great. That means our code is actually working and it's grabbing our location data. So it's no use printing these coordinates into the debug console because only the developer will get to see that. So instead, let's turn these coordinates into parameters, which we will send to the OpenWeatherMap API. So I'm going to create a constant called latitude, And I'm going to set it to equal location.coordinate.latitude. And then I'm going to create another one called longitude. And it's going to be set to location.coordinates.longitude. And then I'm going to combine these two into a dictionary. So I'm going to call it params. So my parameters, which I will send to OpenWeatherMap, and the structure of the data will be a string as the key and a string as the value. So if this syntax looks unfamiliar to you, have a look at the lesson where we discuss dictionaries. And that's going to be equal to an array of various dictionary objects. So the first object is going to be called lat, so that's the key. And then the value is going to be this latitude constant. And then we've got another parameter called lon, and it's going to be set to equal to the longitude constant. And finally, in order to complete our parameters for this OpenWeatherMap API, we need to have a key called app ID. And that's going to be equal to the app ID constant that we put up here. Now you'll notice that my wording for these keys are specific. I didn't just make them up, but instead I got them from the documentation of OpenWeatherMap. So if we have a look at their APIs page and we go to the current weather data API documentation, you can see that you can get the current weather conditions by geographic coordinates by creating a call that has the parameters of lat and long. Now, they've been a bit naughty and they haven't properly updated their documentation. But if you click on this URL, you can see that this is the full URL of that API call. Now, in this API call, you can see all the parameter names. So you have a lat, you have a lon, and you have an app ID. So those are their three parameters for a valid API call. And I hope at some point soon they're going to update their documentation. If you try to make this call without the app ID, then you'll see that it gives you an error message saying that you don't have an API key. Instead, go here and see what the problem is. So it says API calls returns error 401, and that is because starting from 9th of October 2015, their APIs require a valid app ID for access. So coming back to our code, that's why we've specified these three parameter names, because we modeled it on their URL. Now at the moment, Xcode is giving me an error, and if we click on that error, we can see that it says cannot convert value of type CL location degrees, i.e. a double, so they're talking about the latitude here, to expected dictionary value of type string, which is what we specified over here. We said that all the values in this dictionary should be of data type string. And that's because we need to construct our URL from strings. So in order to get rid of this error, we need to convert the latitude and longitude into strings. And if you remember, we do that by writing string and then enclosing the value inside some parentheses. So I'm going to go ahead and do that for both. And now, magically, your error will disappear, only to be replaced by a warning. And this is a warning that happens quite frequently. And it's basically telling you that params was never used. But actually, that's because we haven't used it yet, not that we're not going to use it ever. So whenever you see this type of error, as long as you remember to carry on and use it, then don't worry about it. So now that we've constructed our parameters, the next step is to do some networking and send our request to OpenWeatherMap in order to get some weather data back. So I'm just going to take a moment to explain what delegation is so that you can understand why we set the delegate property of the location manager. So say if we wanted to pass some data from class A over to class B, an easy way of doing this would be to create a B object using the blueprint or the class. So in this case, this is the B class, and here we've created an object using that blueprint called B1. Now additionally, if we know that inside this B class there is a property called data, then we can simply write the code B1 dot data to set the data property in this B1 object as whatever data we want to pass from A to B. So say if we imagine that these are in fact view controllers, then in order to pass information from one screen to the next, from one view controller to the next, all we have to do is to create an instance of the second view controller and set a variable or property inside that object to whatever data we want to pass. Now the problem arises when we want to use the code that's provided by Apple, so something like UI button or UI slider or core location. So in our case, we're using core location, and once the location manager has found the user's current location, it will send out an address saying that I found it, here's the address. Now the problem is, how do we pass that data from the location manager, namely the code that Apple wrote, into our own view controller? Now we can't use the same method that we spoke about earlier to pass that data. And the reason for that is because in this case, both view controllers are created by ourselves, so we know what are the properties and what are the methods in each of these classes. And so that's how we know that there's a variable in the B class called data, and we set that variable to the data that we want to pass it. But when we're using core location, it's impossible for core location to know what properties or variables are within our view controller, because core location was written by Apple engineers, and it was written long before we started writing the code for our own view controller. So how do we get around this? Well, that's where delegation comes in. The delegation pattern is a bit like as if our view controller was putting its hand up and saying that I'll be the one who'll deal with the location that you find. I will be the delegate for the location manager. And so it becomes very simple for the location manager. Once it finds the location, it will send it out to the delegate. And if the delegate happens to be nil, then nothing happens with that information. But if the delegate happens to be set, i.e. in our case, it's set as our view controller, who's going to handle the data that comes from the location manager, then the core location data will get sent to the delegate. And once our view controller receives that data, then it can use it to find the weather data. So in a nutshell, that's how we're delegating the location that the location manager finds. Now, because the code inside core location is proprietary to Apple, i.e. it's not open source, we can't actually see how they set up that side of delegation. But in a later episode, when we're creating our own delegates and our own protocols, we can see the whole picture, both sides of the coin, and we'll dig deeper into this concept of delegates and protocols. But for now, all you need to know is that if you want to use the location manager, then you have to set a delegate for the location manager, i.e. set a class that will deal with the location once the location manager finds it. In the next lesson, we're going to look at some of the methods that the location manager has, and we're going to implement some of those methods in order to get the GPS location of the user. So this is a good opportunity to explain what dictionaries are and how they work in Swift. So they're modeled on their real-life counterpart, i.e. dictionaries, where you have a word and an associated meaning. In programming, we use dictionaries to associate a key with its value so that any value can be identified as long as you know the key. And when you create a dictionary, you can put in more than one of these key value pairs as long as they have the same data structure, i.e. in this case, a key that uses the string data type and a value that also has the string data type. Now, as long as your key value pairs all have the same structure in terms of data types, you can mix and match whatever data type you want. So in this case, we have a key made of strings and we have values that are made of integers. And in this case, our dictionary actually uses Swift's ability to infer the data type because we haven't specified it explicitly. Now, of course, you can also create your dictionary by explicitly stating how the data should be structured. So here we're creating a new variable called dict that has a data type that's structured in this way, namely keys that are made of strings and values that are made of integers. And our key value pairs all abide by this rule. So in previous lessons and previous modules, we've been using and have come to be familiar with arrays. Now, arrays are another collection type, another way of organizing data. Whereas in arrays, what matters the most is the sequence of data, i.e. brewery is at index 0, bakery is at index 1, and blacksmith is at index 2. So that means if we wanted to retrieve bakery out of the array, we would have to specify the index of 1. Now, dictionaries work slightly differently. They organize data using these key value pairs. So we would retrieve data using the key. So let me use an analogy to show you the difference between these two collection types. Now, let's say that you got a job at the local cinema in their cloakroom. In order to organize your cloakroom so that it's as efficient as possible, you've devised a way of taking customers' coats and hanging them on the coat hangers sequentially. So as new customers come in, you hang their coats on the next available coat hanger, and you give them a ticket that identifies the number of that coat hanger. So as more and more customers come in, you hang the coats on sequentially and give out ticket numbers. Now, once the film is over and the customers come back looking for their coats, as long as they give you their ticket, you'll be able to use it to identify where their coat jacket is. So this is the equivalent of an array, where data gets filled in sequentially, and you can use their position in an array in order to identify the data that's associated. So asking the array for the 0th item gives you this particular coat jacket. Now, the problem arises when your customers are getting a little bit drunk and they've lost their tickets. Now, without that number and a whole bunch of coat jackets that look very similar to each other, you won't be able to easily identify whose coat belongs to whom. So here's a different way of organizing the cloakroom. If instead of hanging the coats up sequentially, you ask each customer for their name, you write down their name on a piece of paper and you tag it onto the coat jacket. Then you can hang their coat onto any of the free coat hangers, and the name label that's stuck to the coat will identify whose coat jacket it is. So even if your customers get a little bit tipsy, hopefully they won't forget their name. And as long as they provide you their name, you'll be able to identify the coat jacket that's associated with it. So this is the equivalent of a dictionary. In this case, the sequence doesn't matter. The name is the key, and the coat is the associated value. So coming back to our param dictionary, you can see that it's created with a data type that has a key made of string and values made of string also. And we have 3 key value pairs that's stored in this dictionary. The first key value pair has a key of lat, and that is associated with the latitude value. And similarly, the key that's called long is associated with the longitude value. So if we have a look at that same dictionary inside a Swift playground, I can show you how easy it is to pull out values from this dictionary. Say if we wanted to grab the latitude data, then all we need to do is to tap into the param dictionary and give it the key that's lat. And you'll be able to see in the Swift playgrounds that it's pulled out the value that's associated with the lat key in our param dictionary. Now, in a dictionary, the order in which your key value pairs go in doesn't matter. So I can put my data right at the end and it still provides the same value. So in a nutshell, that's how dictionaries work. And the way to think about it is that arrays and dictionaries are known as collection types, and they help you to organize data. Now, if you have data that is sequential in nature, for example, dice 1, dice 2, dice 3, dice 4, then you're going to want to organize them in an array. But on the other hand, if you have data that can be identified by a key, then you'll want to put them in a key value pair inside a dictionary. So in the coming lessons and modules, we're going to be using and seeing dictionaries a lot more, and you'll get to play around with them and solidify your understanding. But all you need to remember is that they're just a way of organizing your data into key value pairs. Okay, so we've been talking a lot about using APIs, tapping into APIs, but what exactly are APIs? Well, it's an acronym for Application Program Interfaces, and essentially it's just a contract. And in this contract, there's rules that your app must follow in order to get the data from the website's servers. And these rules are pre-written and specified on the API's documentation. So let's look at APIs in a different light. Let's say that instead of talking about apps and servers, we were talking about a contract between ourselves and our builder. What the API would specify would be the things that you need to provide, maybe bricks or tools or money, so that the builder can deliver you a house. So in our case, using OpenWeatherData's APIs, the things that we need to provide are the latitude, the longitude, and the app ID. And in return, OpenWeatherMap's data servers will give us the weather data that's associated with that location. Now, APIs are not the only way that you can get data from a website. If you didn't have an API, you could tell your program to go onto the website just as you would in a browser and look for specific pieces of data. So for example, you could instruct your program to go onto OpenWeatherMap and have a look at the weather for London, or tell your program to input another city name inside this field and look at the weather data for that particular city. Now the problem here is that if OpenWeatherMap decides to change the appearance of their website, then your program will break. It will not know how to parse or how to interpret the data from that website, and it won't be able to give you the data that you need. But if instead you had your app make a request to the website using the rules of the API, and you pass the website the parameters that are required, such as the latitude or the longitude, then the website can return a response, and that includes data, and in our case would be weather data. So the advantages of using an API is that it's more robust. There's rules that are set out as to how you can interact with the website's servers. For example, they will specify what's the URL or the address of the data, and what are the parameters or the inputs that you need to provide in order to get your response back. It also shows you what is the data structure of the response that you get, so that you can deal with it appropriately and display it in a way that looks nice on your app. So that, in a nutshell, is what APIs are. And being able to tap into APIs will open up a whole new world of possibilities for your apps. And there's all sorts of websites that have publicly available APIs that allow you to tap into things like Bitcoin prices, or the current stock prices, or what is the pollution level in certain areas, etc., etc. It really brings your app to life. All right, so now that we've put together our parameters which we need in order to grab the weather data, namely the latitude and the longitude, as well as our app ID, the next step is to do some networking. So put your business cards down, we're not doing that type of networking. Instead, what we're talking about is a computer network, and we're trying to facilitate the communication between our app and the OpenWeatherMap servers. So in order to do that, we have to perform what's called a HTTP request. So what exactly is that? Well, when your browser tries to fetch something from a website, for example, opening up an image of Cindy Crawford, it's making an HTTP request. It sends the request to the website servers that host that image, and that server responds with a file, which then gets displayed in the browser. Now, browsers are able to manage these requests and responses, as well as a whole bunch of other things, but we're not interested in building a browser. Instead, all we want is just to make a request to the OpenWeatherMap servers and retrieve some weather data. Now, in the beginning of this project, we included a pod that was called AlamoFire. And the reason is because AlamoFire is a library of code that's going to help us with making these HTTP requests and simplifying a lot of the networking calls for us. So we can make a request with only a few lines of code instead of having to worry about, oh, what if the server times out? Or what if there's connection issues? That's all been handled by AlamoFire. So I'm going to show you how easy it is to make a HTTP request. And the first thing that we're going to do is we're going to call a method called getWeatherData. And we're going to pass it two inputs. One is the URL, which comes from OpenWeatherMap, and we've set it as a constant called weather URL. So let's put that in as our first input. And the second input or second parameter is called parameters. And that is going to be set to our params, which we created over here, that contains everything that OpenWeatherMap wants. So you can see that Xcode is complaining here, and it's telling you use of unresolved identifier getWeatherData. And that's because we haven't created this method that we're using here, getWeatherData. So let's go ahead and do that. Now, under the pragma mark that says networking, we're going to write a method called getWeatherData. Now, in order to create a method, of course, you first have to write the func keyword and then give it the name of the method. So getWeatherData. And then our particular method takes two inputs. So that's the URL, which is going to be structured as a string, and also the parameters, which is going to be structured as a dictionary. And we're going to open a curly brace and hit enter to insert the closing curly brace. So this is our method, and you can see that error disappears now because we've got this getWeatherData method and the structure matches our inputs as well. Okay, so the next thing that we need to do is that we need to use AlamoFire. So in order to use any of the pods, remember you have to first import them. So we can import AlamoFire, and while we're here, let's import Swifty.json as well. Now, this is a weird bug that sometimes happens in Xcode, and it's basically telling you that it doesn't know where AlamoFire is. Even though we can see over here in the pods, we've already got AlamoFire incorporated. This is just a simple Xcode bug, and you can usually get rid of it by just hitting Command B to build your project. And once it's built for the first time, Xcode will be able to find where all the pod modules are, and that error will go away. Great, so build succeeded and all the errors are gone. Perfect. So we can now use AlamoFire to make our HTTP request. In order to use AlamoFire, you can go ahead and have a look at their documentation for how it works. So there's a section on what are the features, or what are the requirements, how you install it, etc., etc. And there's also a part on how you use it. So the simplest way of using it is by just making a request. So you're using the request method, saying AlamoFire, make a request to this URL. Now, this doesn't really do very much because you're not dealing with that request. Now, in order to deal with that request, you need to have some sort of response handling, i.e. what do you do with the message that you get back from the server? So in the case of OpenWeatherMap, the response is structured in what's called a JSON or JavaScript object notation. Now, we're going to talk about JSON structuring a little bit later on, but for now, all you need to know is that it's just a commonly accepted way of structuring large pieces of data. So in order to handle that response, the documentation tells us that we can use a callback to handle whatever we get back from the data server. So I'm going to type out how we can use AlamoFire to make our HTTP request and handle the response that we get from the OpenWeatherMap servers. All right, so this is the block of code that's provided by AlamoFire in order to make a GET request. Now, let's go through it in detail and try to understand it. So firstly, we're using the AlamoFire library, and we're using one of its methods called request. Now, that method takes a few inputs or parameters, the first of which is the URL to which we're going to make our request, and that URL comes from the input of getWeatherData, which in turn comes from the weather URL constant that we've got listed up here. Now, the second input we need to give it is what is the method to which we're going to make our HTTP request. And the one we're going to use in this case is what's called a GET request. Now, there's other HTTP methods that you can use. And the method basically dictates what we want to do with the data on the data server. So there's a whole bunch of different HTTP methods that you can read about, and I've included a link to the Wikipedia article where you can have a look at all of these different HTTP methods. But for most case, you're going to be using the GET method, which basically just retrieves data and does nothing else. So we're using the GET method. The final input that we need to provide are the parameters which OpenWeatherMap has specified in their documentation. And these are the inputs that we need to give the OpenWeatherMap data servers in order to retrieve the weather conditions for that geographic location. And if you remember, the parameters came from this dictionary, which was created using the data from the location manager. Now, once we've got all three inputs to our method, and AlamoFire makes a request, once it completes that request with the OpenWeatherMap data servers, then it responds with some data. And then once that response comes back, we want to check if the response result is success or otherwise, i.e. it was a failure. So if it didn't manage to grab the weather data, then we're going to tell the user that there was a problem with their internet connection, which is most likely the case. But if it was successful, then we're going to do something with the data that came back. So this block of code might look a little bit different from what you've seen so far. And the reason for that is because the networking happens in an asynchronous fashion. Now, what that means is just that AlamoFire is trying to communicate with the OpenWeatherMap servers in the background of the app, i.e. it's not holding up any processes that the user can see. It's not freezing up the screen. All it does is that it makes a request in the background, and once it gets a message back from the server, then it comes into action. So the part between response in and the closing brace is what should get triggered once the background process has completed and we get data back from the server. So the first thing we're going to process is what should happen when there's a problem. So in order to check our code, we're going to write a print statement that says there's an error and the problem is this response.result.error. So AlamoFire will give you an error message when it is not able to successfully complete the networking. So we can print that out into the console and we can try and debug what's going on. But for the user, they won't see that. So we're going to update the city label with an error message. And we'll give them something a little bit simpler, just saying connection issues. So most of the time when networking fails, it's probably because there's connection issues, i.e. the user is not connected to the internet or their connection is unstable. So that handles the case where there's a problem with the networking. But what if it was successful? Well, what we want to happen is we also want to print a message into the console saying success, got the weather data. So this way we know that it worked. Now, I know that this is a large block of code, and most of that code comes from the AlamoFire's documentation. In order to understand it fully, we need to understand how asynchronous processes work, as well as how closures work in Swift. And those are some of the things that we're going to cover in a few lessons that's coming up. So don't worry if this looks unfamiliar. All you need to understand at this point is that we're using a few inputs, namely our URL and the parameters that we got from our location manager. And then we will get a response back from the server, and we check to see if that response was successful. But if it was not successful, Then we're going to print the error in the console, and we're also going to tell the user that there were connection issues. So that's all you need to know about that part of the method. In the next lesson, we're going to talk about what JSONs are, why they're useful, and how we can understand them. So there's quite a lot of new information to chew through, but don't worry, we're going to take it one step at a time, and you're going to understand all of this after we use it a few times. Now, this is a good time to discuss what exactly is networking. Networking is essentially the communication between different computers on network. So say if you're trying to access a website, your browser has to network with the data server of the website in order to retrieve the files for display on screen. So say you type in www.google.com, then what actually happens is that your browser makes a request to Google's servers, and in return, those servers gives you back some HTML and CSS files. And your browser then opens and interprets those files, and you see a web page. Now, when you're making networking calls, you have to provide a URL. And you can view the URL as simply as an address in the data server. It tells that data server the location of the files that you want to access. So going back to that example of trying to load up a website on your computer, the first thing that happens is that your computer makes an HTTP request to the website's servers, passing it the URL or the address of the files that it's trying to look for, the files of the website. Once the website server receives that message, then it'll provide a response in the form of those files. Then the browser on your computer will open those files and display your favorite website. So when you're making an HTTP request, there's many methods that you can use. I want to talk about 3 of the most common ones you might see. First is what's known as a GET request. And this is essentially like the cookie monster. It's give me cookies, i.e. fetching data from the web server. The second type is called a POST request. And this is where you pass data to the server and add data into that server. And the final one is a delete request. This is where you make a request to the server in order to delete some data that's in the server. And there's a whole bunch more which you can read up on in the link below this video. Essentially, all that we're doing in our Klima app is we're making a GET request using the API, and we're providing a whole bunch of parameters that are required to get the weather data of the location we want. Now, once OpenWeatherMap's data servers receive the request and finds the data that's associated with those GPS coordinates, then it provides a response in the form of weather data, and it passes that back into our app. So if we have a look back at our code, we're using AlamoFire to make an HTTP request using one of its methods. Now, in order to make that request, we have to specify a couple of things. Firstly, what is the address of the data server that we want to access, i.e. what is the URL? And that comes from OpenWeatherMap's API documentation. The next thing we need to specify is what type of request we want to make. And in this case, it's a GET request. We want to get data from OpenWeatherMap's data servers. And the third thing that we need to provide are the parameters that OpenWeatherMap needs in order to give us the weather data. Now, our parameters are made up of a dictionary of key value pairs containing the latitude, the longitude, and our app ID for using OpenWeatherMap's APIs. Now, once we've got all three things ready, we can make our request. Now, this request happens in the background because it can take some time. Now, instead of clogging up the interface where the user can't do anything during that time, this method is asynchronous, i.e. it happens in the background. But once that request is complete, then it triggers a response. And that response contains data that's held inside this variable called response. So the next part, it's imperative for us to check to see if that response contained a result that was successful, i.e. we were able to get data from the servers, or if it was not successful, in which case we can print out the error that was passed back from the data server. So that, in a nutshell, is how our networking code works behind the scenes. Alright, so we've already talked about the error handling part of our code. So inside this else statement, we deal with what should happen when there's an error in getting the data from OpenWeatherMap. Now, the next part to address is, what if the result of the response is successful? So what do we do then? Well, firstly, we print into the console success, got the weather data, so that when we're testing our app, we know that it succeeded. Well, the next part is formatting the data that we get back from OpenWeatherMap and processing it so that we can display it on screen. So the first step towards doing that is creating a new constant called weather.json that is of data type JSON. Now, JSON stands for JavaScript Object Notation, and even though it says JavaScript in there, it's actually used in many programming languages and many applications, and that's because it's simply a way of formatting large pieces of data that gets passed around on the internet. So I'm going to show you what the JSON format looks like very soon, but let's create our constant first. So weather.json has a data type of JSON, and it's going to be assigned the value that comes from the response. And inside the response, we want to tap into the result, and the result itself has quite a few associated properties, such as is failure, or is success, or error. The one that we want is the actual value of the result. So in essence, when using Alamofire to make a request, we're giving it all of these inputs in order to get back the weather data. And once we've connected with the data servers of OpenWeatherMap and it's processed our request, it sends back a message containing a package called response. And in that package, we're tapping into the value, which should contain the weather data. Now, Xcode is upset here because this value that comes back in the form of an optional. So in order to use it, we first have to force unwrap it using an exclamation mark. Now, it's reasonably safe to use force unwrapping here because we're already checking to make sure that the result is a successful one. And if that result is success, then we can be reasonably assured that that value will definitely not be nil. So it should be okay to force unwrap it. Now, the next problem that Xcode has is that this value has a data type of any, as you can see here. And we're trying to assign it to a constant that needs to be of data type JSON. So in order to do that, we first have to convert it into a JSON. So as you've done many times before, you write JSON, and then you enclose the value inside brackets in order to cast that value into a JSON format. Now, this functionality actually comes from Swifty.json rather than Swift itself. And you'll come to see that it's actually a really neat little package that helps you process these JSON objects very easily, or at least with fewer lines of code than you would need with Swift alone. So now that we've got our weather.json object, let's have a look at what it looks like. Let's go ahead and print it into the console. Then I'll be able to show you exactly what JSONs are and how our weather comes back from the database. So let's go ahead and run the app. Alright, so here's our app in the wild. You can see from the top right corner when the app is tapping into the location data. So there's nothing much to see on the app itself because we haven't written any code to update the user interface yet. But if you have a look in your debug console, you'll see a whole bunch of data. Now, the first thing that you see is the longitude and latitude data. And subsequently, we get the message, success, got the weather data. And that, of course, comes from this line where we print that statement into the console. And that only gets printed when the response result is a successful one. After it prints that, then we cast that value into a JSON object and we print out that JSON data into the console. So if you have a look here, this is the entirety of your data from OpenWeatherMap. Now you might get it printed a couple of times, and that's simply because it takes a little while to stop the location manager. So if you only want to see the data once, then you can actually go ahead and set the location manager's delegate to nil once you decide to stop updating the location. And that basically just removes our current class from receiving messages from the location manager while it's in the process of being stopped. So if you run the app again, you'll see that you only get the longitude and latitude data once, and you also only get the data back from OpenWeatherMap once as well. So it's just a matter of a time delay when you're trying to stop the location manager. So just go ahead and copy the data that you see in your debug console right up to just below your success message, so including the first opening brace. Now, once you've copied that, head over to your browser and go to a website called JSONEditorOnline.org. Now, what you can do here is you can replace the existing JSON in here with your code, and if you hit the right arrow, it'll be able to display all of that data in a more structured and human readable way. But essentially what it's showing is that you've got 12 objects that's enclosed inside the first set of brackets, and of those 12 objects you've got something here called main, which contains 5 objects, including the humidity, the maximum temperature, the minimum temperature, the average temperature, and the pressure. So those are the 5 objects. Then you've got something called name, which is where your location is at, and because we set our location as the Apple headquarters, is telling us that the location corresponds to Cupertino, and that has a city ID of that. And then there's the coordinates. These are the things that we actually passed in. And then under weather, we've got the weather conditions, which all have a code. So that's mist and haze. And then we've got the cloud conditions and a whole bunch of other data that you can get back from OpenWeatherMap. So this is essentially how JSON data is structured. Here you have these key value pairs, which are grouped together into what appears very similar to our dictionaries. And then we have a whole bunch of these dictionaries that are grouped together inside an array. But in order to see the nesting and visualize the data a little bit better, you can use a visualizer like JSON Editor Online, where you can see it in a more human readable format. So for example, you can see that the temperature is inside something called main, which is the first object out of 12 objects in this whole JSON package. So even though this is called JSON, i.e. JavaScript object notation, and this is JavaScript syntax, this is actually a structure commonly used across multiple languages and platforms. So for most public APIs, the data that you'll get back is most likely to be formatted in the JSON format. But all it is at the end of the day is just a whole bunch of keys with their associated values. And all you need to know is what level are they nested at and what is the key that you're looking for. So let's go back to our app and start using some of this data and display it on the screen. So now that we've gotten our data back from OpenWeatherMap, the next thing that we want to do is to pull out the relevant values that we want to display on screen and then populate the labels and the image views. So in order to not mix up the functionality, we want to have a separate method that does that. And the section for that is under JSON parsing. So we're going to write a new method here. So using the funky word, and we're going to call it update weather data. And it's going to take a single input that's of data type JSON. And then we're just going to open and close some curly braces. And we're going to go back over here and pass this weather JSON into this method. So go ahead and delete that print statement. We've already seen what the data looks like. We don't need to have it print out every time our app runs. And instead, we're going to call update weather data, which takes a single input in the format of a JSON, which is what our weather JSON is perfectly suited for. So now we're going to pass this constant that contains all the weather data from OpenWeatherMap into this method called update weather data. And we're going to deal with formatting it over here. So you'll see an error at this point. And the reason for that is because normally we call methods just by calling their name. And Swift is clever enough to search within the file to try and see if it can find that particular method. Now this AlamoFire method contains something called a closure. And a closure is simply a function that's within a function. So it's something that we're going to go into more detail about later on. But essentially, whenever you see a keyword in, then you know that you're inside a closure, i.e. there's more than one function inside this function. So whenever you're inside a closure, it can get a little bit confusing because you've already got a function that's inside a function, then you're trying to call another function or another method, and the compiler can get a little bit confused as to where this function is declared. So the rule is when you're inside a closure, when you see this in keyword, you always have to specify self in front of your method calls. So that tells the compiler to look for this update weather data inside the current class, and sure enough, it'll find it right over here. So that gets rid of that error and passes our weather data inside this parameter JSON. So we can now deal with it over here. Now the first thing that we want to grab out of our weather data is the temperature. And so we're going to create a constant called temp result, and we're going to set it to equal a value inside this JSON. So if we have a look back at this printout, we can see that the temperature is a value that's associated with the key temp, and it's inside a dictionary called main, which is inside this JSON. So in order to navigate to this value here, we have to take this entire JSON, i.e. all of this, and we want to give it the key main so that it'll navigate to this dictionary. And then inside that hierarchy, we want to give it the key temp. So let's pretend to be computer. And essentially what we're doing is we're saying, go and find the entire JSON that contains the weather data, which got passed into this parameter here when we called this method. And that is all of this. Next, go and find the key main and find all of its values. Now inside there, the next stage is to look for a key called temp and then pull out the value, which is 281.29. And so with that simple line of code, temp result is now assigned this value, and we can work with it and display it on screen. So this code is very simple once you understand how we got there. And the simplicity is again afforded by this library, SwiftyJSON. Because if you wanted to do this using just Swift without SwiftyJSON, it can get very wordy and it gets very complex very quickly. So have a look at the documentation for SwiftyJSON if you're interested in how it works. But essentially, I want to show you the process of how we navigated through this entire JSON to get to this value here. Alright, so now that we understand how our weather data is structured and how to pull out the relevant pieces of information from that data, the next step is displaying it on screen. Now, while we can pull out each value and then update each of the labels and image views using those values, it's considered bad practice. A better way of doing this would be to create a data model that will represent our weather data. So it'll contain properties like weather condition or temperature, and then we can use that weather data model to update our app. So this is getting you into the swing of how you should organize data when you're dealing with larger and more complex apps. So the first thing we're going to do is head over to this file called weatherdatamodel.swift, which we've already created for you. So I want you to go ahead and create 4 variables. One that stores the temperature, and it's going to be of data type integer. The next is the weather condition, and the weather condition comes back from OpenWeatherMap as a ID, so it's also going to be an integer. And then we're going to have another variable called city that stores data of type string. And finally, we're going to have one that's called weather icon name, and it's going to be of data type string. So go ahead and create all 4 variables that's going to store those pieces of data. All right, so that's pretty simple. So I'm going to go ahead and create them and just check to make sure that you've got the same variable names. All right, so if you haven't already, go ahead and create these 4 variables. And once you're done with that, head back over to the weather view controller, and we're going to create a new object of the weather data models. So just below where we created the location manager object, we're going to create a weather data model object, and it's going to be created from the weather data model using empty initializers. Now we're going to update that weather data model object. So the first thing we have to do is weather data model, and it's going to be the one with the lowercase w. So the one that's C is the class weather data model, and the one with the V is our object weather data model. So let's put that in there. And then we're going to tap into the temperature property, which remember is data type int, and we're going to set it to equal the temp result. Now, one of the first problems you'll see here is that our temp result at the moment is still in the format of a JSON, but instead we can see that it should really be in the format of a double because it's a number with decimal places. So let's go ahead and convert that into a double by just writing .double, and that changes the JSON into a double. So the next thing is that for the keen-eyed among you, you would have noticed that Cupertino seems to be at a temperature where they're burning in hell. And as we all know, that's not true. They're absolutely fine. This temperature value is expressed in kelvins. So in order to convert something from kelvins to degrees, we have to subtract 273.15. Now, there's a problem here because if you click on this error message, it says that you can't subtract a double with a question mark. Remember, that's an optional, and an actual double. The double with a question mark is actually a different data type from the one without. So let's go ahead and change that by force unwrapping. So we can go ahead and just put an exclamation mark at the end of temp result, and that will unwrap the optional. So these two are now of the same data type and are now comparable. Now, the next problem we have is that this temperature property has a data type of integer because we said that we can't be bothered with the decimal places and we just want a whole number. But these two are both of data type double, i.e. they have a number behind the decimal place. So let's go ahead and convert that into an integer by writing int and putting a bracket around it. So now you can see all the errors go away, and our weather data model now has its temperature property filled in with the actual temperature in Celsius. The next thing that we want to populate is the city property. So let's go into weather data model.city, and we're going to set it to equal this name here, Cupertino. And you can see that Cupertino is listed under the key name, and it's at the same level as main. So let's go ahead and pull that out of our JSON. So similar to this line here, all we need to say is that the city should equal the JSON with the value that's under the key name. And in order to convert this data that's currently still in the JSON format into a string so that it can be stored in our city property, we have to write dot and then we write string value. So that converts that JSON into a string. And the final property that we're going to populate is the weather condition. So that's weather data model.condition. So the weather condition is listed under the key weather. And currently for Cupertino, we're actually getting 2 weather conditions back. And this happens when different areas of the same city have different conditions. So for example, for one part of Cupertino, the weather condition is more accurately classified as mist, whereas for another part, it's probably more like haze. So all we're going to do is just pull out the first weather condition that's available, which is going to be this 701 code. And if you have a look at the APIs for Open Weather Map, you can see a whole bunch of different weather codes and what they translate to in terms of the weather condition. So in order to get to this 701, we have to go into weather, and then we have to go into 0, and then we have to go into the key ID. So let's do that for our app. So it was first going into the JSON, and then it was the key weather, and then it's the object at index 0. So this particular one rather than this one. And then inside there, we're looking for the ID so that we can get this 701 code pulled into our condition property. And this should be an integer value. So we're going to convert it into int value so that we can conform with the data type of this property. Okay, so now that's done, we have a bit of a problem because if you look into our image assets, we've got a whole bunch of different icon images that we want to show on screen, but we have to convert these codes 701 or 721 into an image. And the way that we would do that is to check against these values from Open Weather Map. Now, we considered getting you guys to type all of this out, but we thought it might drive you crazy. So instead, we've typed out all of the different conditions that matches up with the images that we've got. So if you just go ahead and select everything from this line where it says function update weather icon down to just above the last curly brace, and hold down command while you hit the / button, then it will uncomment that entire block of code and put it into active use. Now, let me show you what we've done here. We've created a method called update weather icon that takes an input of an integer, the condition ID, and then it returns, i.e. it outputs a string, which is going to be the name of the image that we want to pull up on screen. So the way that this method works is that it checks the condition code and sees which of these buckets it falls into. So for example, our weather code currently is 701. So this switch statement will check for a 701. Is it between 0 and 300? No. Is it between 301 and 500? No, etc., etc., until it finds a case where it returns true, i.e. 701 is between 701 and 771 inclusive. So then it returns the image that's called fog. So we can go into our image assets and find the image called fog, and this will get displayed on screen. So in order for that method to work, we have to call it. So if you remember, we still have one last property to set, and that is the weather icon name. And we're going to use that method update weather icon that we saw just now. So it was weather data model dot, and at this point you should see the method name that we uncommented over here, update weather icon. But you'll see that if you try to type it now, update weather, it's not suggesting anything for us. And in fact, when you type it all out, it'll actually give you an error saying, I don't know where this is. And the reason for that is because we updated that file very recently. And if you look at the icon here, it's still gray, which means that this change, this uncommenting, hasn't been saved yet. So all you have to do is just hit Command S to turn that icon from gray to white. And now if you go back over here, you can see that once we start typing update weather icon, it now knows about that new method. So the condition or the input that we're going to pass in is going to be the weather data model dot condition. And then this method is going to output the name of the image that we want to display on screen, and it's going to be stored inside this property called weather icon name. So our code is now error-free, and we've created this weather data model object that stores all of the data of the weather data that we get back from Open Weather Map. Now there's just one problem here. So I'm going to simulate what happens when we get back nonsense data. So I know that if I provide the wrong app ID to Open Weather Map or an invalid app ID, then it won't give me the correct weather data. So I'm just going to add 3 zeros at the end of my app ID to turn this valid app ID into something that's nonsense. And we're going to run the app again and see what happens. And our app has now crashed, and it highlights to you the line that crashed it. So the error message here is fatal error. unexpectedly found nil while unwrapping an optional value. So if you've seen the lesson on optionals, you know that it's extremely dangerous to use an exclamation mark on an optional when you don't know for sure that every single case it will return a valid value. So here's the problem. Let's first print out what that weather JSON that we get back from OpenWeatherMap looks like. So you can see that the success message gets triggered because indeed the response is successful, i.e. there's not a problem with the connection. So we were successful networking with the OpenWeatherMap servers, and it does in fact give us a response. But that is the problem. The data that it gives back is not what we expect it to. Instead, it's an error, and it has an error code and an error message, and it says invalid API key. So we do indeed get data back from the OpenWeatherMap servers, structured in a JSON format, but there is no name and there is no weather ID. So that means this value is currently nil, and if we try to force unwrap it from an optional when it's nil, then we'll crash our app. So let's go back and just fix our API so that we get actual data back from OpenWeatherMap. And the next thing we're going to do is we're going to make this code a lot safer. So if you remember, instead of force unwrapping an optional, the safer way to do it was to use optional binding. So we're binding this new constant temp result to the value that we get back from the JSON. Now, if that JSON indeed does have a value and it's not nil, then we're going to proceed to do the rest of our code. And in this case, we don't need to force unwrap that temp result anymore because we now check to make sure that it does indeed contain a value. So in this case, even if we messed up our app ID and we got this erroneous data back from OpenWeatherMap, then all of this will simply be skipped and it won't be executed and our app won't crash, but it also won't do anything and the user won't know what's going on. So let's put an else statement in there that tells the user what's happening. So in this case, if we don't see a main and a temp in our JSON, which we know we always get back from OpenWeatherMap as long as we gave it all the right values, then we skip this block entirely and we go over to the else statement. And in the else statement, we're going to tell the user that there was a problem with getting the weather data. So we're going to set the city labels text property to weather unavailable. And that's essentially the error. We couldn't get the weather from OpenWeatherMap. So now the user will know what's happening, we won't crash our app, and our code is a lot safer and a lot more robust. So now all that's left to do is to update the user interface. So we can head over to the UI update section and we can create a method called update UI with weather data. And it's not going to take any inputs because we don't need to pass it data. All we need is to tap into this weather data model object that contains a whole bunch of populated properties. So the part of the user interface we want to update is the city label, which is going to be set to weather data models city property. And then the temperature label is going to be set to equal the temperature property of weather data model. Now remember with labels, they're always expecting a string. So you can go ahead and cast this integer value into a string by writing string and enclosing the value inside the brackets. Or you can use the escaping the string method, which we mentioned earlier on, which is where you use a backslash and quotation marks around the object to turn it into a string. So either way is fine, it doesn't really matter as long as you change that integer into a string so that it can be displayed in the temperature label. And the final thing we want to show on screen is we want to change the weather icon image view's image property to a UI image that is named according to the weather data model's weather icon name property. So now we've got a method that updates the user interface with the city name, with the temperature, and also the weather icon, it's important to remember that this method won't do anything until you call it somewhere. So the ideal place to call it is after we've set all of these weather properties. So let's go ahead and call that method over here. So let's run our app and see if that worked. So now we've got our temperature displayed on screen, the weather icon that represents the current condition, and the city name all showing up on screen. So great, you've completed the first part of the Klima app. All right, so I want to take a moment just to explain what segues are and how we can use them. So segues are one of the most powerful things in the interface builder, and they allow us to link view controllers with other view controllers or elements within a view controller, such as a button within another view controller. So they help us with navigating, essentially. And as you can see, in order to get from the first weather view controller to the change city view controller, we've linked up this little segue here. And when you click on the segue, it turns blue and it highlights where its origin is. So in this case, it's this particular button. And we've linked up that segue so that when you click on this button, it'll automatically navigate and take you to the Change City view controller, which is this screen here. Now we've done all of that for you in the skeleton project. So let's have a look how segues are created from scratch and how we can use them to pass data and navigate between different view controllers. So in this case, I'm going to set up a new single view application project. I'm just going to call it Segues and save it on my desktop. Now you can either follow along with me by watching the video, or you can do it while I'm doing it. So at the moment we have a single view application, so there's only one view controller. Now if our app got slightly bigger or more complicated and we wanted another view controller, then we can easily drag one from the object library here. So now that we've dragged on this view controller, you can see that the first warning you get is that this view controller is unreachable because it has no entry points and no identifiers. So what Xcode is trying to tell you is that there is no way of getting to this view controller because you haven't set up any portals of getting there. So let's go ahead and do that. Let's say that in our first view controller, if we click on a button, then it should take us to the second view controller. So in order to do that, we would need to set up a segue. And setting up a segue is easy as pie. All you have to do is click on the button, hold down the control key, and click and drag and point the arrow towards where you want to link up your segue to. So the beginning, the origin, is this button, and the end is this second view controller. So I'm going to let go, and you can see that you get a bunch of options for what kind of segues you want. Now, show is the simplest type of segue, and it's got a very simple transition where the second screen just slides onto the first screen. So it doesn't really matter which one you choose at this stage because you can change it quite easily in the options later on. So I'm just going to go ahead and hit show, and you can see after I do that, the first thing that happens is that Xcode has drawn this little arrow here that links the first view controller with the second view controller. Now that looks a little bit similar to this, doesn't it? And that's because we've just created our first segue. So now if I run my app and I click on this button, it'll take me onto the second view controller. Now let's just give these view controllers some random colors so that we can actually see what's happening when we run the app. So let's give it a go. When we press the button on the first view controller, it takes us onto the second view controller. Now, one thing to remember at this point is that we've got this viewcontroller.swift file, which we know to be linked to this first view controller. Because if you have a look under the identity inspector, you can see that it's got a class that is the view controller, and that of course refers to this file. So when you click on the assistant editor, you can see that the automatically associated file with this particular screen is the viewcontroller.swift code file. But unfortunately, our second view controller currently is not associated with any class at all, and hence you get something completely different, when you look at what it's linked to automatically in the assistant editor. So let's go ahead and create a code file so that we can link it up with this second view controller so that we can command what should happen inside this screen. So as always, to create a new view controller, you just hit Command N to bring up this dialog, and under iOS, you go to the Cocoa Touch class, hit Next, And we're going to call ours second view controller so that it doesn't clash with the previous name, which is view controller. And it is a subclass, i.e. it inherits from the UI view controller. Leave the language as Swift and then go ahead and click Next. Save it inside your project file and voila, we've got a second code file. Now at the moment, just because we created that code file, it's still not yet linked to this particular view controller. So in order to do that, we have to go into the identity inspector and change the class to second view controller. So now automatically, whenever you click on this screen in the assistant editor, you'll get the code file second view controller.swift. So let's return to the single screen editor. So this current segue that we've set up is associated with the button so that whenever you click the button, it'll take you to the destination of the segue, which is indicated by the arrow. Now, another way of setting up segues is if we go ahead and just delete that by hitting backspace, is if you click on this little yellow symbol that indicates the view controller and you hold down Control and you click and drag, you can also set up a segue this way. So now this segue links the first view controller with the second view controller. Now, your question might be, well, how do I trigger it when I press the button? Well, in order to trigger the segue, you have to give it an identifier. So if you go into the attributes inspector with your segue selected, you can set an identifier for this segue, and we'll call it go to second screen. And I'm going to select it and copy it because we're going to use it in our code, and the exact spelling and casing matters a huge deal. So now that we've got that segue name, we're going to use it by triggering it when the button is pressed. So as per usual, we can link up the button to an IB action, and we can call that IB action button pressed. So pretty simple. Now, whenever that button gets pressed, what we want to happen is to trigger the segue. So all we have to say is perform segue with identifier. So here is where we put the input of the identifier name. So I copied it earlier on and I'm just going to paste it in there. It was called go to second screen. And you can reconfirm by just selecting that segue again, and you can see its identifier, go to second screen. And the sender in this case will be who started, who initiated the segue, which in this case will be this first view controller. And given that we're inside the first view controller's class file, then we can just write self. So now if you have a look at our code, what it says is that when the button is pressed, then we should perform the segue called go to second screen. So this one, and the sender should be self. Now, the reason why we need identifiers for segues is that you can actually initiate multiple segues from a single view controller. So if we had another view controller up here and we had a button 2 and we wanted it such that when you press button 2, you go to another screen, then we can trigger the other segue. So the identifier is really important. And because this is a string, you have to make sure that you spell it and have the casing completely identical to how you named it in the attributes inspector. So let's go ahead and test it out. Okay, so in this case, what we're expecting is exactly the same as our previous scenario. When we click on the button, it should take us to the second screen, and it works as predicted. So those are two ways that you can set up segues, either originating from the view controller or originating as the button. So great, that's pretty neat. But the next thing that we want to do is we want to be able to pass data from the first view controller to the second view controller. What the user does in the first screen will usually determine what gets shown on the second screen. So passing data forwards is a very, very common need. So let's make this very simple. What we're going to do is we're going to put a text field inside the first view controller so that when I type something in here, I want that text to get passed into the second view controller. And I'm going to display that text using a label in this view controller. So here's my label, here's my text field, and I have the button that's going to start off the sending of the message. So let's go ahead and link everything up to some IB outlets. So the text field will be linked to the view controller.swift file, and I'm just going to call it text field. And then the label will get linked in the second view controller, and similarly I will just call it label. Okay, so that was easy enough. Now it's time to write some code. So let's go ahead and go into the viewcontroller.swift file. So let's go ahead and go into the viewcontroller.swift file. So every UI view controller has a method called prepare for segue. And what prepare for segue does is it performs the actions that should happen just before you embark on the segue, or just before you're transitioning from the first view controller to the second view controller. So in order to tap into it, we of course have to override it. So we override the original method, prepare for segue. And remember, in any given view controller, you can have more than one segue. So we first have to check to see if the segue's identifier is equal to the route that we're going to take. So this is like your route 66, to make sure that we're talking about the right path or the right portal, i.e. going from view controller to the second view controller. But if the segue identifier is indeed equal to go to second screen, then under those conditions, we want to pass the text that was entered into the text field over to the second view controller. Now, how can we do that? The easiest way of doing this is by creating a property in the second view controller called, let's call it text passed over. And we can set it to an optional string. And then if we go back over here, if we can grab a reference to that second view controller, then we can set its property. So to grab hold of the reference to the second view controller that'll get created after the segue finishes, there's a very easy way of doing that. So let's create a constant called let destination view controller equal segue dot destination. So before we typed destination, it tells you what the type of it is, and it is a UI view controller. So we know that the destination of this segue, go to second screen, is of type second view controller. So if we tell the compiler that the segue destination is going to be a second view controller, then that will allow us to tap into the properties that are declared inside the second view controller, namely this one, text passed over. So if we write destination view controller dot text passed over, then we can set it to equal the text field's text property. So let's just go over those last two lines. We're creating a constant that's going to hold a reference to the destination of this segue, or destination of this route. And then we cast that UI view controller explicitly as a second view controller. So we tell the compiler what type of view controller that the destination will be. And after doing that, we're able to tap into the properties in the destination view controller, and we're able to set the text field. So now all we have to do is to go into the second view controller, and upon view loading, i.e. inside view did load, we can set label's text property to equal the text passed over. So if we run our app and everything goes well, then we should be able to send some data from our first view controller to our second view controller using the power of segues. All right, so let's type in something in here like hello and hit the button to initiate the segue. And there we go. Our data was sent through the segue and then displayed in that label. So that was a brief introduction to segues and segue associated methods to transport data along the path of the segue. So in this module and in the coming modules, we will be using segues a lot more as we're building apps now that have more than one screen. And we're going to be passing data from view controller to view controller. And you'll see this prepare for segue as well as perform for segue. And you're going to get used to using it. So let's get back to our Klima app. So if everything is going well, you should now have an app that tells you the current weather data for your current location. So if you ran this app on your iPhone, it will tell you your actual live weather data for wherever you are. Alternatively, you can change the debug location to a custom location by entering a latitude and longitude for where you are if you're working with just the simulator. Now that's great, but what if we wanted to find out the weather in a location where we're currently not at? Well, this is where our second view controller comes in. So we've linked up this button here to go to another view controller. And here we have a text field where we can enter a city name like Rio, and we can press the Get Weather button to get the weather for that current location. Now, at the moment, it doesn't do anything yet. And if we have a look at our code, you can see that there's really not much code in this Change City View controller yet. All it has is a IB outlet that's linked up to the Change City text field, which is this one, and it's called Change City text field. And then there's an IB action that's linked up to the Get Weather Pressed button. Finally, there's a back button that basically just gets rid of that view controller and goes back to the previous one. So there's nothing there yet, and we have to go and give it some functionality. So let's think about the problem here. Essentially, we want to go into a completely different view controller, i.e. the Change City view controller. We want to type in some data, and we want that data to get passed back to the weather view controller once we hit that Get Weather button. So essentially, our problem is that we need to pass data between two completely different view controllers. So in order to do this, we need to learn about something called delegates and protocols. Now, delegates and protocols are definitely an intermediate to high-level topic in Swift programming, and we're going to take it slowly. I'm going to show you the step-by-step process of how we set it up first, and then we're going to explain in detail exactly how it works. So if you think about it, you've actually already used delegates and protocols. When we created a location manager from the CL Location Manager class, which is something that Apple wrote in their core location framework, which we imported here, we had to declare our weather view controller as the delegate of the location manager. So essentially, the weather view controller is declared as the one that's responsible for messages that you get back from the location manager. Now, core location is not open source, so we can't see the actual code that Apple wrote in order for us to handle location data. But what it does tell us in the documentation is that once the location manager finds a location, it looks for its delegate, i.e. it looks for the one who it should report to. And it would send messages about the location data that it got. And that's essentially what we're doing inside the weather view controller. We're setting the weather view controller as the delegate of the location manager. And then we have these methods that handle what we should do when we get messages back from the location manager. Namely, what should we do if we get the iPhone's location, and what should we do if there was an error in getting the location. So we've been using one side of the code, but the other side of the code is hidden inside this core location, which we can't look at. But this time we're going to create our own protocols and our own delegates, so we get to see both sides of the coin and see how it's created from scratch, how we set up listeners for messages being passed between different classes or different view controllers. So step one is we're going to head into Change City View Controller. So at the top of the file, i.e. outside this Change City View Controller class, we're going to create our protocol. So in order to create a protocol, we first write the keyword protocol, and we're going to call our protocol Change City Delegate. And it's going to contain a single method called user entered a new city name, and it's going to take an input in the form of the city name, which will be a string, and our plan is to trigger a message containing whatever the user typed into this text field back to the weather view controller. Essentially, you can see a protocol as just a contract, and what we've done just now is we've drawn up the contract. We're saying that if you want to be the delegate, you have to be able to implement this method, user entered a new city name, i.e. you have to be able to handle what should happen when you get sent a message that contains the city name that the user typed in to the Change City View Controller. So now that we've drawn up our contract, we have to declare a new property inside our change city view controller, that's going to be the delegate. So we're going to declare a new property. So we're going to use the var keyword, and it's going to be called delegate. Now, you of course don't have to call it delegate, but it's the accepted convention. And it's going to be of data type change city delegate, and it's going to be an optional. So the role of the delegate can be filled, i.e. there's a view controller that declares itself as the delegate, or it can be unfilled, in which case the value of this property delegate will be nil. So now that we've created this delegate property, we're going to go back into the weather view controller, and we're going to say that our weather view controller is going to abide by that contract. So we first declare at the end of the class declaration that we are going to conform to the change city delegate. So as soon as we've declared that, we get an error. And the error message tells you that the weather view controller does not conform to the protocol change city delegate. Now, why is that? If we have a look inside our change city delegate protocol, it has a single required function, i.e. in order to take up this contract, the only requirement is that you must have this method within the body of your class, and we completely ignored it. So that's why Xcode is angry. And in fact, if you click on this error and you have a look over in the left-hand pane and you expand the error, it actually tells you that the protocol requires a function called user entered a new city name. And that is the reason why the weather view controller does not conform to the change city delegate protocol. So the protocol is like a job contract. It's like a contract for a builder to build a house. And in order to take up that contract, you have to have certain qualifications, i.e. you can lay bricks. So the contract specifies a method that has to exist in the class that's going to conform to this change city delegate protocol. So let's go ahead and do that. Let's declare our delegate method over here. So we're going to use the func keyword, and then we're going to type out the required method, which is user entered a new city name. And inside the brackets, we're going to figure out what we're going to do with that city name that we get passed. So for now, all we want to do is just print it out into the console. Let's just print out city and see what we get passed back as the message. Now, just by saying that we're qualified to be the change city delegate, that's not enough. We also have to set ourselves as the delegate, just as we have done here with the location manager. So the next thing I'm going to do is I'm going to override a function called prepare for segue. And this is something that gets triggered when we segue from the first view controller to the second view controller. It's essentially this little arrow here. And it's linked up to this button so that when you press on this button, you get taken to this view controller. And segues are a really useful tool because you can name them, so you can give them an identifier, and we've called ours change city name in this particular, and notice the capitalization. So if you go ahead and copy that, what we can do inside weather view controller is that we can say if the segue's identifier is equal to this change city name, in that case, we want to set destination view controller as the destination of the segue. So basically, we know that that segue links the weather view controller to the change city view controller. And we're saying, let's give an identifier to that destination view controller. Now, at this stage, Xcode doesn't know what type is the destination going to be. Now we know that the destination is going to be a change city view controller. So we can write segue.destination as change city view controller. And this basically just tells Xcode that the data type of the segue destination is going to be a change city view controller. And what this allows us to do is we can now set the destination view controller's delegate property. Remember that one that we created earlier on? And we can set it to self, i.e. this current view controller or the weather view controller. Now, the last step of setting up delegates and protocols is to go back to that change city view controller. And we're going to call that delegate method user entered a new city name when the user presses the Get Weather button. And we're going to pass in what is contained in the text field at that moment so that we can send a message containing the city that the user typed into the text field back over to the Weather View Controller. So the first thing that we're going to do is we're going to get the city name that the user entered into the text field. So remember, there's a change city text field here, and we want to grab what the user typed in there. So we're just going to write let city name equal change city text field dot text and exclamation mark. Next, we're going to say that if we have a delegate that's set, i.e. it's not nil as it is currently, then in that case, we're going to call the delegate method user entered a new city name. So in order to do this, we're going to say delegate question mark, i.e. if the delegate is not nil, then you're going to call the user entered a new city name method, and you're going to pass the message of this city name. So essentially what's contained inside the change city text field. And finally, once that's done, we're going to dismiss this view controller and head back over to the original weather view controller. So the code for that is self, so current view controller, dismiss, animated, yeah, go ahead, why not animate it? Completion, i.e. what should it do after it's completed? Nil, nothing, don't worry about it. What is this question mark doing here? We've not seen this pattern used before. And this is something called optional chaining. So essentially what it's doing is checking to see if this optional, remember we declared it without a value here, it checks with that question mark to see if that delegate contains a value or if it is nil. If it contains a value, then you should go ahead and execute this function. If it does not contain a value, then ignore this entirely. So it's an alternative to optional binding, essentially. All right, so there's only one thing to do. Let's run the app, see if it works. So let's go over to our Change City View controller, and we're going to type in a name. I always use Rio because it's only 3 letters. And then we're going to press the Get Weather button and see what gets printed. Great. So we get Rio printed in the console. And remember, the only way that Rio can get printed is if this delegate function got triggered. And remember, this function is in our first view controller, so the weather view controller. So that must mean that the data was successfully passed back from the change city view controller via our delegate method. Now, very often when you're creating your own apps, you will find yourself needing to pass data between view controllers, forwards and back. Now, because creating delegates and protocols requires quite a few steps, I want to take you through the entire process of sending data forwards and sending data backwards using a simplified app so that we can focus on the code. So here I've got a new project. Now you can set it up the way that I have to follow along, or you can just watch me do it. So I've got 2 view controllers, a first view controller and a second view controller. They both have a display label and they both have a text field. And finally, there's a button. So the idea here is that we first land on the first view controller and we type a little bit of data into this text box and we hit the button to send it over to the second view controller. And once we've landed on that second view controller, then the label will display whatever it is that we typed into the text box. And so that is passing data forwards. To pass data backwards, we're going to type into the text field on the second view controller and hit the pass it back button in order to get it displayed on this label when we dismiss the second view controller. So if you remember from our lesson on segues, view controllers are stacked one on top of the other. So when you go from the first view controller to the second view controller, all you're doing is putting the second view controller on top of the previous one. And you can dismiss the ones on top in order to go backwards in navigation. So the 2 view controllers are linked by a segue called send data forwards. And I've also linked up a bunch of outlets and actions. So the label is linked to an IB outlet called label, text field is linked to text field, and this button is linked to send button pressed. And similarly, the second view controller is also linked up, so I can access the label, the text field, and also write some code when the button gets pressed. So let's address the first task, which is sending data from the first view controller forwards to the second view controller. And as we said previously, sending data forwards is incredibly easy. All we have to do is to go into the first view controller.swift file, and we can use the prepare for segue function, and we can check if segue.identifier. So remember, whenever you create a segue, always you have to give it an identifier, and that identifier lies in the attributes inspector when you've selected the segue. So it's called send data forwards. I'm just going to copy it so I don't make any typos, and I'm going to put it here. So if the segue, or if the route is the one where we go from first view controller to second view controller, which we called send data forwards, then in that case, we want to tap into the destination of that segue. Now, the destination of that segue is a second view controller object, but it's not the same as if we created a new second view controller object. So say if we said let second VC equals second view controller create, this second VC is not going to be the same as the second view controller object which we land on from the segue. So if we want to tap into the object which we land on, then we can't create a brand new object from the second view controller class. Instead, we have to use segue.destination. And we have to tell Xcode that this is going to be a second view controller object. So now we have this second VC, which we can use. So next we go into the second view controller and we create a new property, so a new variable, and let's call it data. And that's the data that's going to be passed over, which we're going to start out as an empty string. And if we head back to the first view controller, then we can tap into that property and set it over here. So we can write second VC, which is the object that we're going to land on, dot data is equal to whatever the user typed in the text field. So text field dot text. And we're going to unwrap that optional there to say that text field dot text will always contain a value, even if it's going to be just an empty string, i.e. if they left the text field empty. So next we can go into the second view controller, and upon view did load, we want to set the labels text property to equal whatever is inside data. And the last thing we need to do is we need to head back over to the first view controller, and upon the send button being pressed, we want to trigger that segue, which is perform segue function, and it's going to be the one called send data forwards, and the sender, of course, is self, the origin of the segue. So now let's go ahead and run our app and see if we can send data forwards. Okay, so here's our first view controller, and inside the text field, I'm just going to write hello. And once I click the send button, then it should send that data to the second view controller and get displayed on screen. So here goes. There we go. And that gets shown up here. So that was pretty successful, and it wasn't so hard to do either. It only took a few lines of code, and we used the prepare for segue method, which gets triggered just before the segue gets performed. And at that point, and we check to make sure that it's the right segue, because remember, you can have multiple segues originating from the same view controller. So you check that it's the one that goes from first view controller to the second view controller, which is called send data forwards. And if so, we create a reference to the destination, and then we set its data property as whatever was entered in the text field. Now, you might imagine that you can do the same thing in reverse, and it would be equally simple to send the data from the second view controller back to the first view controller. So let's try and do exactly the same thing and see what happens, because experimentation is the best teacher, and I'll show you why this doesn't work. So let's just go ahead and create a segue from the second one to the first one, and we'll call that segue send data back. I'm just going to copy it. And then we can go into the second view controller and we can write override function prepare for segue if segue.identifier is equal to send data back, then in that case we want to create a reference to the first view controller, and it's going to be equal to the segue's destination, and it's going to be a first view controller object. Okay, so now inside this first view controller we'll create a property, a variable called data passed back, and it's going to be initially set to an empty string. And then over here we're going to set the first VC's data passed back property to whatever was typed into the text field. So text field dot text. And I'm going to go into the first view controller, and upon view did load, we're going to set the label's text property to equal the data passed back property. And finally, we're going to trigger the perform segue with this send data back segue, and the sender is of course self. So let's see if that works. Okay, so let's write something like hello and hit the button, and that gets sent, so data being sent forwards, and that gets displayed on the second view controller's label. Now let's send some data back. Let's write bye, and then if we hit pass it back, you'll see it displayed on the label. Now this is falsely assuring, because you think, oh, so it works, it's fine then, that's how you pass data forwards and backwards. Now the problem will become apparent if I add in another button. So if on the first view controller I insert a little blue button, and I'm going to link it up to my first view controller class. Don't know why it's gone off the automatic. So let's link that IB action up here, and let's call that button change to blue. And what's going to happen is that when this button gets pressed, I want to change the background color of the view to a UI color that is blue. So now whenever I tap on this button, the whole screen changes to blue. And let's go ahead and run the app, and I'll show you why I just did that. So testing our app as we did before, we're going to pass over some data. Let's try Scotty. So data being passed forwards, and then we're going to pass some data back, and we're going to hit pass it back. Now you can see it seems like our data is being passed forwards and back without any issue. Now here's the problem. If I hit this button and change the screen to blue, and then I pass some data forwards, then that still works. But here's the catch. When I want to pass some data backwards, if I hit pass it back, you'll notice that the first view controller is no longer blue. And the reason for that is because this is no longer the same view controller object. In fact, we've created new copies of each view controller as we're passing data forwards and backwards. So by passing data this way, essentially what we're doing is we're passing data forwards by creating a new object, let's call it B1. And then from B, when we're sending data to A, we're actually creating a new version of the A object. Let's call it A1. Then from A1, we're sending data to a new version of B. And then from B2, we send it to another different version of A, and so on and so forth. So essentially, in memory, we've now got a whole bunch of view controllers that keep getting stacked one on top of each other. And we're not actually ever truly sending data backwards. We're just creating new objects each time and sending data forwards each time. So essentially, this method doesn't work. So let's get rid of some of that code that we wrote, and let's use a different way of passing data backwards. So in the second view controller, I'm going to delete this perform segue, and I'm also going to delete this prepare for segue. And I'm going to go into the storyboard and get rid of that backwards segue. So we still have the code that enables us to pass data forwards, but we've gotten rid of all the code that supposedly passed data back when in fact it was just creating new objects. So how do we pass data back? Well, we use delegates and protocols. The first step in passing data back is creating a protocol in the second view controller. So protocols are actually at the same hierarchical level as classes. I could, in fact, create the protocol in a completely different file, but for ease of use and simplicity, I'm simply going to write it in the second view controller.swift file, although it is not inside the curly braces of the second view controller class. It's in fact separate. So we're going to use the protocol keyword, and we're going to call this protocol can receive. Okay, and this protocol is going to have a single required method, and that method is going to be called data received. And it's going to have a single input or single parameter, which is going to be called data. And let's say that it's a string type data. Okay, so that's our protocol created. And just like a basketball coach, the protocol itself doesn't know how to implement any of these functions. It doesn't know how to dunk a basketball. It doesn't know how to dribble. It merely sets out the rules of engagement. So the next step is to go into our first view controller and conform to that protocol. So after where we inherit from UI view controller, we're going to declare the protocols that our class conforms to. And that protocol was called can receive. And you'll notice that the class inheritance is highlighted in a different color from the class protocol, from the protocol adoption. This one's sort of light green and that one is purple. Now, once we've added that line to the class declaration, we get this error. And the error says that the can receive protocol has a required function called data received. i.e., if you're going to be the delegate, then you have to be able to handle the data. So let's put that function somewhere. So it's called data received. And this method will get triggered once that data gets sent back. And so when it does get triggered, we want to display the data inside the label of the first view controller. So label.text equals the data that is received. So step 1, create the protocol. Step 2, conform to the protocol in the class that is going to be the delegate. Step 3, implement the required delegate method, i.e. deal with that data once it gets sent. And the third step is to create a new property called delegate inside the view controller that will do the delegating, i.e. the one that is going to send the data, which in our case is the second view controller. So the type of the delegate is in fact the protocol name, so can receive. and it's going to have a question mark because that delegate might be nil, i.e. if there wasn't somebody who stepped up and said that they were going to be the delegate, then this property is not going to be set. It's going to be empty. So the point at which we want to send the data is once the user presses the button, i.e. the send data back button. So here we're going to write delegate dot data received. So we're going to trigger that method data received, and the data that we're going to send is whatever the user has put into the text field at this point. Text field.text. Final bit of code that we need to write is that we need to set ourselves as the delegate of the second view controller. So remember, this is the object that gets created when we initiate that segue, and the second VC is the destination of the segue, i.e. it's a second view controller object where we type in the data to be sent back. So second VC dot delegate equals self equals the first view controller. So let's just review those few steps. Step 1 was create the protocol that has a name and also has a required method. Next, in the view controller that's receiving the data, we conformed to that protocol at the class declaration line, and we also implemented the required delegate method, which is called data received, and we do something with the data that is received. The next step is we created this property called delegate that is of type can receive, and that delegate is an optional, so it might be nil. Now, if it is nil, then this line is not triggered, i.e. the data isn't sent anywhere. But if the role of the delegate is filled, i.e. somebody has set themselves as the delegate, then we trigger this method called data received, and we send this data that's currently inputted in the text field to whoever the delegate is via this method, data received. And the last step was to set the second view controller's delegate as this current view controller. So to say that the first view controller is going to be the one that's going to receive the data, and you can delegate that data to the first view controller. The final line of code that we need to add is to dismiss the second view controller so that we can go back to the view controller that's underneath, namely the first view controller. So to do that, all we need to do is write dismiss, and we're going to do it in an animated fashion, and upon completion we don't want anything to happen, so nil. So let's go ahead and run our app and see if it works. So first things first, I'm going to set the first view controller, so this particular instance of the first view controller, to a blue background so that we know when we come back whether if we've just created a new version of the first view controller or if indeed we are actually on the original first view controller object. So passing data forwards should be pretty straightforward, and we've already seen that it works, so that input gets displayed on the label. Now here's the tense part. Let's see if this data that we type into the view controller, when I click on this pass it back button, when we trigger this send data back IB action, whether if we can send the data back to the original instance of the first view controller. So when I hit this button, what should happen is that we will check to see if in the cases where that delegate is not nil, then we're going to trigger this method called data received, passing in whatever was typed in the text field. And then that will trigger the delegate of the second view controller, i.e. the first view controller, and trigger this method, data received, passing in that data input, and then it will get displayed on the label. And finally, we dismiss the second view controller and we go back to the previous instance of the first view controller. So I've typed a little bit of data into the text field, and I'm going to hit pass it back, and there we go. That data got passed back into the same instance of the first view controller as we started out with. So there you have it. That's how you pass data forwards and backwards between view controllers using delegates and protocols. Okay, so before I start explaining delegates and protocols, the first thing to say is that you may need to watch this video a couple of times before everything sinks in. You might even need to try it out a few times and write the code out, because it is an advanced topic and it can take a little while to sink in and make sense. But so far, you've implemented delegates and protocols in two ways. In the first case, you used the location manager's delegation pattern in order to receive the location data from the core location framework. And in the second case, we actually created our own protocols that allowed us to transfer data between the Change City view controller and the weather view controller. And then we showed you how to pass data forwards and backwards between view controllers and why it's necessary to use delegates and protocols to pass data backwards rather than going via segues. So in this episode, I'm just going to consolidate a lot of that knowledge that we've already approached. It's just to help it all glue together and sink in. Firstly, I want to talk about the code that we wrote in Klima in order to get the city name that the user typed into the Change City view controller back into our weather view controller, where we've got all the code for networking and JSON parsing and getting the weather data from OpenWeatherMap. So when the user clicks on the switch button in the weather view controller, it of course takes them via a segue to the Change City view controller. And it's here where our delegates and protocols story starts. So the first thing that we did was to create a protocol called Change City Delegate. And inside this protocol, we defined a required method. And the method only has a name and the input parameters. Notice that the function doesn't have any open or closing curly braces that follow it because it has no body. We're not writing out what this method does at this stage. All that we're saying is that this protocol, Change City Delegate, in order to conform to it, you must implement this method with this name, taking in these inputs. And this is pretty similar to a job contract, if you will. And in creating the delegate protocol, we're essentially creating a contract that states you must be able to use Photoshop. For example, if this was a designer contract. Or you must be able to implement user entered a new city name. So we created a delegate protocol, we specified a required function for that protocol. And in the next stage, we added the Change City Delegate protocol to the end of the class declaration in the weather view controller. So to make things slightly clearer, the code that goes in the weather view controller will be represented on white slides, and the code that goes into the Change City view controller will be on black slides. That way you know where the code is going, because we're writing code in both view controllers, both classes that affect each other. So in the weather view controller, we've conformed to the Change City Delegate protocol. And we do that by adding it behind the inheritance. So if you notice, the inheritance, i.e. the weather view controller, inherits from Apple's UI view controller, being able to do everything that a UI view controller can do. And then we add a comma and we add the protocols that we want to adopt. So it's like saying that weather view controller is going to take up that contract. And at this stage, if you remember, this is the point where Xcode starts screaming and telling you that you've got an error. And that's because we haven't implemented the required delegate methods. So it's like if you were a designer and you decided to take up the contract, you have to show on your CV that you can use Photoshop because that was one of the requirements of the job contract. So similarly, Xcode tells us that the weather view controller does not conform to the protocol Change City Delegate, and that's because when we created the Change City Delegate protocol, we specified a required function or required method called user entered a new city name, taking in an input called city. And Xcode is looking for that required method inside your weather view controller. So you have to add this method in the weather view controller class in order for this error to go away and in order for you to legally adopt that change city delegate protocol. So this method will enable you to deal with the message that gets sent from the change city view controller, because when the user types in a new city name, then it sends out a message to be received using this user enter the new city name, and that city name gets passed in over here as a parameter, which then you can use inside the body of this method to go and get the weather data. So the next step is going back to the change city view controller and creating a delegate property. So we use the var keyword to create a variable called delegate that is of the data type of the protocol change city delegate. And this is set as an optional, noted by the question mark, i.e. it can be nil or it can be set to something. So then naturally, if we want our weather view controller to be the delegate, i.e. to receive the messages from the change city view controller, then we have to go back into weather view controller and set ourselves, i.e. the weather view controller, as the delegate of the change city view controller. So this destination VC is a change city view controller object that gets created at the end of the segue. So by initiating the segue, we're creating an object of change city view controller. So essentially, when we're going from the sender to the destination via our segue, a new copy of the change city view controller gets created. And the change city view controller is the one that's going to be sending the message containing the text that the user entered. And the weather view controller is set as the delegate to receive that message. Now, finally, the last step is calling the delegate method. So when the user types in a city name and hits that get weather button, we want to pass this string, London, into the delegate method and send it to the weather view controller. So the time point where we do this is when the user taps on the get weather button. And that, of course, triggers the IB action get weather pressed. And then inside the curly braces of that IB action is where we're going to initiate the data sending. So first, we create a constant called city name that stores whatever the user typed into the change city text field. So i.e. in this case, it's London. And then we check to see if there is a delegate that's set. If the delegate's nil, then this line simply gets ignored. But if the delegate is set, and in our case it's set as the weather view controller, then we're going to call this delegate method, the method that exists in the delegate called user entered a new city name, passing in this city name constant, which is what the user wrote. And finally, we're going to dismiss this view controller, the change city view controller, and head back over to the weather view controller, having passed the data over. So essentially, if the city name was London, then the word London gets put as the input to the delegate method user enter the new city name, and that delegate method gets called, and that input gets sent over to the weather view controller as an input. And so now that we have the data inside the weather view controller, we can use that city name to create a parameter that we can send to Open Weather Maps servers and get the weather data for that city name. So essentially, passing data forwards is incredibly easy because you can use segues. And when the segue gets triggered, a new object of the destination view controller gets created. But if we want to pass data backwards from that new object back to the one that created it, then we have to do it via a delegate. And in order to do this, we create a protocol. So essentially, you can view the receiver class, the sender class, and the protocol as three separate things. They can exist in three separate files. In our case, the sender is the change city view controller, where the city name gets entered. The receiver is the weather view controller, which is going to use that city name to get the weather data. And the protocol, even though we created it inside the change city view controller, it's actually separate to that class, and it can exist in its own file. So if you view the whole process as having three components, sender, receiver, and protocol, then this is the process by which we pass data using delegation. So first things first, we create a protocol with required methods. These are the delegate methods that any class, if it wishes to adopt the protocol, needs to contain. So if the receiver class, in our case it's the weather view controller, decides to adopt this protocol, then it has to contain the required methods in its class body, which is user entered a new city name in our case. And the required methods are actually called a delegate method because it's the method that exists in the delegate that's going to get triggered by the sender. So if we go back to the sender side, our change city view controller, we created a new property called delegate, and it's created as an optional, so it can be nil or it can contain a value. If the delegate is nil, then the delegate method will never get triggered by the sender. But in our case, we set the delegate inside the receiver class, inside the weather view controller class. And we did that by grabbing a reference to the sender class and setting its delegate property to self, namely the receiver class. So now the receiver is putting its hands up and saying, I will be the delegate of the sender. So whenever the sender decides to send a message, I will be there to catch it. So now in the sender class, the delegate property is now equal to the receiver and it is no longer nil. So now when you call upon the delegate method, and we do that when the get weather button gets pressed, and the delegate method first checks to see if the delegate is nil or not. If it is nil, then nothing happens. But if it is not nil, i.e. it contains a value, then we trigger the delegate method and we can pass our data from the sender class as an input into the delegate method, and that gets sent over via the delegate method in the receiver class. So now, through that convoluted process, we've managed to get our data sent backwards from the sender class to the receiver class. Now, one of the biggest reasons why we use the delegation pattern is because it allows us to reuse components that are created by Apple, like the core location manager, or components that we create ourselves. So here's an example. We know that we can pass data forwards by creating an object. So in this case, A creates B, and so A knows all about B's properties and methods. It knows the things that it can change, so it can pass data forwards by changing one of those properties or calling one of its methods. But if subsequently we wanted to pass data back, i.e. from B to A, then the B class would need to know the properties and the methods that exist in the A class. And this gets a little bit complicated when you add a few more players into the game. If we wanted to reuse this component B, then we want to be able to allow A to create B1 and another class, for example, a C class, to also create an object B. Of course, there'll be different versions of the object B, but they would be the same component. So now, if you want to pass data back from B to A, as well as from B to C, then the B class would have to know about the properties and the methods in the A class, as well as the properties and methods in the C class. Now, if all three components, A, B, and C, were all created by ourselves, then this is potentially feasible, although it's not advisable, because your B class will get very, very bloated. But if the B class was actually created by a third party, say Apple, then there's no way for them to know about our custom classes A and C. Then there's no way for B to know about the properties and the methods that are available in A and C in order to set them to pass data this way. And that is why delegates are essential in this case. So a real life example of that is the Tetris app. So if I go into the Tetris app and they now have all these different types of gameplays: Marathon, Galaxy, Explorers. And say if you decided to go to the Marathon mode and you start playing Tetris, and you decide that you want to change the volume of the music that's being played. So you tap the Change Music button, and it takes you to a new view controller. That's the Change Music view controller. Now here you can set the music volume, you can set the FSX, you can set the song that you want to play, and then you can click Select, which dismisses this new view controller, and it sends that data back to the game view controller, changing the music that gets played there. So this is an example of sending data backwards. Now, what if we go back to the main menu and we decide to play a different type of Tetris? We decide to go into the Galaxy mode. So this is a completely different view controller. This is the Galaxy gaming view controller, for example. But there's also music playing in the background, and we also want to be able to change the music. So by tapping on the Change Music button, we are presented with exactly the same view controller that we saw earlier on, the component that gets reused by both the Galaxy mode game controller as well as the Marathon mode game controller. So by using the delegation pattern, we're able to reuse this music view controller, and it can pass data, namely the music volume, to its delegate, no matter who it is. It doesn't know anything about the delegate class. All it knows is that the delegate has to have a delegate method called music volume setting. And all it needs to do is send the data to that delegate. And if it happens to be the Galaxy game view controller that set itself as the delegate, then that's the one that's going to receive the data. But if it so happens that the Marathon game view controller was set as the delegate, then that will be the one that's going to receive the music data. So remember, the number one rule of programming is that programmers are lazy, and we will find every single opportunity where we can avoid writing duplicate code. And this is one of those cases. By using delegates and protocols, we're able to reuse large components like view controllers or classes like the location manager, and we can use them in many places without having to rewrite it. So that's a little bit on delegates and protocols. And again, you might find yourself watching this video a couple of times in order to fully understand what it's all about. But essentially, just follow the steps that it takes to implement the protocols and delegates, and over time of repeated use, you'll come to understand how it works. All right, so now we're in a position where we're able to send the user to another view controller, namely Change City View Controller, let them enter something into the text field, and use our delegate method to pass that city name back to the weather view controller, which is the delegate who receives that message. And currently we're only just printing out what that message says, which is just the city that the user typed in. But what we actually want is to send that city name to Open Weather Maps servers and get the weather data for that city name. So the workflow is the same as when we use the location data to get the weather. All we need to do is to network with Open Weather Maps servers using Alamo Fire. And then we can use SwiftlyJSON to pass the result that we get back from those servers, and then we can update the UI accordingly. So inside that delegate method, user entered a new city name. Let's get rid of that print statement, and instead let's create a dictionary that contains all the parameters that we will send to Open Weather Map, including that city name. So I'm going to create a new constant called params, and it's going to be of type dictionary with a string as the key and strings as the value. And I'm going to set it to contain only 2 key value pairs. And the first one, the key, is going to be called Q, and it's going to be set to the value of our city, so the city name that we get passed back. And the second key value pair is going to be the app ID. So the key is app ID, and the value is that constant app ID that we've got up here. So how do I know that the key for the city name should be Q? Where do I get that from? I didn't pull it out of thin air. Instead, I got it from the API documentation of the Open Weather Map. So you can see that if you wanted to get the weather data by city name, then your parameters are Q, which is the city name. So for example, it would be Q equals London or Q equals London in the UK. So that's how I know to use Q as the key. So the last step is just to call our method getWeatherData and trigger this waterfall sequence of networking with the OpenWeatherMap servers, sending it the parameters that we created, and then getting a response back and checking to see if we have any errors. Or if we get a response back, then we're going to go to this method called updateWeatherData, passing in the data that we got back from the data servers. And then updateWeatherData is going to disentangle that JSON and format it in a way that we can call update UI with weather data, and then finally update UI with weather data just updates the user interface with the data and changes the appearance of our app. So after we've created those parameters, let's go ahead and call getWeatherData, passing in the URL, which is that constant weather URL that we've got up here. And it's the same if you want to get weather using the location data or using the city name. And then the parameters are going to be this new params constant that we created. So fingers crossed, let's go ahead and run our app and see if everything works as expected. So let's go and change our location and go to the change city view controller. And let's see what the weather's like in Rio right now. Let's go ahead and hit get weather. Rio looks great, 14 degrees with sun. Now, what about Alaska? Okay, Alaska's not so great, -21 with clouds. Now, if it bothers you that the temperature label doesn't actually have a degree symbol at the end of it, then you can simply just go into your update UI with weather data method, and at the end of this string, you can simply insert a degree symbol by holding down Control, Command, and the spacebar on your keyboard. That's usually the shortcut for bringing up the emoji inspector. And now if you run your app again, you'll see that the temperature label now includes a degree symbol. So remember when we did the temperature conversion, we converted the temperature we got back from OpenWeatherMap, which is in the form of kelvins, to Celsius by subtracting 273.15. Now, if you're keen on extending this project, you can challenge yourself to add a toggle that toggles between Fahrenheit and Celsius so that the temperature makes sense to the users in the US. So the toggles in iOS are known as a UI switch, and you can simply drag it on and have a look in the documentation to see how to use it. It's pretty simple and a very doable challenge. So there you go. You've now got an app that allows you to magically summon the weather at the touch of a button. So of course, if you want to take this app a little bit further, it's not so hard to do so. Have a look at what other APIs you have access to at OpenWeatherMap. Maybe you want to get the 5-day forecast. Maybe you want to grab the UV index. Maybe you want to display air pollution. Have a look at what else is available and go ahead and modify your app to make it do whatever it is that you want. You can now use APIs and command weather data using the power of code. All right, guys, it's time to take our app development skills to the next level. So in this module, we're going to introduce you to the wonderful world of CocoaPods and open source libraries. So essentially, you can view these as little discrete packages of code that another helpful programmer has produced, which we can incorporate into our own project so that we can cut down our development time, sometimes by months. Additionally, we're going to learn about how we can use APIs or application program interfaces to grab data from websites so that we can create our very own weather app. Now, if you've ever dreamed of having your very own weather app, then this is the module that will make it a reality. So let's have a look at what this app can do. All right, so here's our Klima app. And on launch, you first get the location-based weather screen. So this is grabbing my current GPS data and then sending that latitude and longitude data to the OpenWeatherMap servers to grab the weather data for my current location. So the two pieces of information that I'm displaying in the app is the current temperature as well as the current weather condition. Now, if we click on this switch button here, we can go to another screen. So this will be the first time that we're making an app with more than one screen. And we're going to talk about how to do that as well as some of the intricacies of multiple screen layouts. In this new view controller, I can put in a city name. So let's see what it's like in Rio right now. And I can click Get Weather to grab the weather data for that particular location. So if you ever needed to find out what the weather is like somewhere else, then this will be the app for you. All right, so as always, we're going to get you guys to download the project stub, which we've already set up with the designs and the layout, as well as all of the image assets that you'll require for this project. So if you just go to github.com/LondonAppBreeze/Klima, then you will find the iOS project here. So you've done this plenty of times. Go ahead and download the zip file or git clone to your desktop. Okay, so now that we've downloaded our Klima-master to our downloads folder and we've extracted it, the next step is that I'm going to drag this Klima master folder onto my desktop. Now, this step is really important. In the last few projects, we merely suggested where to put it, but in this case, we're going to work with our directories quite a bit, and it's essential for everything to work that you have your app in the same directory as I am, because I'm going to run through installing CocoaPods on a particular directory, and it'll just make your life so much easier if your Klima master folder is also in your desktop. After you've completed this project, after you've completed the module, you can put this folder anywhere you like into your projects folder or whatever, but just for now, put it into desktop. Okay, so now that we've got this folder inside desktop, we're going to double click on it and open up the klima.xcode project. And we're going to click open. Okay, so here is our brand new Klima project. The first thing I want to show you is the main storyboard, so that we can have a look at the design of our multi-page app. So previously in all of the projects we've done so far, we've only had a single view controller. It's always been a single page app. Now this is the first time that we've got more than one view controllers. And certainly in the future, when you're making your own apps, you're probably going to need more than one view controller. So to create a new view controller, it's actually pretty simple. All you have to do is go into the object library, as always, and the first thing it suggests before you start typing anything else is a view controller. So all you have to do is just drag it onto the screen, and there you have a brand new view controller. And in the next module, when we're building our messaging app, we're going to talk about how you navigate between these view controllers and how you can create segues that link up these different screens. But for now, all we need to do is just delete this view controller by hitting backspace. And all we need are these two pre-built view controllers. So all I've done for these view controllers is that I've set up the auto layout and constraints for these UI elements so that they'll look good on whatever size screen you have. Now we have a big label here that is going to display the temperature, and it's linked up to an IB outlet called temperature label. And then we've got another label here, which is linked to something called city label. This is going to show what is your current location. And finally, we've got a UI image view that's linked up to something called weather icon. And it's going to show the icon of the current weather condition. And finally, we've got this button here that's not actually linked up to an IB action. Instead, it's linked to a segue, and this particular segue. And that segue just takes the user that presses this button to the next view controller. So that's all that button does. When you click on it, it triggers this segue called change city name. And then it takes it over to the Change City View Controller. Now on the Change City View Controller, it's even simpler. We've got a text field that is linked up to an IB outlet called Change City Text Field. And this is where we're going to put in the city whose weather that we want. And we've got this button, which is called Get Weather. Now, one design flaw of this button you might pick up on is that it doesn't look particularly like a button. If you've seen some of the app design modules, you see us stressing how important it is to make sure that your user knows what they can interact with. So feel free to go ahead and change that button to however you want it to look. But this is simply designed with the flat design concept where everything has minimal edges, minimal contrast. But just be aware that this is in fact a button, and it's linked up to an IB action called Get Weather Pressed. And finally, we have this back button that is linked to an IB action called back button. And in there, we've pre-written a little bit of code that basically just dismisses this view controller and takes the user back to this weather view controller. So all in all, the design and layouts are pretty simple, and I'm going to talk about them again when we work with them in the coming lessons. So the other thing to note is that you have this image set. In your assets folder, you have the app icons already set up. You have background images that I've put in there, as well as a bunch of weather icons that we're going to use to display the weather conditions. So all of that's all set up and ready to go, so you don't have to worry about it at all. And feel free to run the app as it is and see how the navigation between the screens work. All right, so this is the part where things start to get exciting. So we're going to install something called CocoaPods onto your Mac. And CocoaPods is what's known as a dependency manager for Xcode projects. Now, what that basically means is that it has a whole bunch of libraries, so collections of code that other programmers have written, which they've made open source, i.e. you can see the code base, and you can incorporate those libraries of code into your own projects in order to achieve specific ends. So if you have a look at cocoapods.org, where you can find out a little bit more about what it is and what it does, as well as this brilliant search interface. So searching for CocoaPods is a little bit like window shopping. You know, you can have a look at all the beautiful things or all the useful things that you can incorporate into your future projects. And I like to keep a little stash of the names of the pods that might come in handy in future. So say, for example, you wanted to make a progress bar, but you can't be bothered to spend, a week creating it by yourself. So what you can do is you can head over here and have a look at what progress bars there are on CocoaPods. So let's have a look at this one, YL progress bar. Ooh, okay, some of these look very nice. That one looks a bit like the Facebook progress bar under the navigation bar, and some of these others look a little bit more fancy. What about a circular progress bar? So that's very Apple Watch style. Maybe I might use that on an Apple Watch project. Or what about circle progress bar? That's very flat design, looks beautiful, right? So essentially you can just window shop through all the available code bases. And in the coming lessons, I'm going to show you how we can easily incorporate any of these libraries into our own code and use it to save ourselves loads and loads of time. All right, so in order to set up CocoaPods for the first time, you're going to have to open up something called Terminal. Now, the easiest way of finding Terminal is going to Spotlight, which you can access via this little magnifying glass icon. Inside Spotlight, we're going to type Terminal, and there you go, it's already shown up, and then we're going to hit Enter to open up Terminal. Now, if you have deep-seated fantasies of looking like a hacker when you're working in Starbucks, then you can change your terminal appearance to look like mine. So if you want to do that, you can go to Terminal, Preferences, and then it's under Profiles, and I've got Homebrew set as default, but some of these other ones look quite nice as well. Or you can stick with the basic black on white, but this particular color scheme helps me work at night. It's less straining to my eyes, but this is all aesthetics, and when you want to prank people in Starbucks and pretend like you're hacking into the NSA to the guy next to you. But all in all, Terminal is actually a very benign program. All it does is that it allows you to access what's called the command line. And from here, you can navigate through your file directories in your computer, you can run programs, you can download things from the internet, and it basically just gives you a lot more control over your computer. So let's get started installing CocoaPods. Now, the first thing we're going to do is we're going to have a look at this line that's in the terminal. Now, the most important thing here is that $sign. And that $sign is called a prompt. So what that means is that only once you see the $sign is the terminal ready to receive inputs. When you don't see that sign and when you don't see that flashing cursor, it means that it's probably doing something. and if you try to type anything into it, it won't be ready to receive those commands. But in this case, we see our username, then we see the $, and we see a flashing cursor. So it's ready to receive any new commands. And the command that we're going to write is called sudo, which stands for super user do. So that's basically using admin privileges. And this step does require you to have admin control of your laptop because you need to install CocoaPods. Now, the next thing we're going to write is gem. So CocoaPod is actually what's known as a Ruby gem. So if you've ever used Ruby on Rails, then you'll be very familiar with gems, and CocoaPods is one such gem. If you've never heard about what gems are, it doesn't matter. It's just a way for us to install CocoaPods onto our system in a pain-free and easy way. So next we're going to type the keyword install, and then it's going to be CocoaPods. Remember that CocoaPods is spelt with a, not CocoaPods, but instead it's CocoaPods. And now I'm going to hit enter, and it's going to request you type in your password, which unlike most graphical user interfaces will not show up. So if you type something wrong, then it will tell you sorry, try again. And if it was correct, you'll get a whole bunch of things happening on screen. And it's installing all the things that are required for your CocoaPods to work. So if you've ever watched a hacker movie or a movie about hackers that's made by Hollywood, you always see like reams and reams of text, like green on black text that scrolls down the screen. Now in reality, when we're staring at these lines scroll past, we're just looking at it, waiting for it to finish. Okay, so once the process is done, we will once again get your username plus the prompt plus our flashing cursor. Now sometimes in different color schemes for the terminal, you don't get the flashing cursor, but as long as you see the prompt, then this means that your gems have been installed and you can proceed to the next step. Now the next step, we're going to write pod setup to set up our CocoaPods, and then I'm going to add 2 dashes and the word verbose in order to see step by step what's happening, because Terminal's very good at doing things behind the scenes and not bothering you with it. But in this case, I want to see that it's doing something. Now remember, depending on your internet connection and depending on how old your laptop is, each of these steps can take a while. So just remember, you're looking out for your username and the $ as the prompt. And when you're looking at something like this, it means it's doing something behind the scenes. It's not yet done, and just be patient. And it can take 5 to 10 minutes for setup to complete. So don't be in a rush and just let it do its thing. So once everything's completed, at the bottom of your terminal, you'll see setup completed, and you'll see your prompt showing again. So that means we've installed CocoaPods and we've set it up on our system ready to go. Okay, so now that we've got CocoaPods installed and set up on our system, you won't have to do that again. So in the future, when you're using CocoaPods or when you're installing new pods, you don't have to go through the CocoaPod setup. All you have to do is incorporate new CocoaPods, and we're going to show you how to do that in the next lesson. Now, depending on your Mac OS version, you might come into problems when you're trying to set up CocoaPods. And one of the known problems is something to do with a gem called active support. So if you get an error saying Ruby version 2.2.2 required, then have a look at the text below this video where we've got a fix that you can implement. Now, if you've got setup completed and everything went smoothly, then you can continue to the next step. If you don't see this setup completed, then have a look in the text below this video, and you can use some of those fixes to get everything up and running. Okay, so now that we've successfully installed and set up CocoaPods on our system, the next step is to put some pods into our Xcode project. Now, the first thing we're going to do is to close down the Xcode application and any projects associated, because CocoaPods will be making changes to it in the background. Now, the next thing you're going to do is you're going to go into your desktop and just remind yourself of what that folder was called. So in this case, because we downloaded the zip file from GitHub and then we extracted it, the folder name is called Cleamer-master. Now, if you use git clone to get it onto your desktop, it'll likely be called just Cleamer. So have a look at what your project folder is called and make a mental note of that. Because the next thing that we're going to do is go back into Terminal and we're going to navigate inside this directory. Now, how are we going to do that? Well, we're going to use a keyword called cd or change directory. We're going to give terminal a file path to navigate to. Now, bear with me here. This is super simple, but if you're doing it for the first time, it can seem a little bit confusing. So currently we're inside what's called the root directory. And in most cases, that means you're inside your Macintosh HD, you're inside users, and you're inside your current username. So for me, it's A1 on this laptop, and we are inside this folder right here when it shows this little squiggly line. Now from here, I can change directory into any of these folders. So if I just write CD desktop, that's the equivalent of going from here and clicking here. So let's go and hit enter. So now you'll see that instead of the squiggly line, you get desktop. So that means that I'm now inside my desktop directory. So I'm right here, basically. Now from here, you can use a keyword called ls to list all the directories that are available inside this folder. So as you can see inside Finder, you've got two folders. One's called Klima-Master, one's called Music. You can also see that inside Terminal. So next I want to CD or change directory into Klima-Master. And now, as you can see, I am inside my Klima-Master folder. So I am now here. And this is the place that you want to be when you want to install CocoaPods onto your Xcode project. You're basically at the same hierarchical level as your Klima.xcode project. So when you're here, we're going to use a keyword called pod. So pod for CocoaPods, init. So initialize CocoaPods and hit enter. And once that's done, if you have a look in your Finder, you'll see a new file called pod file that's just been created for you. So now that I've created a new pod file, I'm going to edit it. Now, it's very important how you edit this pod file, because while I can double click on it here, and on most Macs, the default text editor is text edit, and the formatting of text edit by default, again, is rich text. Now, rich text allows you to format things in a pretty way, basically. And when you write quotation marks inside text edit in a rich text format, what you get is something that looks like this when you magnify it. So the open quotes and the closing quotes are actually different symbols, and it can make it look very pretty when you write a quote in the middle of it. But the problem is that this is not the symbol that we use to program in. Instead, these are the quotation marks that programming softwares recognize. So in order to make sure that we write our quotation marks in the correct format, we're going to use Xcode to edit this text file rather than using the default that's text edit. Okay, so instead of opening this file inside text edit, we're going to instruct terminal to open up this file inside Xcode. So in order to do that, we're going to write open, which is the keyword. Then we're going to use -a, which is the application that we want to use. And we're going to use Xcode. Now remember, Xcode is spelt with a capital X and everything else is lowercase. And then we're going to open the pod file. And then if you hit enter, you'll see that terminal has opened up the pod file inside Xcode, and it's opened up as just a standalone piece of text. All right, so let's guide you through this pod file. So one of the first things you might notice is that the programming syntax looks a little bit different from what we're used to in Swift. And that's because this is a completely different programming language. Because CocoaPods are Ruby gems, that means that pod files are written in Ruby code. But it doesn't matter if you've never seen a line of Ruby code, because all we need to do in this pod file are a few very simple things. So the first thing that I want to say is that in Swift, we use the // to represent a new comment. In Ruby, they use the £, which looks like this. So in order to uncomment the next line as they've instructed us, all you need to do is just delete the £. So now this is no longer a comment, and this is an active line of code. Now, unfortunately, Xcode doesn't have great code highlighting for Ruby code, like the way that it does for Swift, where normally comments are shown in green, and then when they're code, they're shown in different colors. But just follow along with me, and I'll show you the parts which you need to edit in future projects. So the next thing to remember is that in Swift, we have the open and closing braces that define a code block. so everything within here is a code block. But in Ruby, what they have instead is the do and end keywords. So the do is the equivalent of your opening brace, and the end is the equivalent of your closing brace. And everything in between is basically your code block. Okay, so the next thing that we're going to do is we're going to add our CocoaPods under this comment where it says the pods that we will use for Klima. And the pods that we're going to incorporate into this particular project are going to be SwiftlyJSON, SV Progress HUD, and something called AlamoFire. I'm going to talk through each of those libraries in detail when we're using them. But for now, all we need to do is write pod, and then we're going to use a single quotation mark and enclose inside the quotation mark SwiftlyJSON, and then close it with another single quotation mark. Now, the upper and lower casing of the names of these pods are really important. So make sure that you're typing out your pod names exactly the same way as I am. So now I'm going to add just a few more. So AlamoFire, and then pod SV Progress HUD. Okay, so now we've got all three pods listed out. And if you want to find out a little bit more about each of these pods, you can just type out their name into the cocoapods.org search bar, and you can read up on what each of these do and what they look like, and you can even have a look at the original source code on GitHub if you're interested. Okay, so the next step, I'm going to go back into our terminal. Now, if you've closed down terminal, don't worry. You can just cd or change directory into the Klima master directory. And you remember how we did that, right? We basically navigated from the user A1 to desktop, and then on desktop, you should have your Klima master folder. So just check this part below your username and the $sign to make sure that you are indeed within the Klima master directory. Okay, so now we're going to proceed to the next step, and there is a caveat here, because depending on your current version of CocoaPods, we might do something slightly different. So what you're going to do is you're going to write pod -- version to check your current version of CocoaPods, and then the terminal is going to print it out here. So currently the version I've got is CocoaPods 1.1.1, which is currently the latest version of CocoaPods. Okay, so now the important part is that if you have CocoaPods version 1.1.0 or above, i.e. 1.1.1, 1.1.2, 1.2. Whatever, etc., right? You get the point. So basically any version that's higher than 1.1.0, then you're good to go. You can ignore the next step. But if your version of CocoaPods is 1.1.0 or below, so i.e. if you have something like 1.0.1, then you're going to have to add a little bit of a fix to your code. So for those of you guys who have a lower version, i.e. if you have 1.0 point something, then what you're going to do is go into your browser, and what you're going to do is you're going to go into browser and you're going to go back to that repository, which is github.com/londonappery/klima. And here, if you scroll down in the README, you'll see a section called Fix for CocoaPods version 1.0.1 and below. And you're going to select all of these lines of code, and you're going to copy it and go back into your pod file, and you're going to paste it below the last end. So right here. Now, once that's done, you can go ahead and hit save, and you can follow along with everybody else on the rest of the tutorial. Now, for those of you guys who have version 1.1.1 or above, you don't need this, and instead all you need to do is just hit save in Xcode and quit Xcode. And we're going to head back into the terminal. Now, if you close the terminal, don't worry. Just use the same method that we showed earlier on, using the change directory keyword to go into your desktop and then go into your Klima master folder. Just make sure that this part before your username and the prompt reads Klima master, so that you are indeed within the Klima master folder, i.e. over here, in the same hierarchy as where your pod file exists. So the next command you're going to type into your terminal is pod install, and that will install the 3 CocoaPods that we specified earlier in our pod file. Now, If everything goes well, then you will get a successful message and everything will be green. If something goes wrong, the terminal will give you an error code that's in red. And in this case, it's telling me that it's unable to find a specification for Swift JSON. And that's because that CocoaPod is not called Swift JSON. It's actually called Swifty JSON. So if you have a look on the CocoaPods file, you can see what is the name that you should be using, which in this case is a capital S Swifty JSON, capital JSON. So that means that I made a typo in my pod file. So what I have to do is open up my pod file again. So open -a Xcode pod file and hit enter. And we're going to open that file again inside Xcode, and we're going to change this pod file, which instead of being Swift JSON should be Swifty JSON. So hit save, close down Xcode, and we're going to run that pod install command again. Now, instead of typing it all out, all you have to do is hit the up symbol on your keyboard, and that goes through the previous lines that you've typed. So this is the one we want, and then we're going to hit enter, and it's going to install those pods and dependencies. So as you can see, it's installing Alamofire, installing SV Progress HUD, installing Swifty JSON, and at the end, it'll give you a successful message saying that pod installation complete and 3 in total were installed. So that's great. So that means we're all set with our CocoaPods. And in the future, when you want to install new CocoaPods, then all you have to do is just to follow the steps detailed in this video. So starting with going into the project file where you have your Xcode project, then using pod init to initialize a new pod file, opening the pod file in Xcode, and then adding in those pod names that you found from CocoaPods or you found from GitHub. So the name is this part before the version, and then you write pod install, and then you're done. So for those of you guys who've never worked with terminal, that can seem a little bit cumbersome, but just remember that each of these libraries will get updated regularly because there'll be a new version of Xcode or there'll be a new version of Swift, and in order for your code to not break, you'll need to keep updating these libraries. And with CocoaPods, it's as simple as just typing pod install or pod update, and that will update all of your dependencies, all of your CocoaPods in your project without you having to download it and drag it into your project and rebuild, hoping that everything's going to work. This is way, way simpler. Trust me, I've been there before, and this is a much better way of doing this. So finally, we're done with all our setup and we're ready to start writing some code. Now, when you open your Klima master folder, you will now see a new file that's been created for you. And it's this one called klima.exe workspace. Now, if I just enlarge these symbols a little bit, you'll see that this one has a white icon and this one has a blue icon. Now, up till now, we've always been working in our Xcode project file. But once you have pods installed, then you've got to use this klima.exe workspace because this is the file that contains all of your CocoaPods. So go ahead and double click on that one to open it up, and we're going to be working in there from now on. Okay, so once the project finishes indexing, you might see an error already on startup. So if you click on the error, it'll tell you what the warning is about, and it says update to recommended settings. So when there are discrepancies between the current version of Xcode that you've got open and the version of Xcode that was used to create the stub project or the skeleton project, it might give you this little warning. All you have to do is just click on it and hit perform changes, and you'll make that warning go away. So once you've done that, you're going to head over to the project navigator, and you can see that we've got 2 projects here. You're going to expand the Klima project and expand the Klima folder. Now you can see that our files have been organized into the familiar model view controller organizational structure. And if you expand each of these 3 folders, you can see all of our files that make up our Klima app. So the first thing that we're going to do is we're going to head over to the weatherviewcontroller.swift file, and I'm just going to show you briefly what's already in here. So at the top, we've got 2 constants that we've pre-written for you. And what this is the weather URL, which is the website which we're going to obtain our weather data from, and it's going to be from a service called openweathermap.org. And then there's something called an app ID. And this is our own app ID, which we've set up in order to use the Open Weather Map API. Now, the reason why you need an app ID is because these guys at Open Weather Map need to keep track of who is requesting what type of data and how to deliver you that information. So if we head over to openweathermap.org, in our browser, you can have a look at the conditions for using their API. So they have a whole bunch of different APIs, for example, current weather data or a 5-day forecast, weather stations, air pollution, and a whole bunch of interesting things. So you can tap into all of this data, and we're going to show you how to do that for one of their APIs, which is the current weather data. So in order to use this in your own app, all you have to do is head over to openweathermap.org/API, and you can sign up and register to get your own API key. Next, you can see that we've added in a bunch of to-dos, and those are the things that we'll be doing in this module in order to make our app work. And the other thing that we've added is a bunch of pragma marks. And what these marks allow you to do is that they can separate your code into discrete sections. So you have all of your networking code in one section, or all of your parsing code in another section. And that allows you to navigate and have a look at an overview of your long code file without having to scroll through it and troll through it manually. So this file is split into a few sections. The first section is called networking, and this is the part that's going to make the HTTP request for the data from OpenWeatherMap. Next, we have a section called JSON parsing, and this is the part where we're going to write the code that parses the response that we get from OpenWeatherMap into something that we can display in our app. The next section is UI updates, so the code that's going to update our weather condition images or what's going to be displayed in the labels. And this part is the location manager, which is the part of the code that's going to grab our current location and tell us what is the latitude and longitude of our iPhone. And finally, we're going to have a little bit of code that handles how we can change from one view controller to the other and how we can pass data back and forth between these two view controllers. So without further ado, let's get started by writing some code that taps into the GPS and grabs our location data. So the first thing that we need to do is to import the core location library. And this is a module that Apple has written that allows us to tap into the GPS functionality of the iPhone. Now you can have a look at this framework by holding down the Option key or the Alt key on your keyboard and then hovering over core location and hitting the question mark. And then if you click on the framework references, you can read all about core location, what it enables you to do, and what are the classes and methods that it contains. So heading back into our Xcode project, the next thing that we're going to do is we're going to declare that our weather view controller, so this current view controller, conforms to the CL or core location manager delegate. So this is a protocol for how we will handle location data. So go ahead and hit enter so that gets inserted in here. And remember, it has to come after a comma from the UI view controller. So now if we look at this line, what it's saying is that our class, the weather view controller, is a subclass of the UI view controller, and it conforms to the rules of the core location manager delegate. So the next step is going over to just under this to do where it says declare instance variables, and we're going to create a new location manager object. Now, if you've watched the last module, you'll be familiar with how we create objects from classes. So we first use the let keyword, and we're going to call our new object location manager, and this is named using camel casing, and it's going to be created from the CL core location manager class. And it's going to be initialized with no parameters. So if any of that seemed foreign to you, have a look back at the last module where we spoke in detail about objects and classes and how we can create objects from these blueprints. So once we've done that, the next step is setting up our location manager. So we're going to head into our viewDidLoad method. So when we say inside, of course, we mean inside the curly braces. And just below this to do, we're going to set up our location manager. So to do that, we're going to refer to the location manager that we created up here. So our object called location manager. We're going to use the dot notation to access the delegate property of the location manager. And we're going to set that to equal self, i.e. our current class, which is the weather view controller. So we're introducing a new concept here, which is the delegate. Now, if we had an abundance of time, say if we had a year to kill, we could go about coding up our own methods and classes as to how we can fetch the GPS location from the phone. Now, that would involve triangulating the GPS location from cell towers. Alternatively, when the cell location is weak, we can look at using Wi-Fi to try to figure out the GPS coordinates of the phone. Now, because we don't have 6 months to spare, and even if we did, we don't want to reinvent the wheel, that's why we're using Apple's code, namely the core location library. Now, inside that library, there's a whole bunch of code with various classes and methods that help us do everything that's location related. And the component inside core location that helps us with getting the GPS coordinates is something called a location manager. Now, in order to use that location manager and all of its capabilities, we, i.e. our own class, the weather view controller, has to become a delegate of the location manager. Now, what that means is just that we're putting our hands up and we're volunteering to be the one that deals with the location data once the location manager has found it. So in order to become the delegate of the location manager, we first have to say that we are suitably qualified. So to do that, we first conformed to the CL location manager delegate. And then later on, inside view.did_load, we set ourselves, i.e. the weather view controller, as the delegate of the location manager. So delegates and protocols is an intermediate programming concept in Swift, and it's something that we're going to explore in more detail later on in this module. But for now, all we need to know is that we're setting the weather view controller as the delegate of the location manager, and that's so that this location manager, which Apple coded up, can deal with all the location related functionality. And we're setting ourselves up as the delegate so that the location manager knows who to report to once it's found the location data that we're looking for. Next, we're going to set another property of the location manager, which is the desired accuracy property. And this sets the accuracy of the location data. And there's a whole range of different accuracies that you can get back. Now, if you start writing KCL location accuracy, you can see all the different options. So there's accuracy best, which is the highest level of accuracy, to the nearest kilometer, to the nearest 100 meters, nearest 3 kilometers, nearest 10 meters, and best for navigation. So the thing to note is that the more accurate you want your location data, the longer it's going to take, and hence the more battery it's going to drain. So when you're picking your location accuracy, have a think about what your app does and the degree of location accuracy you need. So for example, if you're doing turn-by-turn navigations in your app, then you're going to need something like best for navigation. So that's basically to the nearest 5 or so meters. And that ensures that your navigation app is accurate. But if you're making an app like a weather app, is the weather really going to be different between where the user is and 100 meters down the road? So you can probably go for something like 100 meters or kilometer. So after a bit of testing, we found that accuracy 100 meters works best for the Open Weather Map API. So we're going to choose that particular option for our Klima app. But just remember that this is something that you always have to specify if you want to get the location data and to choose the option that's best for the job. So the last thing that we're going to do is we're going to get our app to ask the user for their permission in getting their location data. So remember when you first installed Google Maps or an app that needs your location data, there's this little pop-up that asks you for your permission to give the app your current location. And that's what this line of code is going to do. So we're going to write location manager dot request when in use authorization. So there's two options here. You can either request for always authorization, i.e. when you need the user's location data when your app is in the background, or you can request when in use authorization. So usually users are a little bit more wary about giving always authorization because it feels like the app is constantly spying on you. So unless you need that feature for a specific use case, always use the request when in use authorization. And this is the method that is going to trigger the authorization pop-up.